Hello everyone, welcome to the Dilip IT Academy channel. Now this Java 8 features session contains all the features which are introduced as part of the Java 8 version. And if you are following this entire session, definitely you will become master with respect to the Java 8 features with respect to programming point of view as well as making answers in interviews as well. See now about the entire Java 8 features one by one. Java 8 futures. When Java 8 is released into the market 2014, they came up with lot of new features as well as they enhanced existing features also. So until Java 8, like before Java 7, the way we are doing the Java program is different, and from Java 8 onwards, the way we are doing programming is changed drastically when comparing with Java 7. It's all about because of the new features which are introduced in Java 8, and then onwards Java 8 features are got popular because there are so many features added in the Java 8, and those are all completely irrelevant when comparing with the Java 7. So now we will try to understand one by one what are the new features they given as part of the Java 8 version, and we will understand the real use of every Java 8 feature with respect to application development as well as interview oriented. Now, as part of my first session, I chosen a concept called as default and static methods. So in an hierarchy, I would like to follow every session, and as part of that, so I chosen default and static methods inside the interfaces. So now as before the Java 8, so until Java 7, we have a concept of interfaces, but we don't have a concept called as writing implementation methods inside the interfaces. So that means until Java 7, we have only abstract methods definition inside the interfaces. We cannot write down any concrete implemented methods inside the interfaces in any way. But from Java 8 onwards, they are given a new feature called as default and static methods inside the interfaces. So the idea behind default and static methods inside the interfaces is we are going to explore now. And if you see my agenda now, so what we are going to do, I'm going to explain you what is default or static methods inside the interfaces, as well as I will explain you the importance of default methods in interfaces, like where you have to define default methods, when you have to define the default methods, and as well as Java team is saying like they are achieving the backward compatibility when they are using the default methods. So we will understand what is the meaning of backward compatibility when we are using default methods inside the interfaces. And as well as we will understand couple of use cases of default methods inside the interfaces as part of our examples level. And then finally, we will move to the static methods and what is the difference between a static method declared inside the class and inside the interface also we will have a overview. And then finally, we will discuss default methods over static methods, like what we have to define at what time and all. We will take couple of scenarios, and then I will introduce or I will show you some couple of predefined default or static methods which are given from the Java 8 version onwards from our predefined interfaces where we can identify. So a couple of examples I will try to show here. Okay, so before going into default and static methods inside the Java 8, so let me give you a overview of until Java 7 what is happened. So until Java 7 generally we used to write down interfaces, right? But inside interfaces we don't have any way we can define implementation methods. So that means in interface we used to define always abstract methods. So now I taken a Java 7 project and I created a interface and I just added a couple of abstract methods, nothing but where providing any implementation, and if any class is implemented this interface, then those classes has to provide implementation to these methods. So that is the contract of interface versus classes, and that's the purpose we use to create generally interfaces in our applications. Now, with respect to Java 7 version, now what I'm trying to do, I'm trying to add or I'm trying to make sure couple of methods we can providing logic also. So if you see here, if I define a regular method, a instance method, so it is trying to say like these abstract methods do not specify a body. So that means Java 7 version is saying like we cannot define any implementation methods. Even if I am trying to make this as a static method also, okay, in classes generally, even until Java 7 or even Java 7 also, we can define static methods. But when I'm trying to make sure a method has static in interface also, it is trying to give same compile time error exception, like we cannot define anything with the either except public and abstract modifiers, we cannot define statics. So that means what is the outcome here? It is even we cannot define static methods until Java 7. Even if I am trying to make sure like default method also, there also it is going to give you same methods, like default methods are allowed only 1.8 or above onwards. So that's what I'm in Java. Until Java 7, we can define only abstract methods and there is no way to provide any way providing implementation methods. Okay. So now let's do one thing, and I'm making this project as a Java 8 project now. So understand how the things are changed from 1.7 to 1.8. So now see, even the Java 8 version is allowing now to write down our default methods. Writing the default methods. So even I can define static methods also inside the Java 1.8. So now let's make a couple of points around the interface, and then we will take couple of default methods in the interface and we will understand the functionality of default methods. So point number one is, as part of interface, we can define any number of abstract methods. Any number of abstract methods. Even we know this point, right? So we can define any number. Similarly, we can define any number of default methods also inside a interface. So there is no limitation like we have to define only one default method for one interface. Like that, we don't have any limitation. So let me take one interface and let me define couple of default methods, and let's implement that interface from the class, and let's understand how the default methods are able to access from a implemented class. Okay. Now I created an interface inside our Java 8 project and I added couple of abstract methods. So that means we don't have any logic implementation for these methods. Now I'm writing a default method or more than one default method inside the interface. So how to create default methods is how to create default methods. So here we just need to add a default keyword in front of the implementation method or whatever the method we define. For example, if I defined a method like void default method 1, something like this, then how can I make sure this method has a default method? So only thing is we have to add a default keyword in front of the method return type. Then you can write down, provide any logic as part of this method, whatever you want. So now I'm just writing a couple of sysout statements here so that we can see these things should be printed when you are accessing from the class implemented class level. So, and I told you one more point, we can define any number of default methods inside the class. So for example, let's create one more default method inside the interface. So I'm making this method name as method 2, and even I'm trying to make sure the return type is also different for the default method. So, and let me make sure a couple of changes in the body also so that we can understand very easily how it is implemented. So now the return type is string. So that's why I'm just returning a string from here also as a result. So I'm just writing the method name as a return value here, and we will see how these default methods are accessed from the implemented class now. So now finally, with respect to Java 8 point of view, I created two default methods inside the interface without any compile time problems. So this is how we are going to define the default methods. Now let me write down a class which is going to implement this interface. So I'm writing a class 1, okay, and what I'm trying to do from this class 1, I'm implementing the interface one. I'm implementing the interface one. Yes. Okay. Now see here, immediately we know the concept. We have to override the abstract methods generally. So that means we need to provide logic for the unimplemented methods. So there are two methods available, abstract methods. One is print names and second one is get names. So we are just trying to implement these two abstract methods inside the our implemented class. So this is all we know. So let's write down a logic for these methods also. So you provided implementation for the abstract method. It's all about implementation of abstract methods inside a class. Now, if I want to access the default methods logic from my class, what we have to do? So what we have to do is let's create an instance for our class and then we will try to access the defaults method from the interface. I'm writing one more class so where I can test all the functionalities, testing default methods. Okay, I'm just taking a main method here and let's do what I'm doing now. So I'm just creating an object for the class 1 and okay, so 1 is instance name I given new class 1. Okay, fine. Now let's see, I'm able to access the methods from the class what we implemented called as print names and get names, as well as if you see here we can access the default methods what we defined in the interface level. So like if you observe here default method 1 and default method 2, so you can call by using the implemented class object. So now I'm doing, I'm calling default method 1 and similarly I'm calling the default method 2 also. So it is providing return type as string. So let me take even the string return value also. So now this is how we are going to access the default methods of an interface from the implemented class object. So it is always possible with respect to implemented classes only, but if you want to access default methods of an interface from non-implemented class, there is no possibility. So now even you can call your own methods like what we overridden inside our class also. So something like get names, print names, even we can access those methods along with our default methods. So yes, this is how you are going to access the default methods from implemented classes. This is always possible from the implemented classes. So let me execute this now and let's see what is happening. The methods are getting executed or not from the interface. We need to identify here now. So if you see here, yes, the method is implemented from the interface, the method is implemented from the interface, and one more method what you written in your own class implementation, getting method names, that is also printed here, right? So this is how we can access the default methods from our implemented class. Now if you define one more implemented class also from the same interface, yes, you can access the same default methods from the another class also. So let me define one more class 2, and I'm trying to implement same interface again. Implements same interface again here. So interface 1 I implemented. So now go, yeah. So anyway, you have abstract methods inside this interface. So definitely as a contract, you have to 100% implement abstract methods. So now what I did, I'm just writing a couple of sysouts here also. I will write down something like class 2 d4, class 2, something like that. Okay. So this is how you overridden what? Abstract methods, not default methods. Now can you access default methods from the class 2? Yes, we can access from the class 2 also. So let's do create object for the class 2 also, class 2, and creating instance name as 2 and new class. Okay, so now let's see, can I access the default methods from the class 2 also or not? Yes, you can access default method 1. Similarly, even you can access default method 2 also from the second implemented class objects. Now, as usual, you can call your own implemented methods also what you defined inside your class, like something like print names or whatever the methods we define, we can call those also. So here also we accessed default methods. Yeah. Now I'm executing this example and let's observe the console output now. So see, we can access the default methods by using our implemented class objects directly, and we can see the execution of default methods from individual object level, right? So as of now, we access the default methods by using the instances. In case if I have a use case like, can we call the default methods of an interface from our own implemented methods manually or not? Yes, if you want, for example, if you want to default method 1 from this method, yes, if you want, you can call it. So see here, I can directly access the default methods from our own implemented methods of the class. The own methods of the class from the own methods of class, yes, you can access wherever you want directly those implemented methods. Yeah. Okay, so this is also one of the use case. So what we did here, accessing default method from our own, class own method. Okay, yes, we can do that. Okay, so that means whenever we call this method internally, it will go to the interface and then it will execute the default method from the interface, and then the rest of method will be executed. So we can, just like we will call our instance methods of our own class, in same manner we can use default methods inside the implemented class objects. So this is what we implemented as of now. So what we did, we created one interface, and inside interface we return two abstract methods and we return two default methods with method implementation. Now, and immediately we define two implemented classes for the same interface, like class 1 and class 2, and we've overridden the logic of abstract methods inside the class 1 and as well as class 2 also. But here again, with respect to default methods, we were able to access default methods logic from our class 1 and class 2, and we created objects for the class 1, and finally we created object for the class 2, and we were able to access the default methods directly from the interface, instead of again we are writing same logic in class 1 and class 2. So what is the advantage of the default methods now you can understand? So understand, tomorrow if you have more than one implemented classes for one interface, like it might be 10 to 15 or whatever it is. So instead of you are defining same logic in every implemented class level, we are centralizing logic at one place and we are directly accessing that logic into every implemented class object level. So the benefit of this is all about, tomorrow if you are making any code change or when you are making any functionality change in the default method level, so it is automatically reflected at every implemented class instance level. So you don't need to separately maintain a same logic in different implemented classes, and as well as you don't need to write down the same logic and we don't need to update the same logic at every individual class level if you are going with the default methods implementation inside the interfaces. So this is the main agenda of Java 8 default methods feature here. So to avoid same logic being written inside the implemented classes level. So that is one advantage. And one more advantage, what is the one more advantage with respect to same default methods? Here it is. So what Java 8 team is saying here, so assume you already implemented interface 1 and you return couple of classes from the same interface. Assume you are having like 4 to 5 implemented classes from the interface. Now tomorrow, if you don't have a concept of default methods, then if I added a new abstract method inside the same interface, I added third abstract method. So then what will happen? So this immediately what we have to do, every class has to provide implementation to this third abstract method. So as a contract, otherwise what will happen? you will get compile time exceptions, nothing but our application functionality will be broken in case if you are not provided implementation to this third abstract method what you added in the interface level. We are forcefully providing implementation for third abstract method what we created in interface level, and we have to implement it every class level. Now, in case if you feel like the logic is common for across multiple classes, and if you made the third functionality whatever you defined as abstract method, if you defined it as default method, if you defined it as default method instead of abstract method, then what is going to happen? You no need to force, I mean, we are not at all forcing to the implemented class objects to to provide implementation again for the new functionality or the new feature what you added as part of the interface level. The reason is what? You are having direct access into your implemented classes when you define it as default methods. So this is what they are calling it as backward compatibility. So what is the meaning of backward compatibility? Here it is. So what is the meaning of backward compatibility? Here it is. They are saying like we are not at all worrying with respect to implemented classes. When you are trying to add a new features, we are just making like it is available to every implemented class by applying that functionality as a default method inside the interface. Now that's all. So say every class object or every class can access the new functionality which is added as a default method inside their own classes. If they are having dependency of this feature, they can directly access into their respective logic level. So that is what they are saying it as backward compatibility here. Here, the backward compatibility is saying a functionality called as we are not at all making code changes at all implemented class level forcefully. We are just making code change at only one place called as interface level, and we made it as default method so that it is applying to the all implemented classes objects the same functionality. So this is how they are saying like they are preserving the backward compatibility when they are using default methods, and this is very useful with respect to when you have more than one implemented classes from the same interface. So then your default methods are going to help us to reduce lot of logic and centralizing the logic so that in future the maintenance of application will become very easy. Okay, so now the next use case is what I'm going to discuss now. The next use case is, so can we override default methods inside the our own implemented class or not? For example, assume you have a default method logic implementation in the interface, but at your own class level you don't want that method and you want to override the method, or you want to extend the default method which is defined the interface level. Yes, Java is allowing us to override the default method inside our own implemented classes. So that means what I'm trying to say here it is, we can provide our own logic for the above default methods inside our class level. So then what will happen whenever you are calling the respective method from the class 1 object, so it is always going to give priority to our own implemented method at class level instead of interface level. So if you are overridden default method in our own class, the priority is always given to the own class implementation level instead of interface default methods. So the summary point here it is, yes, we can override default methods inside our implemented class. So let me have an example for that also. Yeah, now see in our interface we have two default methods. One is default method 1 and default method 2, right? So what I'm doing, I'm trying to override this method inside our class. So from the class 1, I'm just overriding the default method 1. Okay, if you see here, I taken same method signature and I made it as public method so that the scope is visible to outside of the class. Just updating the system.out.println with a different message so that we can see now which method is executed when you are calling default method 1 from the class 1 object. So as per our explanation, it is going to give always priority to the current class method instead of the interface method when we are overriding the default methods. So let me execute now. So go and call See, now I created object for the class 1 and I'm calling default method 1 from the class 1 object. Earlier we used to see output from the interface method, but now observe the output or the execution is happening from the class level default class level method, whatever you give it. So what we can say here, we can override the default methods in our class when you want to customize the logic apart from the interface method. Okay, so that's all you have to do. Yeah. So now I'm taking one more use case. So as part of this use case, when we have two interfaces and two interfaces contains the default methods. So can we access those default methods from more than one interface from a class or not? Yes. In general, generally, when we are using class and we are implementing the interfaces, at a time we can implement the multiple interfaces, right? So similarly, when you're implementing the multiple interfaces and those multiple interfaces contains different default methods, can we access everything into our class level or not? Yes, we can access everything. So let's have an example for that one also. Okay. So here I'm going to maintain two interfaces this time, and from the two interfaces, like I'm going to define one class. Okay. And then I will try to access the default method which is given here. Okay, so something like if I created one more method called as M3 and one more method called as M4, something like that. And these are all default methods again. So here it is all about my class. So it's a class. So I'm just implementing from the couple of interface. This is also implements. Okay, so this is all about interface 1. So now the use case is when you are having a class which is implemented from two interfaces, yes, and at the same time every interface is having their own default methods. Can we access these two, or can we access default methods of both interfaces in the same class or not? Yes. Yeah, by default we can access the default methods belongs to both interfaces into your implemented class level. So let me make an example for this one also. So what I'm doing, I already have a interface called as interface 1, right? So let me define one more interface and let's take a class is implemented from these two interfaces. And so now I have created one more interface like interface 2, and I created a default method 3 inside the interface. So what I'm doing now, I'm creating a new class and I'm going to implement interface 1 and interface 2 from the new class. So let me take a new class now. So class 3 I'm taking, and I'm making sure this is implemented from both interfaces. One is interface 1 followed by interface 2. Yes, interface 2. So definitely we know that we have to override the abstract methods from the interfaces, and even interface 1 will contain some abstract methods. So I just provided logic for those methods here. So these are all abstract methods. Now our agenda is getting access of default method of interface 1 and interface 2 by class 3 object. So whether it is by default possible or not when you are implementing more than one interface. Let's go here and create an object for the class 3. See, I'm creating an object for the class 3. Okay, so let's access now the methods which are default methods from the interface 1 and interface 2. So if you see here, yes, we can access the default methods from more than one interface when your class is implemented from more than one interface. So you see default method and one default method 2 belongs to the interface 1, and at the same time the default method 3 belongs to the interface 2. So this is interface 2 method. The above two are interface 1 methods. Interface 1 methods. Right? So yes. we can access default methods from the multiple interfaces when you are implementing more than one interface. Okay, cool. So now I'm going to take one more use case. Now with respect to same use case, if both interfaces contains a default method with same method signature. For example, assume I'm taking a method called as ABC method, and assume even the another interface also contains one more default method with same signature but different logic. So then what is going to happen with respect to implemented class object? So what is the use case here? When interfaces are having same method signature, when interfaces are having same method signature, how class object will decide which method has to be executed? Because when it is looking into the parent level like interface 1 comma interface, now generally which ABC method it has to call. So when you are trying to call ABC from the class level, then which ABC has to be executed here, either this one or this one. So it's a ambiguity problem, so it's a confusion, right? So then we are going to get a compile time error in this specific scenario when especially the interfaces are having same method signature of all both default methods, in default methods, and when you are implementing both interfaces at a time from one class, at our class level when you are trying to access default method of same method signature, then you are going to get what? A compile time error. So then what you have to do? So to avoid this compile time error, or even I want to execute one of the ABC method based on my current requirement. So what I have to do as a solution, here it is. So as a solution, what we can do here it is that Java 8 is suggesting us we have to override, okay, override same method in our class implementation also. Class implementation also. Okay, so in our same class implementation also. Now again here I can take one more use case. Okay, I'm going to override method inside my class. That is fine. But I want to execute the logic which written as part of the interface 1 ABC method. I don't want to repeat the logic again as part of my override. So then Java is given one more way how can you access the logic of either interface 1 ABC method or interface 2 ABC method is with respect to overriding method. What you have to do is in the overriding method body level, you have to use the interface reference like interface name dot, and you have to use a super keyword, and then you can decide which method has to be executed as part of this overriding body level, overriding method implementation level. For example, now my requirement is I want to execute interface 1 ABC method. Then what we are going to do? So simply you just define like interface 1 dot interface 1 dot super and then ABC method name. If you given, then yes, you are giving very clear instruction to the JVM. Please go and execute ABC method from the interface 1. Now in case if a requirement is all about executing ABC method from the interface 2, then you will give like interface 2 dot super of ABC. Or sometimes in case if you want to execute both methods at a time, then also you can what you can do. So in case if you want to execute both one by one, then repeat same steps as part of your overriding method level. Interface 1 dot super of what? ABC, and similarly interface 2 dot super of dot ABC. So either of the scenarios you can utilize as part of your requirement level. So this is how, when you are having ambiguity problem and whenever you are getting compile time error, what we have to make sure in this specific scenario is, it's all about the solution is overriding same method in our class implementation level. That's the solution here to avoid this ambiguity compile time problem. So let's make same example as a practical once again. So what I'm doing here, I'm going to create a new method, or let's do, I have interface 1 and I'm going to create a method, a new default method called as method 5, something like, or method 5. Yeah, I will take like method 5. And what I'm going to do, I'm going to define same method signature inside the interface 2 also. Okay, but with different logic. Now I'm defining method 5 inside the interface 2. See, I just defined same method signature I have, same method names I have in interface 1 and interface 2 level. Now go and verify in the class 3 what is going to happen. So immediately the JVM is saying like, you are having duplicate default methods called as default method 5 with respect to two interfaces, then you cannot execute or you cannot compile your program. So then what Java is suggesting us, or what we had a discussion, we have to override immediately with the same method signature in the current class also. So that is what, even you can see the suggestion here, override default method in interface 1, override default method in interface 2. So that means I will tell you what is the meaning of interface 1. See here. So if you go here, yeah. So what I told, if you want to execute a logic from the interface 1, then you have to go with this approach. If you want to execute only logic from the interface 2 method, then you have to utilize super keyword and you have to use the interface name dot super keyword. So you have to use interface name dot super dot the respective default method name you have to use. Yes, in case if you want to override both, or sorry, in case if you want to execute both methods at a time from the overriding method, yes, see here what I'm doing, I'm writing interface2 dot super dot what, the method default method 5 I'm accessing. Only thing is what we made here, it is, this is all about the thing. So we've overridden at our class implementation. Then when you are calling, now go and verify the logic calling from the third class object. 3 dot default method 5 you are going to call. So then as per our previous discussion, it will always execute it from our class. Now it will go to the class and it will execute first a method from the interface 1 and it is going to execute a method from the interface 2 also. It's all about our requirement, whether which default method we have to execute or both at a time, whatever it is. So let's see the output with regarding this last line what we added now and the current scenario. If you observe here, it is executed inside interface 1 default method 5, inside interface 2 default method 5. So that is how you can avoid the ambiguity when both interfaces or more than one interface is having same default methods. When you are implementing a class from those interfaces, you have to go with a solution called as overriding inside the class. And out of that, if you want to execute a specific interface default method, then again you have to take help of super keyword interface name dot super keyword, and that respective default method you can define as part of the method body, so that internally JVM will execute that respective methods when you are calling your default method from the class implementation. Okay, so that is all about to avoid the confusion or ambiguity problem when same method signatures available of default methods when you are implementing more than one interface. So now let's talk about the static methods inside the interfaces. So generally, even we have static methods concepts in classes also before Java 8, like until Java 7, even after Java 8 or Java 8 onwards also, we have static methods in the classes. So same kind of concept of static methods is also introduced as part of the interfaces. So that means along with default methods, we can define static methods inside the interfaces. So that means we are going to use a static keyword when we are defining the concrete implemented methods, and then we are calling those methods as the static methods. So how many static methods we can define is all about? Yes, we can define again any number of static methods inside the interface. Then Java is already given a concept of called as default methods inside the interfaces to provide the implementation of a requirement, right? Then why again interfaces given a same kind of concept called as static methods? Then what is the exact difference between default and static methods, and how static methods are going to work, and why when we have to go for default or static methods inside the interfaces? Let's have a look here. So first, let's straightforwardly we will discuss about the static methods. Then we will discuss at what scenario we are going to use either default or static methods inside the interfaces point of view. Now, in our existing interfaces, I am adding static methods, and we will try to access static methods from the implemented classes. How we are going to access, we will have a look here. So I'm writing by using a static keyword, we are defining static method, and after that the regular way however you are providing the methods implementation, we can provide the implementation. So I'm just making sure method name as something like static method one something. Okay, so and then here I will just write down sysout static method, and here I'm going to return a value because the return type is string. And even so, this is all about, this is static method something. Okay, so fine. Now similarly, how many we can define? We can define any number of static methods. So I'm writing one more static method now. So in the same interface, and see here I'm defining static method, and I'm this is all about, I will make it as void just to make sure different method signature and method 2, and I'm also going to write down no need of return statement because void. Fine. So total two static methods I have been implemented as part of my interface one. So this static methods were written as part of what? Interface level. Now let's take a class and try to access static methods from the class. So how we are going to access static methods now? So what I'm doing, I'm trying to take a new class in this specific scenario called as class 4, and I'm trying to access all the static methods. Okay, so again, yes, it's all about implements the respective interface, and okay, I'm taking interface one where we provided the implementation of static methods. Now again, you just need to take care of abstract methods. It's like as usual, and similarly you have to provide implementation for the other abstract method also. So let me provide abstract method implementation, and we will try to return something. So now I just implemented the abstract methods from the interface one, but at the same time I want to access static methods by using our class 4. So how we are going to access? Let's see here. I'm going to create an instance for the class 4 now, and I'm trying to access the methods of static from the class 4 instance. So accessing static methods. So that is what I'm trying to do now here. Now I'm just trying to access the static methods of interface 1 by using class 4 reference. So for that what I'm doing, I'm writing or I'm creating an instance for the class 4. So now I'm trying to access static methods from the interface 1 by using class 4 reference. So for that I have just created class 4 reference, and I'm trying to call the static methods from the interface 1 now. So let's see here 4 dot, and let's find out whatever the static methods you return. See, it is not at all suggesting us to call the static methods from the interface, sorry, from the class reference, which are belongs to the interface one static methods, right? So that means we cannot access the static methods by using the implemented class references. So if whenever you have a need of executing static methods of interface, then we have to take the interface name to initiate the static method execution. So that means here we have a rule generally. The rule is static methods don't belong to any particular object. So what is that? Static methods. So generally in Java, we have a concept like static methods, particularly not belongs to any object. So that means we cannot initialize static methods generally from the object's point of view. So by using this statement in interfaces, when you are defining the static methods, what it is doing, we cannot use class references. So when you want to initiate, you just need to use the respective interface names. Okay, if you see here interface one dot, and I can access the respective static methods whatever I want to call. So what is the point we made here? We cannot initiate or we cannot call static methods by using the class references which are the implemented classes. So if you want to access, then again you have to take help of interface name. So that why it is happening, because static methods are nowhere belongs to any particular object. So that is why they are not at all part of any time the class implementation. They are always part of interface implementation only. But when it comes to default methods are becoming part of class implementation or class methods level. So default methods are becoming a set of methods with respect to class API methods. But when we cannot consider static methods as a implemented class API methods, because those are all just private properties belongs to the interface. You cannot access from the class point of view. So now even in the class methods, for example, you want to call a static method of your interface, then here also you cannot call directly the static methods whatever you defined in your static. Okay, so whatever you defined inside the interface, we cannot call the static methods directly. So in this case also, you have to take the interface help like interface one dot, whatever the static method you return. So now you can access like this. Okay, so now you can understand the difference between default and static methods. Okay, anyway, we will verify that scenario also. Okay, so now we just understood how to initiate static methods execution when we are using a class from the implemented interface. Okay, so let me execute our example now. So see here, yes. Only thing is what we understood, we cannot reference static methods by using the implemented class object. You have to take help of always interface name to initialize the to initiate the static method execution in any place. So just summarize couple of points related to static methods inside the interfaces. So what I'm just trying to say here, assume you have a interface A and interface B, and you just derived a class or implemented a class from these two interfaces, like I can call it as C. Okay, now assume there is a static method available inside interface like method 1. It is a static method. Now again similarly you have same m1 method in the B interface also. So now guess, are we going to get any ambiguity problem, or are we going to get any confusion? I mean compile time error when we are defining our class C from the interface A and B, like however you got in the default methods time. So in default methods, when you have same method signature, so here the concept is what? Same method signature. Okay, we got compile time error. We got compile time error. And then what we did, we return a overridden method inside our class implementation. But are you going to get any error in this case? No. The reason is default methods are having direct access to the class instance level or class reference as a class level. But when it comes to static methods, as we discussed just before, these are all just like only functionalities belongs to the interface. These functionalities will not belong directly to the class implementation level, even though you are implementing class from these interfaces. So that means, so what generally how we got access of static methods inside our logic level. So when you have to access always something like, for example, interface 1, or sorry, I can take like a dot m1, right? So you're calling like a dot m1 as a static method, and similarly b dot m1 as a static method. Then there is no confusion with respect to static methods. That means in this specific scenario, when you are having same method signature in between two interfaces, both belongs to the static methods, you will not see any compile time error, because those are all not at all part of the class. Those are all not becoming as part of the class uh, reference, and those are all just references of the interfaces, and you are declaring very specifically, or we are executing very specifically by using interface name. So that's why you will never ever get a compile time error in this kind of situation, because the reason is class C is not at all accessing m1 and m1 from the a comma b. There is no reference of m1 either from a comma b to the c level, because static methods. So that is one point I would like to make sure here. Okay. So now let me show you some couple of predefined default or static methods. The interface is what we are aware of as of now, like list or set. Okay. So generally we are talking this concept related to interfaces, right? So when you open the list or set, what we are aware of from the util package, if you see here, you have some couple of default methods or static methods which are defined by using Java 8 default and static methods features. Okay, if you see here, there is a method available. There are one or two methods. See, there are a couple of methods available. If you see here, these are all methods related to default methods. So let me open one of the method, something like add first, add last. So if you see here, the define default method. I mean, it's all about again Java 8 feature. That is what I'm trying to say here. It is. And similarly, if you observe, you do have static methods also. So see here, nowadays we are using a method called as of method to define list of elements. Now see, this is also a static method. So this is all about the backward compatibility. Yeah, now similarly, let me open another interface, what we know like set. Okay, and if you observe the predefined methods from the set interface, even you can see a static method called as set of, like of method. It is a static method. And similarly, I can show you other of couple of, see here they given some default one default method as part of this set, that is something splitterator. Okay, so this is also a default method they started introducing from the Java 8 onwards. So that means, what is the point I would like to make here? It is, there are a couple of interfaces from our collection API, and those are already introduced along with predefined default and static methods as part of the interfaces. Okay, so and at the same time, yes, nowadays it is being used more and more in real-time projects also. When we are working for the any requirements, we are using default and static methods inside the interfaces. This is all about static and default methods inside the interface as part of Java 8 features. Right now, I'm going to discuss functional interfaces and as well as Lambda expressions. These concepts are being introduced again as part of Java 8 version, and still those are all we are using on daily basis in our day-to-day programming, even in the latest Java versions also. So we have to understand the real importance of functional interfaces as well as Lambda expressions. The reason is, nowadays the way we are doing the programming by using Java programming language is completely changed when comparing with the Java 7 and before the Java 7 versions. Until Java 7 version, most of the times we used to provide a programming called as imperative programming. So, but when Java 8 onwards, people are started doing the declarative programming, with the help of functional interfaces and as well as Lambda expressions. And at the same time, by using Lambda expressions and functional interfaces, we are going to achieve functional programming also as part of our Java programming. So we will understand what is the real meaning of functional programming as well as declarative programming as part of this session. Before that, we have to get a knowledge of what is a functional interface and what is the Lambda expression and what is the relation between functional interface and as well as a Lambda expression. So where we are going to use Lambda expressions with respect to functional interfaces, we will try to have a knowledge in the current session, and then we will try to see a lot of other use cases, how we are achieving the functional programming and how we are achieving the declarative programming with the help of functional interfaces. Now let's start discussion about the functional interfaces. So now we have to understand first of all about the interface versus functional interface. So if you take in the interface in general, okay, we can write down any number of abstract methods. So what is the point here? Any number of abstract methods we can, okay, and as per our previous session, even we can provide n number of default methods also we can provide. Even we can provide n number of static methods also we can provide, right? So then this is all about a regular interface. Yeah, now we will define a class and we will implement the above interfaces. Generally, we will implement the interfaces by using our classes, right? And we will provide implementation for every abstract method. Then we will execute the functionalities by using object for the class, whatever we implemented. Now, when it comes to functional interface, what is the definition here it is and how we are going to define the functional interface now. An interface which contains only one abstract method, and those interfaces we can call it as a functional interfaces. So that means, what can I say if I want to call an interface as a functional interface? So what are the rules we have to follow here? It is, as part of the interface implementation, must and should we have to maintain only one abstract method, and we can maintain any number of default methods as well as static methods inside the interface. So what is the condition compulsion here? So we should maintain only one abstract method. So that is what the difference between an interface versus the functional interface in declaration level. So you have to define only one abstract method in this specific scenario. So what is the purpose of this one abstract method and all? We will try to understand. And sometimes the same functional interfaces will be called as SAM also. So that means it contains only one single abstract interface here it is. In case if you are not following this one abstract method rule as part of interface with respect to functional interface, okay, then we are not going to call that interface as a functional interface. An interface should not contain zero abstract methods, at the same time should not contain more than one abstract method. So it should contain always only one abstract method. So to define as a compilation rule point of view, so the Java language provided a predefined annotation called as @functional interface. What it is? Functional interface. So that when we are added, it's a volunteer annotation. So that means when you maintain, for example, if you take an interface something like that, only1, okay, and you maintain only one abstract method as part of the something like m1, yes, you no need to add @functional interface mandatorily, but you can achieve the functional interface functionalities for this one interface point of view because you contain only one abstract method here. Yeah, in future, if you are trying to add another abstract method inside the interface, yes, with respect to interface wise, we will not get any compilation problem or anything else. The reason is an interface can contain any number of abstract methods. But at the same time, functional interface point of view, we should not allow more than one abstract method. So that's the purpose. We can define this annotation at our interface implementation level. So what I did now I added this functional interface annotation on top of the annotation on top of the interface declaration. So what will happen now? Now, when we are not maintain even single abstract method also, it will throw a compile time error. Even if you are maintaining more than one abstract method also, it will show you as a compile time error, and it will force us to maintain always only one abstract method to achieve the functional interface functionality. So that's why it's always recommended to use @functional interface on top of interface declaration when we are considering that interface as a functional interface. So now let's discuss about the functional interface implementations, like how we are going to provide implementation for the abstract methods. Generally, the idea behind functional interfaces implementation by Java team is we are going to use Lambda expressions to define the implementation of the single abstract method which is available as part of the functional interface. So that means now we are just making the implementation of single abstract method as an expression instead of again we are defining one more a separate class which should be implemented this interface and providing implementation for the abstract method. So that means by using Lambda expression, we are making implementation for the functional interface method, and we are using that expression as a statement anywhere else. Like we can use that statement or that expression, Lambda expression, as part of our variable initialization, as well as even we can pass the Lambda expression, okay, as part of method arguments level. Even we can define any number of implementations for the same interface with number of Lambda expressions also, and we can use wherever we want that implementation as an expression. So it's just like precisely it is reducing lot of implementation steps and making it as a just like a expression point of view, so that internally even compiler is not at all going to worry about the conversion of dot class file with respect to the interface implementation, because it's a simple statement. Like however we are writing as generic statements like integer a equal to b plus c, something like that, it is also kind of a statement. So let's focus on Lambda expressions also, and then we will see how we are going to use Lambda expressions to initialize the functional interface methods. And then we will discuss couple of use cases as part of functional interface, and we will see how we are going to generate couple of Lambda expressions as part of the functional interface implementations. So now let's start making some practical things around functional interfaces and then followed by Lambda expressions. Okay, now I'm just creating a interface called as calculate is the interface. Okay, and then what I'm doing, so this is a interface. Okay, fine. And then what I'm doing here, it is I'm adding a abstract method followed by something void print name. Okay, something I just added a abstract method here. So as part of functional interface definition, we understood always like functional interface should contain always only one abstract method, and we maintain only one abstract method. Now can I call calculate as a functional interface? Yes. Now it is a functional interface. So when you are maintaining an interface with one abstract method, yes, definitely this functionality, this interface will give you all the features or functionalities related to the functional interface concept. But the problem here it is when you are leaving like this, in case in future, if you are adding anything like, okay, something I'm adding one more abstract method here, okay, and then what will happen? As a regular interface point of view, you will not get any compile time error. But at the same time, it's breaking functional interface functionality or concept, right? So to avoid this problem, so Java 8 provided a new annotation called as @functional interface. So what is that? Functional interface, and you just need to define on top of interface level. Now see, the compiler is saying an exception, invalid functional interface annotation. Calculate not is a functional interface. The reason is what? You maintain more than one abstract method. So that's why compiler is throwing a exception. Now see, the exception is gone once we are removing a one of the abstract method. Even if you are trying to maintain only zero abstract methods also, then also it will fail compilation. So it is saying like this is also a invalid functional interface. So that's what is the point here. It is we have to maintain always only one abstract method, either it should not be 0 or more than 1. Okay, then finally this is all about the implementation of functional interface or declaration of a functional interface. Okay, along with this we already discussed we can write down any number of, when it comes to abstract method, only one must and should, right? But when it comes to default methods, yes, even a functional interface can contains n number of default methods. So see here, I'm just writing a couple of default methods here, and I given a session about the default methods in the previous session. That link is available in the description. Just find out in case if you want more details about the default methods inside the interfaces, even static methods inside interfaces also. So what I'm doing, I'm writing one more method, default method called as something like method one is the default method one. Okay, and then yes, let me write down some sys out here, and I'm writing like this is default method one something. Okay, fine. Similarly, how many can we add? Yes, we can add any number of default methods inside a interface. Yes, there is no restriction for that. Only thing is you have to maintain only one abstract method. That's the only compulsion here you have to follow. Now see here, I'm going to add couple of another static methods also here. So yes, we can add any number of static methods also here. So if you see here, I'm just adding method static one. This is static method. Similarly, I will add one more static method also. To prove, we can write down any number of static methods inside the class. This is static method. Okay, so this is how you can write down any number of default or static methods inside the functional interface. But when it comes to abstract methods, non-implemented methods, you have to maintain must and should one interface, one abstract method. Otherwise, you will get a compile time error. That too when we declare with @functional interface. Okay. So now let's start creating implementation for the functional interface. How we are going to provide implementation to the functional interface. Generally, what we will do in general, so we will write down a class. Okay, so something like if I'm taking a class called as camel, and what we will do, we will implement the interface. We will implement the interface whatever we did. Okay, so I just implemented calculate interface. Yeah, I just implemented calculate interface, and then I'm going to override implementation for the abstract method, right? So I'm just writing a sys out here also. This is Camel Corporation, Camel Company, Calci, something like that. Okay. So now, yes, we will create object for the camel, and then we will call this respect to implemented method from the camel class, right? So let's write down a testing class. I'm just taking it as demo, and I'm just creating a main method also here. And as part of main method, now what I'm doing, if you observe here, generally we know a formula or fundamental rule like interface can refer IMPL, that means implemented class instance. Okay, fine. So now what I'm doing here, based on the above rule, yeah, even we can directly instantiate with the class type also, but just okay, I'm taking interface calc equal to, and I'm creating an object for my class which is implemented the calculate interface called as camel. Okay, fine. Then now what I'm doing, I'm just calling the respective method from here. Calc dot get, sorry, print name, print details or something. Okay, finally now I can see the output here. Okay, So see here, this is a Camel company calculator. So this is all the old approach. This is all about regular approach, but it's not the purpose functional interfaces provided by the Java language when you are going with the regular approach. Then we can even define a normal interface with this approach also. So now here the main agenda of functional interfaces with single abstract method here it is to achieve single functionality at a time when we are implementing the functional interface abstract method. So that's the purpose they given single abstract method here in the sense it's all about single functionality implementation all the time. So to achieve this single functionality implementation all the time for the same functional interface, so Java 8 is provided a solution called as Lambda Expressions. So that means by using again Lambda Expressions, what we can do, we are implementing that single abstract method of functional interface, and it, as well as we are creating an instance of an implementation. So that means here with Lambda expression, we are providing implementation for the abstract method as well as at the same time, we are initializing that implementation with a reference also. So the entire thing will be called as Lambda expression. So before creating with Lambda expressions, let's understand the syntax as how we are going to create the Lambda expressions. We will create methods with parameters, as well as second type we will have what? Methods with no parameter. Methods with no parameters also. So that means here it might be more than greater than one parameter. Here it is equal to 0 parameters. So if you have more than one parameter, so how the syntax is going to looks like? For example, you have to write down the number of parameters what you have to define here as a variable names. So you have to define a parameter names here. That means the number of parameter names you have to define here and followed by the a array token you have to define here. So that means what you are trying to do here. This is all about the syntax now I am writing. Okay. So if you observe here, this is all about the syntax I am writing. And as part of this, after the arrow token, you are going to define body or code block. We can call it as the body of method implementation or code block of this abstract method implementation. Okay, so and followed by the semicolon. So here the code block representing any number of lines. So you can write down any number of lines in between curly braces. So this is all about the syntax of when you have more than one parameter inside the abstract method. But when you define abstract method with 0 parameters, then what you are going to do? So you have a syntax called as same syntax, only thing is we will define 0 parameters here. So that means no parameters you will have, but at the same time you will provide the implementation or code block for that respective abstract method. So here you need to understand one point very clearly. If I taken this approach, so whatever you written in between the curly braces, the code block, whatever I'm taking here, so this code block is really representing the abstract method of functional interface. So that means what I'm trying to say here it is, if you see here, so when you take in functional interface again, so this is the functional interface we defined, right? For example, inside this interface, yes, we define one abstract now. So let's take this method now here. So this is what the method we defined as part of the functional interface. Right? Now, yeah. So if you take in here, now we define a method, abstract method with 0 parameters. So in such case, we can provide lambda expression in this way, and even we are going to write down the lambda implementation in such way. In case if this method is having parameters, yes, we can go with this approach or this syntax here. Now, whatever the logic we are writing as part of the code block, okay, here or here. So that is all implementation for this abstract method. So this is all about the implementation of the abstract method. So now along with this, what we are going to do, so how I'm going to write down the lambda expression, here it is. We have to take the lambda expression data type, okay, the functional interface data type. So that means I'm taking calculate, and I'm going to take a reference variable here to represent the entire implementation and equal to. So see here, I don't have any method parameters here. So that's why I taken 0 parameters as part of that. And I'm going to write down the body inside this, like, okay, so whatever the logic you have to write down, you have to write down as part of here. So now I'm writing a simple SOP statement in case if you assume, if I written a lot of logic here with respect to this body, it is going to, yeah, logic implementation we are going to do here. So that means this is all about the writing lambda expression for the interface called as functional interface calculate, and here it is representing the abstract method parameters, method parameter, number of method parameters, and this array token, this is called as array token. So this array token is representing the implementation of this abstract method. Now this overall, it's nothing but I can call it as like whatever logic we provided earlier. So this is nothing but is equal to this one. So in case if you taken in earlier scenario point of view, whatever you taken, okay, so if you observe here, this logic whatever you written inside the curly braces, this is nothing but you are providing an implementation like this indirectly with the help of lambda expressions. Now see how I am defining inside the class for the same calculate interface inside the my main method by using lambda expression. So I am using now lambda expression implementation. Okay, fine. So what is the rule we have to follow here? We have to take the interface name here. So my interface name is calculate, and you can define any reference variable here to initialize the we can define any reference variable here to instantiate the functional interface implementation with the help of lambda expressions. So now I'm writing 0 parameters, yes, and at the same time I'm going to write down the entire logic inside the curly braces. So here I can write down any number of lines, whatever the logic you want to perform here. So this is camel company, something like that you can write down, okay, or you can take like something ABC. If I take in here, I'm just writing like ABC company here. So now understand here, you provided implementation nothing but indirectly like this. For the print name, however, you written a separate class with by implementing the interface, you provided the logic, right? So it's nothing but indirectly you are providing same thing inside the curly braces. And as well as what we are doing, we are initializing implementation of functional interface with a reference variable with the same functional interface type. So now similar to this, I can define any number of lambda expressions for the same functional interface with different scenarios. For example, if I take now XYZ, yes, this is XYZ company. So what is this lambda expression implementations for the same what interface? So you can define any number of implementations or in any number of lambda expressions for the same functional interface. Now see, for example, I want to execute the implementation of an expression called as ABC. Yes, simply what we are going to do. So this is a reference now. This is becoming as a reference for the implementation provided. This is a reference of the type called as calculate, and this contains the whole implementation and instantiation of the abstract method implementation. So now what you are going to do by following the approach called as ABC, ABC dot the respective method name you can call. So you can execute your program now. Now you will see this is ABC company. And similarly now, in case if you want XYZ company, logic should be executed for the same functionality. So what you are going to do, you are going to call that respective abstract method here. So execute it, run as Java application. See here, even you can see this is XYZ company. So this is how dynamically we can provide implementation of an functional interface abstract method wherever you want. You can provide in this approach by using Lambda expressions. Okay, so I will take one more interface, functional interface, and I will define one more abstract method with method parameters and number of method parameters as well as a return type for the abstract method also. And I will discuss couple of points over there also. Okay, so now let's define one more functional interface which contains an abstract method with parameters, and as well as we will try to take a return type value also for the abstract method. Okay, so I'm defining a new interface and I'm calling it as a calc operation. So my interface name is calc operation. Okay, so even let me write on a different package also. Fine. Okay, so now let's add the functional interface annotation so that we can make sure in future it should be broken with respect to functional interface functionality. Okay, fine. So let's define a method here and let's see what I'm doing. I'm taking a return type as double and I'm taking the method name as something like operation, and I'm going to take a couple of method parameters here. So I'm taking total 2 method parameters here, integer a comma b. Okay, so I defined one abstract method now. Finally, it is a abstract method. So I'm defining a default method here. Okay, so followed by I'm just writing a return type as void print info, something like that, and I'm writing this out of this is default data of method, something like that. Okay, now I'm defining one more method called as static method. So I'm just writing like static void type of operations, this sort of. So I'm just writing like static content arithmetic operations. Some just statements we written, assume it as an implementation of default and static methods. Now let's provide implementation for the functional interface called as calc operation. So I'm taking a main method here again to test our functionality. Okay, so functional interface with params demo. So we will discuss a couple of other use cases also by using this example. Now see here what I'm doing. I'm first writing a lambda expression. Okay, and I'm just making like addition equal to. So, and I told you already, when we are defining lambda expression, when we are having abstract method with parameters, we have to take this kind of approach. So we have to define the number of parameter names as part of these braces. Okay, so what I'm doing, total how many method parameters we have, guys? In this case, total we have 2 method parameters. One is integer value, second one is also a integer value. So what you can do here, you can define inside this like integer a comma integer b. So it's not like you have to take same variable names whatever you taken in the abstract method. Even you can take different text, okay, variable names also here. And after that followed by arrow token, that means you are saying like you are providing the implementation for the abstract method. So this representing the code block of logic implementation here. So what is the meaning of it is, add a return statement. So that means now in the abstract method, we provided what? This time a return value. So that means the return type is double here. So even you have to return a double value here always. Okay. That's the, it is, you are providing the implementation here. So now here it's, you can provide sys out of the logic, whatever you want to implement as part of this lambda expression. Yes, you can provide values or something. I'm just printing some logic lies x. I'm just writing the y. So the method parameter names x comma y. So and then you just return x plus y here as an addition operator and you just return it. Now see, you provided a logic implementation with the help of lambda expression for the functional interface calci operation, and you created internally you initialized or instantiated the same implementation with a reference variable called as addition. Now what you are going to do, so let's make sure you need just trigger the method. What is the abstract method you written as part of the calci operation class? So what we return the operation. Now we are passing the real values to execute above implementation. Now I'm passing a value as first value as 30 and second value as 20. So these are real values now you are passing to execute this implementation. So that means what we are doing now, executing lambda expression. IMPL, I mean lambda expression implementation. So that means what will happen now internally, what JPA will do, whenever you are calling this JVM is executed this line, okay, so immediately it will observe what is the reference of it is. It's a interface reference called as addition, and it will observe right hand side you provided lambda expression notation. So immediately it will consider with respect to functional interface of calci operation, the abstract method you are calling it as operation. So JVM will understand like this overall logic implementation we provided for the operation method, which is having two method parameters, and even you provided a return value x plus y also. So that means you are provided a return value based on the method signature. So that is how now what it will give you. The return value is what? Double is the return value. So you just take a return reference also here. So I taken like result and let's print the value sys out of result. So it's similar to like however we are calling regular methods by using our objects, right? But only thing is you provided implementation of abstract method with the help of lambda expressions. Now execute until this. See here, you are passing the values from this line 30 comma 20, and immediately internally JVM is verifying the instance is created for the lambda expression. That means internally it is the implementation of which method? Operation method. So this block getting executed and then it is printing values are x comma y. So this is representing x value, this is representing the y value, and then you can see 30 comma 20, and whatever the return value based on the method signature for the operation you return, and that value whatever you are returning, that is what printed here. Okay, so this is how you have to define the lambda expression when you are having different method parameters. So let's see here what I'm going to do here. Can we create one more lambda expression for the same interface? Yes, I can create. See what I'm doing now, I'm going to create second lambda expression calling as subtraction equal to, and I'm providing the implementation again for the operation method which is available inside the functional interface. So how many method parameters we have to pass? Two method parameters you have to pass here. So you have to declare those method parameter names, okay, here always. Now see what I'm doing right now. I'm taking the variable names called as p comma q here, and I did not mention any data types along with the method parameter names. So I will come back and I will explain you whether it is going to work or not. First we will see and then we will understand what's happening here. It is okay. So see here again I am writing return p plus q. Return p plus q value. So what is this? Now you don't see any compile time error here, even though you are not written any data types before the variable names, before the method parameter names. So the reason here it is, I'll just explain. Before that, let me call the lambda expression. Let me execute the lambda expression. Okay, see here, operation dot. So yeah, you're doing this time. Again, let me pass 100 and followed by 50 value here. Sorry, here subtraction, right? Let me make it as minus. Okay, subtract operator. Okay, 100 and 50. So you're going to get again a result here. Okay, just refer that and let's print it. So yes, you're going to get the result in this case. So now see the beauty of lambda expressions, or the advantage of lambda expressions to implement the functional interfaces. The reason is you are making very portable code or very precise coding with respect to functional interface implementation. So what you are doing, you are having a functional interface, you are just making your implementation wherever you want as a simple expression, as a simple expression point of view, and simply you are using it. By using that expression, by using that lambda expression, you are just executing the actual abstract method implementation by passing real values. That is what you're doing. So how many lambda expressions we can create for one functional interface? In the sense, yes, like similar to, we can provide any number of implementation classes for an interface, right? Similarly, we can create any number of lambda expressions and we can execute those logics of lambda expressions with the help of the references what we created with the lambda expression name or lambda expression ID here I can call it as. Now observe here I'm doing a concept. I'm just printing the references. I mean whatever the lambda expression references you created. So I'm just printing those details. Observe what it is printing. Even I'm writing subtraction here also. Okay, so see what are the details internally Java is taking. If you observe here, what is this guys? Functional interface, okay, with parameters demo, it's a just class name. But if you observe here, we created total two lambda expressions. Okay, one is addition comma, one is subtraction for the same functional interface. And if you see here internally, dynamically in the memory level, they are creating a different lambda instances internally. Now we need to understand why we are not getting any compile time issue, even though we are not given any data types for the method parameters, like in the first approach. So in this case, Java is provided a flexible way to simplify the coding. Okay, in this case, so whenever you just taken an approach something like this. So here, generally what we did in the first lambda expression implementation, total we have two method parameters in the operation level. So in the operation, how many we have? Total two parameters we have, right? Now what we did as part of two, first one is integer and second one is also integer. So that based on this declaration, what we did, we created a variable integer x comma integer y, and those values we are using as part of the, those variables we are using as part of the logic implementation in the code block of lambda expression. Now in the second lambda expression also what we did here, yes, we created in the same manner, but only thing is here, however I provided method parameters here, however I provided method parameter data types here I did not provide it. So that means when you are writing the lambda expressions, you are good with the number of method parameters. So here you need to make sure number of method parameters are mandatory. Okay, that is mandatory. So if you have two, definitely you have to define two method parameters here. But when you are dealing with data types of the parameters, it's like optional whether you can declare or not. It's like optional. So maybe we can declare or maybe we cannot declare it. But this p is considering internally as what? Integer only. And even this q is also considered internally as integer value. So that means now internally when you are performing the operation of arithmetic like subtract operation, p is considering as integer and q is also considering as an integer value. That's why you are not getting any compile time error here. So it's like simple on your overall, it's like optional of providing method, parameter, data types when you are defining the lambda expression of a functional interface abstract method. So that means in case in future, if you return an abstract method with a parameters, something like assume you have m1 method and the first parameter is string parameter. Okay, assume second one is something like long parameter. Okay, and whenever you are writing lambda expression for this, okay, whenever you provided the lambda expression and whenever we are writing lambda expression for this, what you can do, you can directly take something like a comma b because you have total two parameters. So you have to define total two parameters here. Number of parameters you have to define must and should. Okay, and here a will be considered as a string value, string data type, and b is considering as a long data type here. So that is how internally taking a as a string and b as a long values here. And internally when you are performing the logic also, a will be considered as a string and b will be considering as a long value. Okay, so that is how you can define the things. Now I'm going to define one more lambda expression for the same functional interface. So let me define one more lambda expression here. So I'm just defining the third lambda expression here. Okay, so observe here what I'm doing now. Calc operation is the interface, functional interface, and I'm just writing something like multiplication equal to. So what I'm doing, if you observe here, again I'm taking p comma q, some method parameter variables and array. And if you observe here, I'm writing something like p into q, p multiplied by the q value here. So see here now I provided one more third lambda expression for the same functional interface, and I defined method parameter names as well as I provided the logic, but this time I did not provide any curly braces to define the code block. So the reason is when you are having only one line of code as part of the code block, you no need to define any curly braces also. Even when you are trying to return a value, we need to provide a return statement also here. So that means whenever our method signature is defined with a return value, we have to return always a value here, even though we are not provided the return keyword like this. And at the same time, if it is one line, you don't need to provide curly braces also. What we can say finally here, you can define curly braces when you have more than one line implementation, and at the same time it's not mandatory to provide a return keyword when you are maintaining only one line. Even you can directly return that value whatever the operation you are doing. So now see, let me execute this again. So I'm directly executing this time calculation. Okay, I'm just printing the result also, multiplication dot. So what is that operation, and I'm giving some value like 10 comma 20 values. So let me execute this now. Now what is going to happen? Whenever JVM executed this line, internally a lambda instance will be created for this multiplication with this multiplication instance reference for this implementation. And whenever you are calling like multiplication dot operation, so immediately the right hand side, whatever you return the logic, that will be executed. So that means the 10 value will be replaced with p, q is considering as 20, and 10 into 20, finally we are going to get 200 value here. So let's execute now. Now see, finally we got 200 values. So that means what are the points we understood here? It's all about the way we are writing the coding is depends on our knowledge, and it's all about Java is providing couple of flexibility things here to define our logic very quickly and very simply in a readability format also. So if you see here, I'm just moving all the things at one place. See, finally, at the end of third lambda expression, how many lines of logic we reduced depends on our requirement point of view. So this is how you can define the lambda expression implementations for a functional interface. You can follow all these rules when you are defining the lambda expressions. Now see here, when you are passing I'm just covering one more use case here. Like, for example, assume we know that these two are integer values. If you try to pass instead of integer value any other values, for example, I'm trying to pass a floating value here. But what is happening here? Immediately it is saying the method parameter should be integer. It should not be something, a different data type value. So you have to take care when you are passing the real values to the lambda expression. We have to pass the data types what you defined inside the abstract method parameters level. Okay. So in the introduction level, I just told like we are going to achieve single functionality responsibility by using functional interfaces. So what is the meaning of single functionality? So here it is, just focus here. Now how many lambda expressions we implemented here? Total 3 we are implemented for the same functional interface. And observe here, I written a single functionality like addition and one more functionality with respect to one more lambda expression implementation. I written one more functionality kind of subtraction, and similarly I created one more lambda expression to achieve one more single functionality called as multiplication. So that means in the overall, whatever the interface you created, functional interface, and whatever the abstract method you provided, single abstract method. So this single abstract method implementation should be responsible for a single functionality. Okay, and that functionality we are going to define by using a concept called as lambda expressions. Okay, so this is all about a single functionality responsible. And what I will do, I will make one more session, more details about the functional programming as well as declarative programming. So inside that, I will discuss again the same concept called as single functionality responsibility with respect to functional interfaces. Yeah, so now one more thing what we have to verify here it is, can we execute the default or static methods of an interface or functional interface by using lambda expressions or not? So generally when we are learning about the default methods, we know that default methods are always executed with the help of instance reference. So now here the lambda expression once we created are executed by the JVM. So this is all about a lambda reference, right? So that means by using lambda references, we can execute the default method. So what we are doing now, executing the default methods of functional interface. And I'm taking here and we return one method called as print info method as a default method inside the functional interface. So if you go and see what is the default method we return, print info method, and then this line will be printed. Now when it comes to the static method, okay, so the same rules applied what we discussed in the previous session as part of default and session static methods. Okay, so see here now I'm just trying to execute static method of our functional interface. Okay, see now you know that functional static methods inside the interfaces we can always execute via interface name, right? Because static methods are nowhere belongs to any instance in a runtime memory level. Those are all simply prop methods belongs to the interface level instead of instances level. So what I'm doing now, by using calc operation functional interface, and I'm calling the static method, whatever you return inside the functional interface level. Type of operations is a static method. So, but we cannot execute again static methods from the by using the lambda reference. The reason is there is a rule like we cannot execute static methods of interface with any instance, only executed by interface name always. Now my next point is, can we extend another interface with the functional interface or not? Yes, we can extend another interface with the functional interface, but only thing is what we have to take care here it is the other interface what you are extending from the functional interface. Okay, the other interface should not contain any abstract methods, then only it is possible. If it is contains any abstract method, the other interface, then what's happening? It's breaking the functionality of functional interfaces like single abstract method concept, because whenever it is inheriting the other abstract method, in the sense this current functional interface is also having two abstract methods. So that means it's against of single abstract method policy again. So that's the purpose. The other interface should not contain any abstract methods, but the other interface can contain only default and static methods. In such case, then we can inherit the other interface from the functional interface. So let's make a small experiment for that also here. Now, for example, if you see here, we from this functional interface, we will try to extend the previous functional interface called as calculate functional interface. So see here, even calculate functional interface is having one abstract method. But as of now, in our rule, what we discussed, the other interface should not contain any abstract method. So now see here what I'm doing, extends calculate interface. So what is the compile time error we are getting? So invalid functional interface annotation. So calc operation is not a functional interface. The reason is one abstract method from this calculate interface is inheriting into the current functional interface. So total you're making two abstract methods, then it's against of the functional interface proper functionality. So that's why you're getting the compile time error. Now, when you can extend another interface when it doesn't contain any abstract methods. Now see what I'm just doing in a functionality point or testing point of view. I just deleted the things from the one abstract method as well as functional interface from the calculate method. Now go and verify what's happening. Are we seeing any compile time error with respect to calc operation? No. Even though it is a functional interface, yes, now we are able to extend the calculate interface. The reason is calculate interface doesn't contain any abstract methods. It contains only default and static methods. So as of now, we are just discussed about the functional interfaces implementation and how we are going to define lambda expressions for the functional interface abstract methods. Right? So we could take a couple of examples with respect to functional interface as well as lambda expressions. Now at the same time, do we have any existing functional interfaces? So nothing but predefined interfaces which are provided by the Java language or not? Yes. So since Java 8 version onwards, when they are introduced functional interfaces and lambda expressions, yes, they provided couple of existing functional interfaces. Okay, and we are going to provide implementation to those functional interfaces wherever we want, depends on the functionality. Okay, so now I just opened the Java 8 API documentation, and if you see here a package called as java.util.function. Okay, so if you just go to the java.util.function package, you can see the couple of predefined interfaces which are all comes under the functional interface concept. So but we have to identify each and every predefined functional interface functionality, and based on that we are going to write down the implementation with the concept of lambda expressions, and we are going to use all this as part of our programming level. So especially the usage of these things will become more and more in the stream API programming implementation. Yeah, so this is all about functional interfaces and as well as lambda expressions in our Java programming. So if you have any doubts, please drop me a comment, or please let me know if you have any other topics you would like to hear from me. So I will try to make session on that also. And in the next topic, I'm going to take method references, which is introduced again as part of Java 8 version. Hello everyone. So right now I'm going to discuss a topic called as method references inside the Java language. So as part of Java 8 features series, I made sessions about default and static methods inside the interfaces, and then I made one more session about the functional interfaces and as well as lambda expressions. So extended to those topics, we have one more concept called as method references in Java. So that means, like however we discussed earlier, the importance of Java 8 features usage in our real-time applications nowadays with respect to functional programming, and as well as with respect to interview oriented also, we used to encounter nowadays the entire Java 8 feature related questions or topics, whatever it is. By considering all these scenarios, I'm going to discuss more details about the method references feature as part of Java. So generally, method references is somewhat extended to the functional interfaces as well as Lambda expressions concepts. So that means we have to understand what exactly the meaning of method reference is and how it is related to functional interfaces as well as Lambda expressions. Okay, it means we required knowledge of functional interfaces and Lambda expressions to understand the method references. I just provided in the description the details of functional interfaces and Lambda expression sessions. Okay, now let's come back to the method references. So now the agenda of this session is I'm going to explain what is method references and how method references are related to the functional interfaces as well as Lambda expressions. We will try to have a couple of scenarios, how many types or how many ways we can use method references in our programming, as well as I will try to take a couple of use cases of method references like with practical examples. Okay, so let's start the more details about the method references now. Generally, the method references are called as a special type of Lambda expressions. So what is the meaning of a special type of Lambda expressions? Why we are calling method references are a special type of Lambda expressions? So generally, when we will define the Lambda expressions, when we are having a functional interface and when we are providing implementation to the functional interface, abstract method, so instead of defining the abstract method details and all, we are directly defining it as an expression by using some Lambda signature. We are defining the implementation of abstract method. Let's create a functional interface, and for that functional interface we will define a Lambda expression, and from that we will define a method references concept. So I'm defining a functional interface here and the name is convert to uppercase. So this is what my functional interface name. So I'm just marking this interface as a functional interface so that we have to provide one abstract method mandatorily. And I'm expecting my result should be string, and once the value is converted to uppercase. Okay, now as part of functional interface, I defined one abstract method called as converted to uppercase. It is taking string value and then it has to produce again a string value as a return value, right? So let's define a Lambda expression implementation for this. Okay, let me define a class here. Okay, now I just defined a main method class, and what I'm doing, I'm providing implementation for this abstract method with the concept called as Lambda expression. So generally what we will do as part of Lambda expression, we will take the interface reference, okay, convert to uppercase. So I'm just taking reference as uppercase equal to, so here we will define the Lambda expression based on the abstract method signature. So as part of this method signature, you have one method parameter. So what you're going to do as part of our Lambda expression definition point of view, you can take one variable here, right? So I'm just taking value and then followed by, that means implementation of Lambda expression and curly braces, and I'm going to close this, and you know that it is expecting a return value something like string. So I'm just right now I'm just dealing with the null. I'll replace it. Okay, so as part of this, what is our intention? So let's assume you return, you know that value belongs to which data type? String data type. Value dot to uppercase. So your aim here it is what? See, I just taken very small example. Okay, first of all, to make sure everything is clear with respect to method references. So you created a Lambda expression, you implemented logic for the abstract method of Lambda expression, and you are making whatever the string value it is coming, you are just converting as a uppercase. Now generally, how we are going to execute this again? So if you or if I am writing sys out of, okay, and what is the reference name here you have? This is the reference name dot and the abstract method name what you written converted to uppercase. Now here I am writing, okay, a statement called as Java method references, right? So now see, this entire string has to be is going to be converted as uppercase, and that value will be returned by executing this lambda expression. So I'm writing this out here also. So inside lambda notation, converting value to uppercase. So just making sure the lambda expression is executing or not. So let's execute now. What is going to happen with this execution? It's all expected result with respect to functional interface and lambda expression. So you define functional interface and by using lambda expression provided implementation of abstract method. Now we are executed and we got everything is converted as uppercase. So that is fine. With respect to lambda expression, you define and you provided implementation for the abstract method and all. But if you observe here, we are using a predefined method from the string class as part of lambda expression, right? So that means to utilize the existing predefined method or user defined method which is already available, okay, why we have to take again a lambda expression and inside that we have to define our logic to fulfill the requirement point of view. So that is what the concept of method references here it is. The method references is saying like in a short, we have to use or utilize the existing method implementations which are suitable or which are compatible to the functional interface implementation of abstract method. So that means now our functional interface aim is converting to the uppercase and we define a abstract method like taking one string value and converting as uppercase and returning a string value, right? So now same kind of method we are already having inside a string class as a predefined method, right? So instead of again declaring a lambda expression, okay, you just reuse that existing predefined method of the string class, okay, by using a concept called as method reference. So that means it's all about reusing of existing implementations. What are the predefined methods or user defined methods we have? Okay, so if you take in method references here, how I am going to write down the same solution whatever I implemented as part of the interface, functional interface with respect to method references, understand here. So I'm taking again the same reference converted to uppercase, okay, and I'm just taking a reference variable name again as called as uppercase 2, a reference variable name, and equal to, if you observe earlier what we discussed, a point called as, we understood like method references are a special type of lambda expressions. That means we define lambda expression with the logic whatever we want here finally to make sure converting string value to the uppercase. But if you see here what I am doing, I'm just calling string colon colon and I'm calling the predefined method whatever available inside the string class called as to uppercase, and I just assign this to the reference of the functional interface. So that means this is also one way of solution to define functional interface implementation. When you are already having solution as part of a method, we are just reusing that method. Now let's see, if I'm writing same statement whatever I written earlier, okay, even if I use the same thing with respect to the current solution instance, okay, see here the current instance I'm taking here and I'm just converting same example one more time as a Java method references. Now let's see the output what you are going to get here. So run as Java application. So that means you got the same output here also, and when you are using lambda expressions also we got the same result here. Then what is the main difference between lambda expressions and method references when it comes to functional interfaces is the lambda expression is simply saying like you have to implement logic with the lambda expression solution. But method references is saying like when you're already having a solution as part of one existing method, whether it is a predefined method or user defined method, the solution is compatible to your functional interface abstract method, then you no need to define again a separate lambda expression like this. Simply you can define that method reference, that method. So that means this is the predefined method name available under the string class, and I'm using a method reference delimiter. So that means we used to use a double colon symbol here, and this will be called as method reference delimiter. Method reference delimiter. So this double colon you have to use. So that means prefix of this double colon is representing, okay, whether it is a class name or instance reference. Generally the syntax I am telling you, and we will take examples also for everything, and followed by colon colon, and whatever the method you are trying to invoke from the that functional interface abstract method implementation point of view, that method name you have to define as part of this colon symbol, double colon symbol. And you don't need to define any parentheses here. It's all internally compiler will take care, or JVM will take care internally. So that means very simple. So in this case, if you are using method references, what you are trying to say to the Java or JVM point of view, what we are trying to achieve here, it is we are using, so that means we are reusing, we are simply reusing or executing a predefined method from the string class. In what way? Just assigning that method reference, of class where it is available, and that we are just initializing to the functional interface reference. Then we are again calling converter to uppercase in the sense. So internally what it is going to happen now, whenever this line is executed, line number 20, so whenever this implementation is going to execute it, so in this scenario it is going to invoke the method from the uppercase of string class. So finally we can see the entire string value is converted as uppercase in the second approach also. So that means the main agenda of method references here it is over the lambda expressions. I can simplify when solution is not available. If you want to define a solution, it's just defined as part of a lambda expression initialization level. If a solution is already available as a predefined method or user defined as part of your logic, as part of your programs, then instead of again you are redefining the same logic by using lambda expressions with respect to functional interface implementations, you just take help of method references concept to invoke that existing method. We are taking help of method references. So I think you got the point now. It's all about reusing the existing methods. The point here it is. The point what here it is, I am trying to say, if you see here, this is what the logic overall here it is. So what it is saying, lambda expression is all about the implementation of abstract method, what you defined as part of the functional interface. It's all about what implementation, the fresh implementation you are providing. But when it comes to method references, it is similar to equivalent to lambda expression. But only thing is method references is saying when already some methods are available, and out of those methods one method is compatible to your abstract method, okay, signature, it's all about compatible to abstract method signature, then you just use that existing implementation method with the help of method references concept, so that the method implementation is directly implicated to the abstract method. So that means your this whatever the implementation method you have, whatever the implementation you are having, that is pointing to this abstract method implementation. And finally, you are utilizing that functional interface reference and you are executing or you are performing all the operations by using functional interfaces concepts. So that is what the main agenda of method references here it is. On a high level, reusing the existing method solutions by using method references concepts. Instead of again you are declaring a way of lambda expressions and inside that again you are defining the implementation, or maybe again lambda expression point of view also you may call same method from lambda expression also, but instead of doing all these steps directly we can refer that method reference to the functional interface abstract method with the help of functional interfaces concept. So that is what all method references overview here it is. But at the same time, we know that in our Java we have couple of different method types, right? So something like static methods, instance methods, right? So similarly here also when we are working with the method references, we do have four types of method references. So that means the same method references is categorized as four types. One is reference to static methods. So that means in case the solution is available as part of the static methods. Second one is reference to instance methods. So the third type is reference to instance methods of arbitrary of given type. These three types belongs to the especially methods. But similarly, when it comes to constructors also, sometimes we used to consider constructors also similar to methods, but only thing is it will be executed while constructing the object, right? But it looks like somewhat methods only, right? So similarly, even to support constructor executions, assume your lambda expression, is internally taking care of some constructor execution to fulfill functional interface implementation, right? So in such case, even you can declare or you can define constructor reference with same delimiter here. So that means we are just initiating the constructor execution with the help of the delimiter references. So under the section called as method references. Okay, the fourth one is finally reference to the constructor. I will discuss each and every reference type here. Okay, when we are having static methods, what are the things we have to take care? Instance methods as well as the specific scenario instance methods of arbitrary object of given time. Then finally we will move to the referring the constructors also similar to methods. We will understand this one also. So before going into each and every one details, okay, we have to remember a couple of points here. So the first point here it is, the method references are always going to be declared as a implementation of abstract method of functional interface. So that means we cannot simply define method references when there is no concept of functional interface. Yeah. Before discussing about each and every individual reference type, okay, we have to remember a point very clearly is method references we have to define always as an implementation to the abstract method of functional interface. It's not like I can use anywhere else the respective method references when there is no relation with the functional interfaces. Okay, so that means we will see those points whether we can use the method references out of the box of functional interfaces concept. Okay, so now let's go back to the one by one. We will try to define a couple of examples with respect to every method reference type. For example, assume what I'm doing here it is when it comes to reference to static methods. Generally in Java, what we will do, we will define sometimes static methods also inside our class. Now assume as a functional interface abstract method implementation, you're going to refer the static method of the class. That's the meaning of here it is. So when it comes to here, we are going to define the syntax like we are going to give class name and followed by we are going to give the respective method name of the static method. Okay, so this is how you are going to define or you are going to initialize this reference to the functional interface implementation level. So let's say define a static method as part of the class, and I will try to use it. So to achieve this, what I'm trying to do, I'm trying to define a class called as employee class. Okay, I'm just making a little bit complex example. So as part of employee class, I'm defining a couple of properties. Okay, private integer ID and private string name of the person, and as well as I'm taking something like gender. So string gender, and I'm going to take one more property, double salary. Okay, so total 4 properties I have taken here. Let me define setter getter methods for this also. For this, I just defined setter getter methods for these properties. Okay, this is just simply a Java class, Pojo class, or we can call it as, right? Now here what I am doing, understand, inside the employee class, I am defining a static method. Okay, so now I'm defining a static method like validate employee details. So here I'm making sure mandatorily ID and name should be presented. Then only valid employee like I'm considering. Okay, so for that, I'm just writing a if statement, something like employee dot, okay, get ID is not equal to 0, and I'm writing like employee dot get name is not equal to none, right? So if everything is good, then I'm going to write down like return true. So he's a valid employee. In case false, then return false. That means he is not a valid employee. So this is how I return my logic here. So now I made it as a static method. Okay, sorry. I just made it as a static method. Okay, now what I'm going to do, I'm going to define a functional interface, and I would like to use that functional interface reference everywhere to make sure the given employee is a valid employee or not. I mean, that means the employee ID and name details are available or not. I have to verify. So for that, I'm writing one more new interface, functional interface, something like employee validation. Okay, I'm writing a functional interface, and I'm making this one also functional interface, so that I'm marking with an annotation at the rate functional interface, and I'm writing the return type as what? Boolean here. So is valid employee. Okay, and the method parameter is employee type we have to take. So I'm taking employee type. So what is the agenda of this abstract method? Here it is, taking in employee details and checking ID comma name available or not. Okay, if available, we are making sure like if available, or else false. This is what our expect. The return type is always boolean here. Now, what is the one thing we have to make sure here it is? Okay, let's define a method reference for the functional interface implementation of employee validation in our class. So I'm just taking one more main method class here, method references demo 2. Okay, so I'm just taking a main method here also. Now observe here what I'm doing. I'm not at all defining any lambda expression. I'm just going to define, okay, I'm going to define method reference of the static method. So what is our functional interface name now? Employee validation. Fine. Okay, so you're just doing the valid or not, right? Valid employee equal to, generally what we will do, we will immediately write down a lambda expression. Inside the lambda expression notation, you will define the logic like this to make sure ID and name is available or not. But this time you are already having a method which is performing same activity, then no need to write down the lambda expressions. So you just need to reuse the existing logic. Today it might be one or two lines. Tomorrow assume the same method is implemented with couple of use cases and it is proving it's a valid employee. Then why you have to write down same logic inside the Lambda expression implementation? So instead of that, just reusing this method signature, this method implementation as part of functional interface implementation level. So now see what I'm doing. And whenever it comes to the method, what is this method? Static method. So in Java, we know that whenever it is a static method, okay, we will use static methods are accessed by the class name, right? So in Java, we will follow this rule. Similarly, here also method references is saying, okay, go with employee. Method is belongs to the employee class and the method name is what? So if you go and verify, the method name is validate employee details. Okay, validate employee details. So just close with the semicolon. If you see here, now in this overall solution, what you defined here it is, what we defined here it is, we are saying like this highlighted one, validate employee details. Okay, that means this entire thing, whatever you define. So whatever we defined here, the entire method implementation is going to become the implementation of functional interface called as employee validation abstract method. So in this case, this is the abstract method of functional interface, right? So this overall method implementation is going to take care of this method implementation. So this is how, internal it is just like, it's all of referring, okay, implementation of abstract method. So functional interface, it is going to refer. So that's what, whenever you are calling again, now if you go back here and let's call and see sys out. So for that, what I'm doing, I'm validating one employee detail, validating employee details, validating employee details. So that means what I'm doing here, I'm creating an employee object first, employee emp1 equal to new employee. Fine. And I'm making sure employee, I'm passing to the valid employee implementation or functional interface. And what is the method we have defined is valid employee and I'm passing the employee one. If you observe here, employee one is just initialized, but there are no employee IDs assigned or name is assigned. So that means we can consider employee one as a invalid employee. So it has to print now what? False. So he's not a valid employee. So that means it is going to be print false. So it is happening or not, see here. So just see, it is printing the false. So what happened in this scenario? Whenever this line is executed internally, so valid employee is all about our functional interface reference. And this reference is having, okay, internally the method reference and it is representing the class called as employee, and from the employee class the method name is called as validate employee details. Here it is static method, that's why you are using class name colon and followed by the method name. So whenever this method is executed, immediately this employee one object is passing to this method here, and internally it is verifying employee details, and finally it is making the return value. Based on that, you can see false here. Now let's see, if I am passing one more employee details to the same functional interface implementation where we used method reference, what is going to happen? So what I'm doing, I'm just copy pasting same logic for, and I'm going to rename employee 2, and I'm going to make sure employee 2 dot set id, and assume his employee id is 123, and then followed by employee 2 dot set name, and I'm giving employee name as Dilip Singh. Okay, so now in this case, mandatory details like employee ID as well as employee name is available as part of the employee too. So I'm validating really this employee is a valid or not. So now in this case, what you're going to get? True, you're going to get, and let's understand here, run as Java application. See here, you got the true. So that's what, in the overall context, what we understood here, instead of defining Lambda expression implementation, you are simply reusing the existing method what you defined as part of the employee class with the concept of method references. If it is a static method, when you are referring static method implementation, okay, to the functional interface abstract method, you have to use that respective class name before the delimiter where your static method is available. Okay, so simply static method from the employee class, this overall line is implementing. But one thing what we have to remember very clearly here, it is your, I will tell you one point here, it is your lamb abstract method of your functional interface syntax should be matched to the, so the syntax of your abstract method of functional interface should be matched to the method what you are referring from any another class or from the current class. Okay, it should be same syntax. It should be same syntax. Now, if you observe here, yes, both are pointing to the same method signature. Then only, okay, method signature in the sense, with respect to return type value, it should be same. And with respect to method parameters, what you are taking input parameters, that should be same. So you have to make sure method return type and as well as method parameters with respect to method signature, both are representing same, that then only you can assign that respective method in place of Lambda expression, or you are just trying to make sure implementation of the abstract method. In case, for example, see here what I'm doing, the same formula, the same rule is applied for other method references also. Okay, so now if you, in case if you observe here what I'm doing, I'm making this one as a void. So that means my static method return type is void. I'm not returning any values as a void method. Okay, so let's see here, then in such case what is going to happen. So I'm just commenting out all the return statements. So now it's a static method. Okay, it's a static method and it's all about a static method, and assume you're having logic here and its return type is void. Save all the changes from the employee, but when it goes to the functional interface reference level and you told like employees validate employee details, in this case why you are getting the compile time error, the type valid employee details employee, okay, from the functional interface abstract method employee is void. So that means it is saying like abstract method is expecting boolean data type as a return type, but your validate employee details method is void data type. So there is no not matching with the method signature. So that's why it is a invalid method reference here. So you got the point, right? So what is the point we have to understand here? It is point number one. So the method which is referred, okay, should be matched method signature of functional interface abstract method. So it's very simple. The method which is referred, okay, should be matched to the method signature of functional interface abstract method. Otherwise, you cannot refer the methods to functional interface abstract methods level. So that is how we are making relation between method references in functional interfaces point of view. And now the statement whatever we have earlier, if you observe, okay, method references are special type of Lambda expressions, in the sense instead of defining the Lambda expressions we are fulfilling all the things, okay, with the help of concrete implemented methods, and we are just referring those methods with same method signatures we are following, and we are just making sure referring those methods as a implementation to the abstract methods. Now this is all about the static method. Now what about the instance methods? Okay, let me do one thing. Let me correct my method signature. Okay, so I will make it as again boolean. Okay, so now again see here, your compile time error is gone, and you can say like employee 1 is false and employee 2 is true. Okay, good. Now, in case this is all about the static method, right? So it's all about static method. That's why you are using class name colon method name. But when it comes to second option, it's all about references to the instance methods. So it's simple. Now it's the type itself representing what instance reference to the instance methods. So what you have to do here it is, in case your method is a non-static method, so that means assume in employee class you made it as a non-static method this time. So what it is, non-static method in the sense it's nothing but we can call it as instance method also. Now how we are going to call this method from the functional interface reference. If you see here, now you're getting a compile time error again. It's not like something a static method, it's a non-static method. You cannot make sure the static reference from the non-static method point of view, right? So then what method references is saying, in case if it is non-static methods, okay, what you have to do is create. Generally in Java, what we will do, we will create instance for that class, and with that instance we will execute the method, right? Similarly here also, create instance for the class, okay, where the method is located. So where it is located, inside the employee class, right? Inside the employee class. In case if the method is located inside your current class called as method references demo, then you have to create object for this class, and that reference you are going to use as part of that object reference we are going to use here. Now what I'm doing, I'm going to create employee object, something like e equal to new employee. Okay, and here I am saying like, okay, let's take this e here and pass here. So see here, now it's all because of it's a non-static method. Non-static methods are always accessible by the instances of that class, right? The object of that class. So I created object for the employee, and I am using same object reference to declare or to define the method reference to make sure logic implementation of this functional interface internally. So that's all you have to take care when it is a non-static method. Okay, if you see here, now also it's a same behavior here it is. It is a same behavior it is. Yeah. So this is how we can refer instance methods with the help of instance name or object name when we are referring to the functional interface abstract method implementation. Okay, so now I'm going to discuss one more use case related to instance methods. So the point here it is, we can access instance methods with class name also. But it's not possible for every instance method accessing or referring with the class name. So that means here instead of instance name, I would like to give the class name. Okay, for example, if you see here, I'm just like it looks like static method references. Okay, but generally this is instance method, and I given class name here. It's saying some compile time error here. So that means it's not possible for every instance method accessing or referring with the class name. So that means we have to follow on one condition here. We can refer instance methods with the class reference, class name. So that means what is that condition here it is. So let me give you. So the condition here it is the method which we are referring from any class. So nothing but in our case employee class. Okay. So in our case what it is, employee. Now that method should not contains any method arguments, and the same method should contain same return type value of abstract method which defined inside the functional interface. So that means now what is the point you understood? The method what the implementation method what you are going to refer with the class name, even though it is a non-static method, that method should not contain any method arguments. So that means zero method arguments has to be available as part of that method. And at the same time, one more compulsion what we have here it is, and the same method return type. So that means the method what you are referring from the employee class, that method return type should be equal to the method return type of abstract method which you defined inside the abstract method. So that means in our case, if you go to the functional interface, we define return type as boolean. But whatever the method we are trying to access with the class name, even though it is an instance method, that means, for example, see here what I am doing. I'm making sure my return type as a boolean here. The reason is what? The functional interface return type is what? Abstract method return type is boolean. So that's why I made return type as also boolean. And I'm writing a new method, something like valid salary or not. Okay, valid salary, something like that. I'm writing a method here. And if you observe here, return, okay, what I'm doing, I'm just taking current object, this dot get salary, okay, greater than 0. So that means true. So it's a valid salary in case 0 value or equal to 0. Okay, so if it is maybe 0 or less than 0, then it is all about false. So in this way, I'm just determining the respective employee is having valid his salary or not. If you observe here, I have no method arguments. So 0 method parameters I defined here. Okay, but the return type is what? Boolean data type. So you may get result as true or false. And this return type, this is what the condition we understood now. The method which we are referring from the class employee. Now, yes, this method is okay, eligible accessing with the help of class name of employee, even though it is a non-static method. The reason is no arguments, and as well as the return type of this method is matching with the return type of functional interface. Now this method you can access with the help of class name, or you can refer with the help of class name. So see here what I'm doing. I'm creating functional interface. What is the functional interface we have? Employee validation, right? So okay, so something like salary validation or whatever it is, I'm just taking and I'm making, see now I'm using class name now, employee. What is that? Class name. So employee and delimiter of method reference, and I'm referring valid salary method. Okay, and just save it semicolon. Now see, yes, you can refer instance methods with the class name, but on one condition, what? This method doesn't contain any arguments, and as well as this method return type is matching to the functional interface abstract method, then you can access. Now let me validate one of our existing employee. See, for example, I'm giving employee 2 here. For this instance of functional interface, what is the method we define? Is valid employee, right? So I define what? Employee 2. So this employee 2 is passing to the valid salary as a this object, current object, and I'm making like greater than 0, then valid salary, otherwise false. Okay, now let me execute this scenario and observe what is the output we are going to get in this scenario. Okay, so see here, you got false. Yes, obviously, the reason is you are not initialized any salary for the employee too. That's why it's 0, you got the false. Now let me make it as some salary for the same person, set salary. Okay, and I'm making something like 50,000 for the person. Now let me execute. Now based on our method execution result, it has to be true. So now salary is wise also, employee 2 is a valid salary or valid salary he is having, right? So this is how you can make sure accessing instance methods with the class reference, with the class name, by using method references, whatever the condition we have, here it is. Okay, so only in this specific scenario you can access. Other than that, if your method is having, okay, like this way approach, here what is happening, this method is having method arguments, one method parameter you define, right? Whatever it is. So in this case, yes, 100% you cannot use again class name employee. So see, even I am using class name, we are getting compile time error here. So that's all. You have to understand how we are accessing instance methods, sometimes by using instance reference or sometimes by using class reference. Okay, so now let's move to the third method references type called as reference to the instance methods of arbitrary object of given type. So we need to little bit focus on this method reference type now. That is, we need to understand now what is the meaning of instance methods of arbitrary objects of given type here. Okay. So let's see here, I'm taking an example and we need to understand internally what is the meaning of arbitrary objects and initiating or referring the instance methods as part of functional interface abstract method implementation. Okay, now if you go to the arrays, predefined class called as arrays, and if you observe there is a method available called as sort method with overloaded something like you are passing array of values and you are getting the sorting values based on the comparator implementation, right? So now what I'm doing here, I'm going to pass set of array values here. So that means what I will do, I'm just taking a string array values. We can take any type of array values generally. Okay. So now values equal to what I'm doing, I'm just defining couple of array values here. So here now I have array of string values and I'm going to sort these string array values, okay, in an ascending order and by using a sort method of arrays class. Okay, for that what you're doing, you're just passing values attribute here. And if you observe the second method parameter here, it is what guys? Comparator. So it's what? Comparator is the second method parameter. And if you go to the comparator interface, okay, so that means let me open the comparator now. If you see here, comparator from our Java. If you observe here, what is this? We have a abstract method called as compare abstract method. So what the method signature of abstract method is what? The return value is integer when it is comparing object 1 comma object 2. So nothing but type 1 comma type 2. So here you can pass any data type values. So that means integer values, string values, okay, whatever the values you have to pass here, any type of values we can pass. That's the meaning of compare here it is. So, and this is what? Functional interface. So that means when we know that now when it comes to functional interface, we have to provide implementation for this abstract method and then we can use it. Now in this scenario, what I'm doing, see here. So now I'm providing implementation for the compare abstract method of comparator. Okay. So with lambda expression, I'm doing. So I'm just taking object 1 comma object 2, right? And followed by, and I'm comparing. So if you observe here, what are the data type values we are having? String data type values. So now I'm considering with respect to comparator abstract method of compare. So you can pass any data type. So in this case, the objects what we are passing like object 1 comma object 2 for the compare method. So those are all I'm just calling it as arbitrary objects. So if you, what I'm doing here, see now object 1 dot, okay, and if you observe here all these methods are belongs to what? String class. So these o1 comma o2 is becoming part of string data type values or string objects. So now I'm calling object 1 comma or object 2 or as arbitrary objects. So that means if you observe here again, I'm calling a method called as compare to ignore case. So that means I'm just comparing string 1 value with the string 2 value by calling the instance method of string class called as compare to ignore case. So in this case, what happened here it is this logic, whatever I provided with lambda expression, okay, it is replacing the logic of the comparator compare abstract method. So that means even if you're providing implementation for this compare abstract method, generally how we are going to write down two parameters and then we will return a integer value. Now here also the predefined method belongs to the string class called as compare to ignore case is taking two values, and let me open this method also, okay, from this string class. If you see here compare to ignore case, so it's comparing internally the current string value with the provided string value. Total two string values are taking here, and if you observe here even internally they are also, okay, taking care of comparator. They are just, okay, taking again a comparator and they are comparing the values as part of that method. Okay, so just only thing is what we have to understand, this method belongs to the string class, this instance method, and we are comparing string value 1 comma string value 2, and I'm using string class predefined method here. But the overall whatever I defined here, this is all completely replacing with the, so if you observe here, this is just replacing the implementation of comparator compare method also. So if you just taken it, so it is replacing the implementation of compare method. So if you observe here, lambda expression for this object 1 comma object 2 and o1 dot, so whatever it is, even this method return type is what, integer value, even compare method return type is integer value. So it's replacing the functionality, of compare abstract method. So it is, the return type is also integer for the compare to ignore case. So this is what calling as arbitrary objects, and you are using method from the arbitrary type called as string, even though this overall implementation is representing comparator functional interface abstract method. Okay, so now let me execute, or let me print my values, everything is sorted or not. Okay, let's take a simple for loop. I'm just taking string values and I'm just making sure like sys out of, okay, every string has to be printed. We are just verifying everything is sorted or not. Okay, if you observe here, yes, it's clearly sorted. Dilip, Java, and methods and references and Spring. The given order is Spring in the third place. Now Spring came into the last place. So that means everything is sorted here. So this is all what Lambda implementation for the comparator interface for the compare method, right? Now, but even though we provided implementation with Lambda expression, but the agenda of method references is what? So instead of providing again implementation like this, okay, as part of Lambda expression, and internally you're calling the either predefined method or user defined method from the Lambda expression notation. Instead of all these things, what we can do? So now I'm just making the same line in this format, okay, with method references point of view. So what I'm doing here, I'm just removing this overall and I'm making like string colon colon, and I'm making compare to ignore case. Compare to ignore case. Now observe here. So you are utilizing predefined method called as compare to ignore case, and from the string class it is taking two input values again. Even if you go here also, this is also comparing current value and current object and as well as given object here also. Okay, so that's why you can call, you can define method reference. So actual sort method parameter is comparator implementation, but so as part of comparator implementation point of view, we are calling the string compare to ignore case method, and it's overriding the functionality of compare method from the comparator interface. Okay, so now let me see again the same result is coming or not. Yes, if you see delete Java methods references and Spring, yes, even the values are sorted. So this is all calling as, okay, arbitrary type, referring the instance methods of arbitrary objects of given type. So given type in the sense string I given today, tomorrow I can give one more data type also here. So maybe I can write down something like employee objects also here. I can implement. Okay, so that is what the meaning of arbitrary objects of given type and referring the instance methods. So with this, we are done with the different types of methods like static and non-static methods, how we are referring with respect to functional interfaces implementation point of view, right? So similarly, even Java 8 is provided same kind of concept called as constructor references as a fourth option in the same concept. So that means whatever the fourth option we are having, it's all completely related to the constructors. So let's discuss what is the point of, okay, reference to the constructor, what is the meaning of it is. It's very simple again. So instead of, okay, defining logic as part of our functional interfaces implementations level. Okay, if you are having anything going to be executed, something related to constructor references, we can do that. Okay, so now let's take a scenario related to constructor references. Okay, so now I'm creating a functional interface now, and I'm calling functional interface name as something like get employee instance. And here what I'm doing, if you observe here, so this is a functional interface. Fine, even we know that. And I'm making sure here my return type is what? Employee. And I'm making get employee, and I'm just passing something like string or integer id comma, okay, string name. So I just defined an abstract method called as get employee, and the return type is employee type, and I'm passing two method arguments id comma name, and it's a functional interface now. So in this case, what I'm going to do now, go to the employee class, and if you observe here, I don't have any thing related to constructor, right? So let's see here. First, let me define a constructor here, and then we will understand how constructor references are going to be useful. Okay, so what I'm doing, let me define a constructor here with 0 parameters. Okay, and so here sys out of this is employee constructor with no data. Okay, fine. And I'm observe here now what I'm going to do. Okay, so I will define, now I'm defining one more constructor with two values, something like integer, okay, id, employee id, comma, and followed by string employee name, something a property I taken. So this is employee constructor with data I just taken here. And what I'm doing here, so I'm just passing these values to our instance variables, like this dot id equal to the employee id, and just I'm passing this dot name is equal to name. So that means what I did in my employee class, total I created two constructors. One is with 0 parameters and one is two parameter constructor of the employee. Now if you observe the functional interface, okay, and the functional interface abstract method, final return value or result should be always a employee type. So that means now what I'm going to do here, just understand here, and creating a new class constructor demo. Okay, fine. So I'm just taking a main method. So let's see here what I'm doing. So how I'm referring the constructor which defined inside the employee class for the functional interface get employee instance, okay, as part of abstract method implementation. So what is my interface here? Get employee instance. Okay, okay, fine. And I'm just taking like employee equal to, if you observe here what I'm doing, employee, and I'm followed by the colon colon. Generally we know that, right? So in Java, whenever we are creating objects, generally how can we create employee e equal to new employee? So that means to initiate the constructor, generally we will use the keyword called as new keyword, right? Similarly, what I'm doing here, so defining same new keyword as part of constructor reference. So that means you are telling, we are configuring like, so whenever I initiated the abstract method implementation from the functional interface, okay, so this with this instance of functional interface, internally it has to execute a constructor from the employee class. So that is what the meaning of it is. So that means if you see here, I'm just taking instance of functional interface, and I'm calling the abstract method what were available as part of functional interface, and whatever the, now what is the point here it is. So let me configure some data first, and I'm giving something like employee name as Dilip Singh. Okay. So in this case, if you observe here, what is the return type of get employee method? Employee type. Okay, so it's returning employee object. So let's do one thing. I'll tell you what is happening internally. Okay, so in this case, what's happening here it is, you are referring a constructor from the class called as employee and by using a keyword called as new keyword after the delimiter, right? So that means what you are trying to say here it is, whenever you are calling the abstract method implementation of functional interface, so internally by taking all these details, okay, it is going to execute the constructor from the employee class. So now, okay, that is fine. So let me execute and let's see, is it now? So you know that whenever a constructor is executed, that means an employee object is created. And the same employee object is whatever is created by the constructor execution, that is what written from this method. So that means the functional interface abstract method is internally when you are invoking that, so internally executing the constructor and whatever the object is created after executing the constructor, that object is being written again here. So now let me see really the things are available or not. So what I'm going to do, employee dot get, so I'm going to write down id so that it has to print 100 and as well as if name also I'm going to print. Okay, so see here get name. Okay, so let's execute now, run as Java application. If you see here, this is an employee constructor. So that means a constructor is executed with data. So if you go to the employee class, then employee, this constructor is executed. So this constructor is executed and the data is initialized as part of constructor, whatever you provided from the abstract method of functional interface. So this is how internally you are initializing the constructor for the abstract method of functional interface. Now my question here it is, okay, that's fine, it's initiated. But how Java is knowing that which constructor has to be executed? So when you're calling this, okay, so you're saying like a constructor has to be executed. But the point here it is, how Java knowing that which constructor has to be executed? So internally, generally, what these guys are doing, they are comparing the number of parameters what you are taking as part of the abstract method. So that means in the abstract method, how many two parameters we have now? Total two method parameters. You define two method parameters, right? So that's why they are executed. Okay, the two parameterized constructor here. Now, for example, see here, if I'm making this one as a one parameterized constructor and you don't have any constructor inside the employee with one parameter called as a integer value, right? So now in this case, what is going to happen? Understand here. Okay, so if you observe here, even here itself it is saying like a compile time error. So it was saying like there is no constructor with one parameter called as employee integer. So that means you have to make sure, what is the rule here it is, as part of constructor in references, make sure abstract method parameters are part of constructor definition in the same order. That is also. So that means whatever you are just making as part of abstract method level, so the same parameters you have to define again a constructor with respective class, then only it will work. Now see if you, what I can do now, let me define one more constructor with integer id. Okay, and let me see here, save it and come back here. Now save it. See, now you got the, now your compile time error is resolved here. So what is the point you understood now? So based on the abstract method parameters, so that respective constructor will be executed whatever the class you referred here. So if you don't have that respective constructor, the equal number of parameters and same parameters in the constructor implementation level, then you are going to get the compile time error. Now in this case, which constructor will be executed? So definitely it will execute the constructor with this okay, this constructor will be executed. So the reason is what? So if you go here, so the abstract method is defined with only integer id value, so that only integer constructor will be executed in this scenario when you are calling the abstract method from this interface. Okay, so if you see here, anyway, I will just try to execute one more time, and I'm passing some value 111 here. Okay, and you're going to get again employee object, and observe which constructor is executed now. Let me write down this out here also. This is only id value initialized. Okay, so if you see here now, run as Java application. See, this is only id value initialized. So that means only that respective constructor is executed. So what is the point we understood now finally? Make sure abstract method parameters are part of constructor definition. So with respect to what? Order and types. Then only you can define constructor references, or you are initializing constructors references as part of functional interface abstract method implementation. Okay, so this is all about the method references and constructor references, which is introduced as part of Java 8 version onwards. And we know that these concepts are nowadays being used in every level. Okay, so now what I will do in the next session, I will make of each and every existing functional interface. Like we have couple of things like predicate, supplier, consumer, and all. I will make a session for all existing predefined functional interfaces, and we will try to understand the purpose of every existing functional interface which are specifically provided by the Java language. Predefined functional interface purpose also. Okay, so that's all comes under functional programming. So once we are understanding the predefined functional interfaces as well as couple of things whatever we completed in this session and even previous sessions, the functional interfaces point of view, Lambda expressions point of view, these are all comes under the functional programming. Okay, so you know the importance of functional programming, how things are being used, especially the most popular concept called as stream API. So as part of stream API, we are using definitely everywhere as okay, what we are using Lambda expressions and method references. So where it is all placeholders of functional interface implementations. Okay, before stream API, we should have all this knowledge. So that's why we need to go through, or we need to revise everything before understanding the stream API thoroughly. And let's connect with the next session. Hello everyone. So right now I'm going to discuss about predefined functional interfaces in Java. So in previous concepts, I discussed about functional interfaces importance as well as how we are using functional interfaces or how we are providing implementation to the functional interfaces by using Lambda expressions and as well as method references, right? So now we should understand the reality of functional interfaces usage in our day-to-day programming when we are implementing any application, right? So when we observe to achieve the functional programming with respect to our Java language, and anyway, whenever we are working with Stream API especially, we know that. So how frequently we are using the functional interfaces implementations as part of methods level. I mean, like passing functional interface implementations to the method argument values, right? So that means if you want to achieve the good knowledge as part of Stream API or to achieve finally functional programming, we have to understood very well about the functional interfaces and as well as the implementation of functional interfaces. So we defined a couple of user-defined functional interfaces as part of our previous session, and we understood how we are providing, implementing, and as well as usage of this user-defined functional interfaces, right? So similarly, now when it comes to Java, so along with Java 8 version, so whenever they are reading these functional interfaces, features, and everything, they are given couple of predefined functional interfaces from the package called as java.util.function package. So that means inside this util.function package, we will find out all predefined functional interfaces which are provided by the Java language. And out of all these functional interfaces, we know that couple of interfaces are the respective implementations we are using everywhere, especially in Stream API functionality. Generally, we will use all these predefined functional interfaces and implementations as part of Stream API methods. Not only Stream API, even we are going to use the same functional interfaces in different other scenarios also. So I would like to explore now. So what is the real importance of predefined functional interfaces, as well as I would like to introduce the more popular functional interfaces, especially function, predicate, consumer, and supplier. So these four are the popular functional interfaces which are being used everywhere in our day-to-day programming. So I will try to cover the use case of every functional interface, especially these four, and I will take some couple of examples for every internal abstract method, as well as if there are any predefined default or static methods are existed as part of these four interfaces. Okay, so let's start one by one. So initially what I'm doing, so I'm going to take now the more discussion about the functional interface of function. So if you see here, this function itself a predefined functional interface from the package called as java.util.function. So let me open the package now. If you observe here, we can find a lot of functional interfaces, especially inside this package, like by consumer or whatever it is, right? But especially, I'm going to discuss more about the function as well as predicate, supplier, and consumer. And the remaining all functional interfaces, whatever we can see here, those are all derived from these four types of functional interfaces, what we are discussing right now. So once we are good with these four functional interfaces, even we can easily understand the remaining all functional interfaces which are listed here. Okay, so let's move to the function interface first, and then one by one we will try to discuss. So now I'm talking about the function functional interface. So what is the meaning of function functional interface? Why Java language provided function interface especially? So this function interface, we can consider it as a utility function as part of our programming level to apply any functionality to the given argument. So for example, let's take a scenario like this. Whenever I have an element or an argument and I want to process that argument with some logic or maybe some manipulation I have to do with that argument. And then finally I have to return some other value. So that means here as an input I am passing one argument, and at the same time after making some calculations or maybe some functionality, applying some functionality, then I want to return a value. So this kind of functionalities we can achieve with the help of functional interface. So that means when you go to the function interface abstract method especially, so let me show you here. So now in this case, if you observe here, we have only one abstract method, single abstract method called as apply method. So what it was saying here, it is whatever the given value. So here the method argument representing the input argument. So once you are taking an input argument, and if you are applying any business logic or maybe any logic to the argument, and then you can return a value. So that means by using this function interface, we can take one input value and we can process it, and then we can return the result also. If you have such kind of requirement in any scenario, then we can use functional interface, and we can pass that interface reference wherever we want as an implementation to achieve same functionality. And even if you observe here, there are a couple of other predefined methods also available, like and, then, compose, and identity. So we will come back and we will discuss each and every one. So now let's start discussion about the apply method. So what this method is saying, just clearly understand now. So we are going to apply this function to the given argument, nothing but whatever the implementation we are going to provide as part of this apply method implementation by using either lambda expression or maybe method references, right? The same functionality we are applying to the given argument, and then finally we are going to get a return value. So for that, let's create a small example and let's try to understand practically how this method we are going to implement, as well as and in what scenarios we are trying to use this respective function interface. Okay, so now let me create a project. So I have created a project now. So yes, I have created one Java class now. So inside this, for example, if I have a requirement, so in this case, just I'm giving find half value from given value. So this is what I just give. So what is this? I'm going to pass one value and I want to get half value from that. So what I'm going to do now? So as per functional interface, we know that we can provide implementation by using Lambda expressions. So what is our interface here? Function interface. So let's take function. So if you see here, java.util.function and file. And this here, when it comes to apply method, so let's discuss the one abstract method called as apply. Yeah, this is what the method. So here, P representing the input type value, R representing the return type value. So that means you can pass any data type value to this method argument. And at the end, we have to return a value mandatorily whenever we are taking this function interface. So for that, what I'm doing, see here, I'm going to pass input value as an integer type and I'm expecting the result as a double data type. So here, half value. So just I'm giving a reference and I'm providing. So let's assume I'm going to give a value and you know that as part of method, Lambda expression implementation, when you are having only one method parameter, you can define that here. And you can divide I by 2. Okay. So that means what is the point here it is? So here I'm just providing implementation like I'm providing integer value and on top of integer value, I'm just applying by 2 divided by the 2 so that I can get the half value. So see here, now we know that generally how to call the implementation of the Lambda expression by using the actual method. So I'm calling now the apply method, which is part of this function interface. So here I'll pass initially like 10, right? And if you see the return type of this method now, what is this? Double data type, because we defined return value as a double here. So let me make sure a double data type result equal to like this. So see here, now let me print this value, sort of. So let me execute now. Yes. So if you see here, the input value we given 10 and then got value as 5. So what is the advantage of these methods? Here it is with respect to functional interfaces. Tomorrow, whenever you are having any kind of requirements, okay? For example, you have to pass a string value and you want to make sure everything is converted as uppercase. And again, you want to receive the value with the uppercase value. So as an input, we will use string data type and output also we can define string data type. So that the given string will be converted to the uppercase and returned as a string again. So and that is how you can reuse as a utility functionalities wherever we want, instead of defining one more separate method or maybe some implementation as part of the classes and all. We can use this respective predefined function interface. For example, let me take one more example for the same. So what I'm going to do here it is, I'm just trying to convert given string to the uppercase, right? So what I have to do now? So let's define our function implementation. So what is the input data type? String value. And what is the expected output data type? String value. So then I will provide implementation something like function 1 to uppercase. So what is the input value you are giving? One single string. So I can define as part of Lambda expression as a method argument, and then I can do what? S dot to uppercase. Yes, right? If I can provide implementations, or else we can provide implementation like by using method references also in place of Lambda expression. So this we discussed in the previous session how to use and where to use method references as part of implementation of functional interfaces. So what is the method? To uppercase, right? So by using method references, I provided implementation instead of Lambda expression. Fine. So now let me verify whether it is really returning string value or not. So what I am doing here, I am directly applying function and I'm just passing apply method. So we know that whenever we provided implementation to the functional interface, we are going to call that abstract method. That means this implementation comes as part of the abstract method implementation. So we are calling that abstract method and we are passing the actual value. So see here, I'm passing my name, Dilip Singh, and let me print it so that what is going to happen in this scenario, what we are expecting here it is. So whatever the value we are passing, like Dilip Singh here in this case, it is going to be passed an implementation like to uppercase, and it will convert the entire Dilip Singh as a uppercase letters, and that value is going to return as a string value in this specific scenario. So that means in the overall implementation level, what value you are going to get? Return. The return value is string result. So then we are trying to print the return value, whatever we are receiving. So it has to print everything in the uppercase. Okay, I'm just executing the program now one more time. So see here, you got the entire value as a uppercase value. Similarly, I can use the same function implementation in any place again also. So like system.out.println. So again, I can use function one dot apply method. Even I can do so like Java features. So see here again, I'm reusing the same function interface here also. So after executing, I can get again the Java features in the uppercase also. So like this, you can define any input value you can pass, and you can expect based on the requirement what is the return value. You can provide implementation as part of this Lambda expression, or you can define your own method implementation also as part of Lambda expression, right? So this is how we can define apply method from this function interface, and we can use this reference wherever we want. Even we can pass this reference to the other method arguments also. We can define method argument with this function interface, and we can pass this implementation also, right? So let's discuss a couple of examples related to the static and default methods which are available inside the same function interface. Okay, so what we will do, first we will discuss one by one what is the purpose of this default methods and static methods provided by the function interface. Okay, so generally sometimes what will happen, we have to compose an implementation with couple of function interface implementation. So nothing but I want to make sure in an order, one action should happen first. That means one functionality should be executed, and immediately one more functionality has to be executed. So that means I'm just composing the actions one after another. Okay, so that is all, right? So that is the purpose. They given couple of methods here. So if you observe here, and then and compose method, especially for all about composing a function interface, is nothing but make sure one function is executed once, and after that immediately followed by one more function. So I will show you very clearly how it is going to happen, what is going to happen as part of this default methods, especially and then and compose. If you observe here, these two default methods are taking input as a function reference and as well as returning again function references. But at the same time, we have to understand what time we have to use out of these two default methods, right? So generally, whenever I have two function implementations, function 1 comma function 2, okay, and then I would like to make sure one function, whatever the function I have, main function, I would like to apply this some functionality, and then again I want to apply some other functionality. So that means I want to apply two functionalities to the given input value. So I have single input value, but two functionalities has to be done at the same time for the given value. So that means, for example, assume I have a scenario like this. I'm taking a string called as a string value. Okay, fine. And then I want to make sure step number one, first of all, is it null or not? Is it null or not? That is one functionality. It's all null check. So that means it's a single functionality. Second step is, if it is not null, then I want to make sure it is converted to the uppercase. So this is what I have to perform in this case. So what it is, first functionality is it null or not? I have to check. In case if it is not null, then I want to make sure converting to the uppercase. If not null. Okay, in case if it is null, then I will ask user to enter valid value. So this is what I have to perform. Then what I have to do. So for this, what I will do, I will write down one function implementation here. Okay, so by checking, first of all, the given value is null or not, right? And then I will write down one more function implementation. Okay. And I will see if it is not null, converting to the uppercase. If it is null, then asking him user to enter the valid value. Right. So this is how I'm going to do that. So that means in a sequence, first this thing should be happen and then this should be happen. So that means if I give an input value now, for example, the value I given as a delete, what should happen now? First, which functionality should coming into the picture? Function 1 should come into the picture, right? And then function 2 has to coming into the picture, right? Yeah, let's implement this now in a programmatical point of view, how we are dealing with and then method, especially in this specific scenario. So generally and then method will be applied in such a way. First, what is going to happen? First step number 1, this function 1 will be executed. So once whatever function 1 is executed, and then okay, second functionality will be executed on the given value. So whatever the given value we have. So step number 1, it will verify with respect to null or not. So in case if it is not null, then it is going to convert everything as a uppercase value. In case if it is null, then we are going to see an enter value. So this is how the and then method. So that means execute this first and then execute this. So like that, in a sequence, we can execute number of functions by using this method. So let's implement this now. How we are going to do that? Okay. So let's define one more functional interface for what? Null check. Okay, so what I'm doing, I'm taking one more function interface, and here also input value is string and output is also I'm going to take as a string. So it's all about function 2 I'm implementing as a null check. Okay. So this is given string, then I'm going to verify if string equal to null, then simply return enter valid value, right? Okay. If it is not null, then return same value. So I have defined one more second functional interface implementation, like if string is null, enter the valid value. If it is not null, returning the same value, right? So now in such case, based on our requirement, what we have to do? First what we have to do? We have to do the null check. And then, so that means null check, please perform this action first and then, okay, perform uppercase. Perform uppercase. For what? For given input value. So I'm giving finally a value here. Okay. So this is delete sync channel. Okay. So this is what given string. So in such case, what is happening now? As per our previous explanation. Okay. So this is the value we given, right? So this value will be passed to the null check. And once at null check level, what it is going to do? So this functionality will be executed. So is it true or false? So here it will become false. So that means then it is going to return the actual string value to this what? To this output. To this whatever the value you are returning. So you are returning what? String. The output of this is written here. And then again this value will be, then this functionality will be executed. It is step number 1, and then it is going to be executed in the given input value from the string. So now this is the lip sync is the not null value, and you will see everything in the uppercase. If it is null, then you are going to see this message is going to return again as part of this method, right? So then to this method implementation, and then again that will also converted in the uppercase like enter valid value in case if you given in the null pointer. So let me collect this result also. So whatever the value I have, so sysauto value, and then let me execute my functionality now. So see here, this is the lip sync channel. So what happened in such case? So that means if it is taking here, coming here, as a first. So this is what executed first, and then not null, return the same value, and then applied uppercase functionality. The second functionality is applied on top of this result, whatever came from here, right? So that's why you can see the ellipsing as a uppercase point of view. For example, let's see if I given same null here, what will happen now? Yes. So in this case, null, that means again this functionality will be executed first, then it will come here str equal to null, then this value will be returned. This value will be returned for this method implementation. So that means in this case, what is the input value? Enter valid value, and that is also converted to the uppercase. But you are going to see now output as enter valid value in the uppercase format. Okay, so let's see here to format in case if I given null. See now when I provided null, then this is what happened. So that means in simple what we understood, we are just making sequence of functionality execution for the one input value, like especially and then method will be executed, okay, right after apply functionality. So that means it will apply functionality and then this will be executed. So now similarly, let's discuss about the another method called as compose method. Okay, so what compose was saying here, returns a composed function that first applies the before function, it is input. So that means it's just like opposite to the and then method. So in and then method, what happened? First, whatever the functionality we provided in the first place, that will be executed, and then whatever we pass it to the and then method reference method argument level, that is what executed in the second place, right? But in this case, what is going to happen? On top of which function reference you are calling compose method, and whatever the function reference you are passing, out of these two, what will happen? First, whatever you pass it to the method argument, that will be executed, and then the result value will be passed to the actual main function what you are calling, that will be executed. It's just like little bit opposite to the and then method. So for example, I'm not taking new example, so I will just make sure the differentiation between and then and compose here itself. For example, let's see, I'm taking same example, I'm just converting and then to compose. Then what is going to happen? We will try to see here. Okay, so what I'm doing here, so in place of and then, I'm just making compose. So if it is and then, we understood first and then second. Now in this case, first this will be done and then it will be done. So that means whatever the value you are passing now, okay, so let's make sure this is compose. Okay, so what is going to happen now? It just this value will be passed to this functional implementation. So that means first uppercase value will be executed and this functionality will be executed, and the result, whatever the uppercase value result, is passing to this functional interface, right? So this is what happening here. So this is first now and this is second now. In earlier case, when if it is and then, this is first and this is second. Okay, so this is all the difference between compose. Compose in the sense it's all about before. So it's all about and then is all about after. So this is what pass executing after. Okay, so this is what executing before. So that means before. So this is what they are explaining as part of these two abstract methods. Okay, so let's see the execution ones again. So let me print again same value also here also. Okay, so I'll just write down a simple this is functionality of compose. Okay, so just making sure from the previous output is different. Okay, so see here, this is compose. So what happened? First, this is executed. So it went into the uppercase. Yes, it is converted. And then it returned to the null check. Then what happened? It's anyway not null. That's why it returns string. Now observe here, what I will do, I'm just passing here null. Okay. So now in this case, you will come to know that which is executed. Okay. That means in case if it is executed first, what will happen? A null value is trying to convert it as a uppercase. But we know that we cannot convert null to the uppercase, we'll get some null pointer exception. So that means at this function implementation, okay, like before this implementation itself, I'm getting the null pointer exception. So that means it's not at all reached to this one. So let's understand now, is it true or not? So see here, you got something like null pointer exception is nothing but what happened here. It just trying to execute this functionality first and then this one. So that means before applying this is what applied. So this is before. I mean, this is after, this is before. You got the point now? So it's just quite opposite to the and then method. So in such a way, we can combine multiple function interfaces implementation to perform sequence of activities. So even we can combine and then as well as compose also in an order, so that you will just need to make sure in which order we are trying to achieve or execute the functionalities on the given input value. So we are giving only one input value, but it is in a compose or in a sequence of actions, multiple functionalities you are trying to execute one after another with the one given input value. So it's something like chaining the functional interface implementations, executions. So now, and we have one more predefined method from the function interface, but it is a static method and call it as identity method. So if you observe this identity static method, it's not taking any input, but it is trying to say it whatever the input value we are passing, same value will be returned as output. So returns a function that always returns its input argument. So that means simply what you are passing, same thing will be returned back. But well, somewhat it is interested, like why we need to question something like, so what is the meaning of passing value and receiving same value? Here it is. So that means in couple of very rare scenarios we are going to use this method. Out of that, I'll try to give one or two scenarios. Okay. So generally as part of identity method, so let me take this. So now we are discussing about identity method. The real use of this identity method is actually, yeah, it will be used very often, but the real scenario is something like where a function is required but no changes should be applied. So that means in simple way, I can say we want to pass some dummy function where we want to, wherever we have a dependency of function implementation. That means when you are passing this identity method, so it's just fulfilling the functional implementation. At the same time, it's not performing any activities on the given input values, and it will give same thing as a output values. So okay, so that is how this method is going to work, and it is a static method. So that means we have to call this method always with the help of function interface name only. So let me take one example, a basic example how it is working. So it's all about static of identity method. So what I will do, I will define a function and given value is integer. So you know that it is always going to return again same integer value. Okay, so identical, it's just like identical things. Function of, see here, I don't want to perform any action, then I'm going to make sure this method is called identity method. So see here what I will do. So just calling system.out.println and identical value dot apply. So I'm just passing some 100 value here. So if you see here, I'm passing 100 value here, and it will not perform anything on the 100, and it will return same value. So that means integer you are passing as a function identity here. So let me return here. Yeah, let me execute now. See, it is providing 100. For example, let's see here, I provided double. So see here, what is the error you are getting? Type mismatch cannot convert from object to object, because the reason is it is saying input and output data type should be same. Then only this identity function will work. Okay, so this is one scenario I can tell you. And second scenario, This is how generally we are going to use. The actual scenario, for example, if you are having any idea of Stream API, okay, so I will cover in the next session the entire details about the Stream API, right? So when as part of Stream API, assume I have a stream object. So I have a stream object, and from that I have to collect. From that I have to collect all values as a list. So what is the output? What is the requirement here? It is I have stream object ready with me, only stream object, and then from that I want to collect all values as a list of values. So that means what I will do here, I will take a stream object first. Okay, followed by, for example, assume I have string and I'm taking like names stream of, so I can pass any type of values here. So something like 21, comma 2, comma 3. So assume I have more values like this. Now what is this? It is a stream object. And what is my output now? From this stream object, I want to collect all values as a list of values. Then what I have to do? See here. So in such case, generally what I will do, see simply I would like to take a map functionality, but map, you know that it will always expect a function implementation, but we don't have any function implementation because we are not doing any transformation of the data. We are not modifying anything, right? So we want details as it is. So in such case, what I can do to replace the function implementation, I'm using function dot identity method. Function dot the identity method I'm using here, and then simply I'm writing like collect us to the list, so that I can get a list of string values. So generally this is how we are going to use, but very rare case we will use this method, just where we want to replace like this a dummy implementation as part of function implementation. See, now it's got. So this is all about the function interface which is provided as part of the java.util.function package, like as a functional interface. So we discussed all the methods as part of function interface, where and all we have to use what method. We taken couple of scenarios and everything, right? So now let's start discussion with another functional interface from the same package called as java.util.function, and the second one what I'm taking here, it is predicate. So now I'm going to discuss more about the predicate functional interface. So when you are good with this function, understanding whatever we had till now, so we can easily understand now the upcoming functional interfaces what we have, like predicate, consumer, and supplier. Okay, so let's start with the predicate now. So before entering into predicate details, what is the meaning of predicate here? So predicate, we can consider it as a condition. So that means generally when we are making our programming, we used to write down a lot of conditions and we will try to get the Boolean results, right? So wherever we are having any functions, those are all expecting a Boolean value functionality. So that means Boolean valued functions, right? So in such cases, we can use predicates. So that means when you are observing the predicate here, so if you see here, predicate is just representing a Boolean valued function of one argument. So that's nothing but, so if you observe here, the predicate contains one single abstract method called as test method. And here it is taking only what? One input type, and it is always producing return value as a Boolean value. So that means, what is the meaning of this test method? What is the meaning of, what is the agenda of predicate here? It is especially very simple. Like when you want to process an argument and you want to make sure the same argument or the same value has to be processed by a condition also. In such kind of scenarios, we are going to use the predicate implementation in any methods level. So that means, for example, I have a list of employee objects, okay, and I want to see how many employees are having greater than 25,000 salary. So in such case, generally what we will do, we will write down a for loop and we will write down inside that maybe if condition. So nothing but we are processing one object after another object and we are verifying salary is greater than 25,000 or not by using the if condition, right? But when it comes to nowadays as per functional programming and when we are processing the list of employee objects, maybe assume we are processing by using Stream API and I want to filter the values or the objects which are having greater than 25,000 salary, right? So in such case, I will process one employee object and I'm validating he is greater than 20,000, 25,000 amount or not, right? So those kind of scenarios we are going to write down predicate implementation and we can pass that predicate implementation as part of the method representation or method argument level or wherever it is, we can use the predicates and simply it's all just like replacing the functionality of a conditional things for any given element. So how and all we will try to understand. I will try to give you the clear details about the predicates with couple of examples. Okay. So and after one abstract method, if you observe, even we do have in predicate couple of default and static methods. Okay, if you observe here, and is equal, negate, and as well as or methods, right? So these are all I can call it as conjunction methods. That means we are conjunction of predicates, like adding multiple conditions, nothing but adding, or we are just applying multiple predicates on given value. So like that, we can consider these methods. Anyway, we will have one by one example for every default and static methods also. After first, we are discussing about the test method as part of predicate interface. Okay, so let's take an example here how we are going to define the implementation for the test method and how we are using the predicates in a simple examples we will try to cover. So now I'm just taking a very basic example right now and then slowly we will try to improve other examples with some complexity. Okay. So for example, assume I need to verify I have a requirement something like verifying age is greater than 21 years or not. Okay, so this is what I want to verify. So here age value I'm just considering as an integer value so that when I'm defining predicate, we already discussed predicate is going to take how many values as an input to the actual function abstract method of test, only one value. So and what value you are passing to the predicate implementation, that data type we have to provide here it is. So that means whatever we provided the type here, so it's just like a method argument type also, whatever we discussed in the test method. So here I'm just providing implementation in a way lambda expression. Yeah, here I'm just providing implementation by using lambda expression implementation. So whenever my method is having only one argument and I'm just taking only one argument here and I'm just writing age is greater than 21 or not. So that means what is the condition here I written? What is the implementation? This is what the implementation. When have input value, something like I'm passing input age value and I'm just checking the respective input value is greater than 20 or not. 21. So that means if it is greater than 21, then you will get the true. If it is less than 21, then you will get the false. Either 21 or less than 21, we will get the false value here. So see here, now you know that generally how to execute the functional interface implementations by, right? So for example, I'm just taking the instance of our implementation and I'm calling what is the method? Test method. So the implementation of test method is this is what. So I'm just passing my value here. For example, I'm giving right now 32 here. So now that means the 32 value, whatever you are passing here, and it is just checking like 32 is greater than 21 or not. Yes, it is greater than. So the what is the output value here? It is right. Similarly, if I am passing any value less than 21 or maybe 21, so then for example, assume I'm going to pass one more value, something like 18 and it is checking internally 18 is greater than 21 or not. Yes, it is false. Then it is going to return false. So generally these kind of scenarios earlier we used to take care as part of if conditions, directly implementing at the if conditions point of view, right? Generally. But now we can use this one as a whatever the predicate we defined with respect to check or whatever it is. So we can use this as part of our conditional statements also. So when instead of again you are defining the implementation based on our conditional statements level, you can directly use these predicates also. Okay, so for example, so let me just give that what 18 also system.out.println. So that means I'm just checking age check dot test of maybe if I given 18 years, then expected output is false, right? So the predicate of result here it is true and here it is false. So see here, yes, it's just like working as a conditional on input value here it is. So tomorrow, even you can use these predicates as part of our conditional statements also. See here, I'm just checking if age check. So the implementation we have to use, right? So I'm just passing a value here. Now simply this out allow or eligible. So let me write down it as eligible, right? In case otherwise, it will become false. So let me execute now. See here. What is this? You got eligible. So that means even you can use the predicate implementations as part of our conditional statements also wherever we want. Instead of again, we are defining the conditions in our conditional statements level. Okay. So that is what one of the big advantage of the predicate. And let me take one more requirement here it is. For example, we decided, right? So we had an example like who we want to find out an employee from the employee objects who is having greater than 25,000 salary, right? So let's take same example here also. So for that, what I'm doing first, I'm creating a class called as employee class with some properties. So let me define the employee class quickly here now. Private integer ID, private string name, private double salary. Okay, so let's define setter getters all for this. Okay, fine. So I just created a simple employee poser class and let's come back to our class name. So what is my requirement here it is? I would like to verify the employee is having greater than 25,000 salary or not, right? So let me create a employee object right now. Employee e1 equal to new employee. Okay, fine. I will just set some values. For example, e1 dot set ID. I'm just like setting a value and as well as e1 dot set salary. And I'm just checking values I given as a 24,000. Okay. So now I would like to verify this employee is having greater than 25,000 salary or not. And I would like to use predicates in this scenario also. How to define predicates for every employee object. See, the condition what we have to evaluate here it is, every time I want to identify an employee's salary is greater than 25,000 and I want to reuse that logic in my implementation in couple of places. So then I'm going to define a predicate here it is. So how? Let's define predicate. And you know this time what is the type of value you are passing, what is the argument? Employee type. So that means employee object you are passing in this scenario. So let me do one thing, employee salary check, something like that I written here. So and then you know that what is the input type this time? What is the method argument type? Employee. So I just taken employee as a method argument and then I'm just making the logic something like employee dot get salary is greater than 25,000 above. Okay, so this is what the predicate or the condition I defined for an employee object. Now wherever I would like to verify employee details with respect to salary, I can use this predicate implementation, right? So for example, if you see here, if employee salary check dot test, so that means we are testing with respect to employee 1 is really valid employee or maybe he is having greater than 25,000 salary or not. Okay, so that means it's out above 25,000, right? So or else I can write down below 25,000, simply just verifying the data now. So let me execute program once. So if you observe here in the latest line, what it is below 25,000. So that means now what happened again in this scenario also? the same employee one object, whatever you are passing here, that employee one object is passed to here. Now from the employee one object, it is picking the get salary. So what is the get salary here? 24,000. Right? Now 24,000 is greater than 25,000. So obviously it is false. Right? So then that's why it moved to the else condition and this is what printed. Now let's do one thing. Let me verify. Let me change the salary from 24,000 to 26,000. Then same scenario will be repeated one more time. So now guess this will be printed, right? So this is how we can define the predicates for any given input type, object or values, what we defined at the predicate type level. So we can define any complex conditional checks as part of single predicate implementation. See, for example, assume tomorrow I have a requirement and I want to see salary is greater than 25,000 and okay, people, I would like to select employees, gender is what? Maybe female. I want to make sure this kind of condition check. So some requirement point of. Then what you can do? As part of this predicate check level itself, you can define employee greater than salary, get salary is greater than 25,000, and you can define employee gender is female or not. So that you can use that new predicate wherever you want. In a single shot, it is going to verify the employee salary as well as the employee gender is matching or not. In a single shot, it is going to verify, and you can reuse that condition, or maybe you can reuse that predicate in any conditional statements level, or maybe anywhere else. A function is expecting a Boolean argument also. So there also, if you want to pass dynamically data, you can use the predicates. That is what happening in the Stream API when you are using the filter methods, especially. So filter methods are always expecting generally a Boolean value function. So those there we can provide simply predicate implementation so that internally filter method will execute this logic implementation and then it will try to pick up all the values which are satisfied the conditions, right? So this is how we are going to use the predicate implementations. So now let's start discussion about the other default and static methods available inside the predicate interface. Okay. So before entering into the default methods, what we can see, especially in this case, first one is called as and second one is negate and as well as third or methods. So if you maybe somewhere else we heard about and negate as well as or operators, right? So it's nothing but in our Java, when we are learning in our Java, we have a concept of logical operators. So what we have logical operators in this case? So we have something like AND operator as well as OR operator as well as negate operator, right? So in this case, what is the meaning of it is both are true. I mean conditions all are true, then you will get the result is true, right? In this case, either of them is true. So when you are having either of the conditions are true, then the result is right. Otherwise, false. That means both are false. Both conditions are false at right hand side and left hand side. Then that means both are false. So then the result is false, right? So, and when it comes to not operator, what we know, for example, when you have true operation and you want to make it as a negate operation, nothing but negative way, just opposite things. So when you are applying negate, what is going to happen? It is becoming false. Similarly, when you are applying negate of false, it will become as a true, right? So these are all logical operators we remember, right? So same thing here also we are going to achieve by using these three methods, but with respect to predicate implementations. That means as by using predicate implementations, when you want to combine or when you want to congest couple of predicates and you want to get one more final predicate, okay, so we can use these methods. So that means in this case, what is going to happen? Just guess now. So in this case, what is going to happen here? It is, for example, I have predicate 1 now, okay, and I have one more predicate also. So I can define predicate 1 and something like predicate 2. So in this case, what will happen? P1 is nothing but just this AND is operating. So this AND is operating now as a logical AND operator, what we discussed in the just right now, right? So that means now P1 predicate is true, and as well as P2 is true, then only you will get true result in this case. Then only will get true results in this case. Same, it's just like similar to logical AND operators. Now similarly the OR method, whatever we saw right now, like predicate 1 dot OR of predicate 2, if you apply, what is going to happen? The result. So when you're passing any value to the this final predicate, wherever you are applying the conjunction with the OR method, either of them is true, then you will get true result. If both are false, that means the result is what? In case both are false, then only you will get the result as false. In other scenarios, you will always get a true, right? So same kind of functionality we are going to achieve with these methods when you are using the predicates. Now similarly, we have one more method called as negate, right? So negate is not taking any input parameters. So that means if you apply p1 dot negate, that means predicate 1 dot negate, what is going to happen? So once your predicate is executed, whatever the result comes, it is just going to convert it into the respective opposite value. For example, predicate result is true, then negate will apply with respect to false. So if predicate result is false, okay, then if it is false, then it will be given finally as a true because of negate operator. So this is very simple when we are understanding the logical AND OR operator as well as negate operators. Where there we are having operators concept, here simply they provided as a methods with respect to predicate implementations. So what I will do in this case, let me quickly define couple of examples in this case also. So see here, I already have a employee salary check, right? So let's take same example only. So where I would like to verify gender is female also. So what I'm doing now, I'm just trying to make sure creating one more predicate, okay, for the employee, and I'm just checking it's all gender check, whether female or not. What I'm doing is just making female check. I'm just doing every with respect to employee object, employee information, okay. So what I'm doing in this case, yes, employee, when I got an employee object, I'm just checking like employee dot get. Okay, sorry, we don't have any gender property in the employee, right? So let me create a gender property to fulfill this requirement. So let me add a new property quickly, string, and followed by the gender. Okay, so let's add setter getter methods also. Source generate setter getter methods for the gender also. So yes, now I just added gender property, right? So let's see here now. Go to the here. Now let's just get the gender. Okay, is it equals to dot equals or ignore base? Just I'm checking whether female or not. Whether female or not. Okay. So what I have written now, one more predicate I have implemented with respect to female checkpoint. So now total, this is for only verifying the employee salary. This is verifying for the employee gender, especially female or not, right? So, but if I want to execute this requirement and like AND operator point of view, it should be greater than 25,000 and at the same time gender should be female. So then guess it's what you have to do. You have predicate number 1 and predicate number 2. So that means you just need to combine both with the method called as AND method. So that means let's see here what I will try to do. I will pass an employee object. Okay, so what is the employee object we have? Employee 1, right? So what I will do, employee 1 dot set gender of female. So I just given gender as a female in this case. Okay, fine. And then next, what I'm going to do, apply both predicates with the AND operator. So what is about my first predicate? Salary check. And the next predicate is all about female check. And for the person or for the employee object of E. So now guess what is the expected result in this case? What is the expected result, whether it is a true or false in this case? Yes, employee 1 wise. So having 26,000 salary, yes, true. And similarly, one more predicate you are applying female check. Yes, employee is also female. So that means you are true as well as true. You are getting for the employee one object. So final result is, so let me take it as Boolean. So that's what the meaning of Boolean valued functions when we are discussing about the predicate introduction. Okay. So let me just make sure very clearly what the output you got with the result. Okay, so just understand the last statement, what it is being printed. So what it is true here, it is printed. For example, assume now the employee is male employee. So we know that whenever we are using AND operator or logical AND operator point of view, the same functionality we are seeing here also, right? So employee salary wise, yes, true, but when it comes to female check point of view, it's getting false. So that means true and false, it's all about false. So based on the AND operator, right? So let's see the result now, whether it is false or not. So yes, it is false. So that's all. It's very simple, very straightforward when it's similar to logical under logical operators, but there we are using operators. Here we are using methods with respect to multiple predicates. One predicate is nothing but one condition we can consider like that. Now guess what is the meaning of OR method? So when you are opening the OR method implementation, okay, so you are just taking or returns a composed predicate. So that is going to apply logical OR operator. Means either of the condition is true, then it will work. For example, assume you have a requirement like you want to verify salary is greater than 25,000, or you have a requirement like gender is male, something like that. So then what you can do? So you just apply both the filters with respect to OR operator, what is going to have. See the result now. So let me copy paste this and I will remodify to the R method here. Okay. So good. So now let me print my result. Okay. So here what method we are using? OR method. So employee salary, yes, greater than 25,000, true. You know that whenever first condition itself true, then the entire OR operation will become true. So it will become irrespective of female check. So let's see whether it is true or not. So it is printed. The reason is employee salary wise good. Now let me make employee salary as below 25,000. So that means in this case, what will happen? Employee salary wise false as well as female check wise false. Then false or false, it's nothing but finally false. So let me execute. See here again, this one also became a false, right? So now similarly, what about the negate method? Do you need to worry about the negate method? So that means it's nothing but simply printing the opposite value. For example, see what I'm doing. I'm just applying negate one of the predicate. For example, I want to make sure female check dot test of employee one. Okay, so I would like to print if it is female check. I want to make sure not female. I want to filter employees off, or I want to find out male employees by using the female check. That what we can do, simply we can apply the not operator, right? So similarly here also what you can do, yeah, simply apply the negate method now. So then just see the result now one more time. What is the result? So you know that now with respect to employee one, what is the result? For example, let me make it as female now. So now with respect to employee one, yes, female check wise, you are going to get the result true, but you are applying what? Negate operation. So that means the true result is becoming as a false. Okay. The true result is becoming as a false. See here, false. So that means condition became true, but result given as false. It's just like the entire predicate result is converted to the opposite Boolean value. That's all about the negate method. So this is very simple related to the logical operators. Okay. So you can congest any number. I mean, that means you can combine any number of predicates or you can join any number of predicates. So that is all about the predicate default methods. Okay. But when you are observing here, we have one more method called as, but it is static method. It is equals of an object target reference. So what is the meaning of is equal here? What is the meaning of predicate. What predicate is doing with the is equal method here? Let me explain you here in a very clear picture. Okay. So here, generally the purpose of, if you observe here what these guys are saying, returns a predicate that tests if two arguments are equal according to the objects dot equals of method. So when you go to the objects class, generally you have a equals method. Inside that, generally they will check the equality of object content, right? So for example, assume in object 1 you are having same content with respect to properties. In even object B also you are having same content. Then equality wise both objects are same, right? Content wise internally. That is what the meaning of equals method. So similarly, in our requirement point of view, for example, assume, okay, so your requirement is what? I want to take one employee. Okay, one, for example, assume I have an employee, or based on this employee property values or whatever it is, I have to validate other employees. Have to validate other employees. So let me give you an example in this case. But one thing what you have to do here it is, in this case we have to override, okay, inside employee class we have to override equals method. What it is, based on the equals method we have to override. So then internally the overridden logic of equals method is taken care by the equals method, what we are calling on top of the predicate, and when you are passing this an object also. So how the things are going to happen? Let's open the employee class and let's define the the equals method also. Okay, I just defined now an equals method. So what we are doing, just it's all object type, so superclass type, typecasted to the employee, and I'm just checking employee ID, employee ID with respect to object was 1 versus object 2, both are same, then I'm feeling like both employees are same. So that is what I written the condition here with respect to equals method implementation. So now see how I am applying the predicate here with respect to, so predicate, I'm just defining again one more predicate. Okay, predicate of employee, yes. And what I'm doing, I'm just taking like base employee. So what I'm doing here it is predicate of, so this is all static method. We cannot use any other instances like what however we done for the or and and methods in previous cases, right? So it's static method we have to call always by using the specific interface name. So is equal method I'm just checking, and what is the base employee I would like to pass here it is employee 1. Now I would like to compare another employee with the employee 1. So how can I do that? So what I will do, let me create a new employee quickly, something like that. Okay, now see here what I'm doing by using this predicate. So that means I'm just checking this current employee is really matching to the, so with respect to this predicate, I'm just testing the current object, whatever I'm passing here, both are matching or not. So what? That is what I'm trying to match here. So in equals method, what we've overridden, we are just overridden with respect to employee ID, both are matching or not. If both are matching, then we are returning true. So if not matching, then we are returning false. So that means now guess what is the result here it is. Okay, so let me execute and observe the last statement now. What it is? False. That means what is the point here it is? Both are different employees. Now let me make, for example, employee ID 111 in the employee 2 also. So what I'm doing, base here, if you observe here, base employee, you just take an employee 1. So that means employee 1 is equal to E2. That is what the meaning of this line here it is. So what it is, employee 1 is testing with the employee 2 with respect to equal functionality. So but as part of employee functionality, what you return, you just return if both are true, then only you are considering both objects are same. So but in this case now, yes, based on employee ID, you are saying like both are same. Okay, so here also 111 and here also 111. So 111 dot, 111 employee is equal to 111 employee. So that is what we are verifying. So yes, it's true, right? It is true. So this is how the equals method, is equal method is going to work inside the predicates. It's simple. One argument you have to verify with another arguments based on your user defined implementation as part of the equals method. So when you want to verify the comparability, or maybe when you want to verify the equality of object content, then you can use this equals methods with any object, Okay, so this is all about the predicate functional interface, and we are done with all the methods from the predicate functional interface. Okay, so now let's start discussion about the another functional interface called as consumer functional interface. So as of now, in function and predicate interfaces, we observe like taking some input arguments as well as returning a value also, right? But when it comes to consumer, yes, if you are understanding the meaning of consumer, it is going to consume an argument, nothing but it is going to take an argument type, one single argument, and it will not return any value with respect to consumer functional interface functionality. So then you can ask one question. So what is the meaning of taking an argument in as an input and not returning any value? So that means what kind of scenarios we are going to use this consumer functional interface, right? So let's try to have a scenario oriented solutions even related to the consumer functional interface. Okay. Okay. So here the consumer is giving a definition something like this interface accepts one argument, but there is no return value. No return value. So that means in what kind of scenarios we are going to use this kind of functional interface implementation. I'll try to tell you one or two scenarios here it is. So I just created a new class for consumer examples. Okay, let's take a example like this. For example, I have list of values like names. Okay, and I want to print all in uppercase. So what I have to do? I have to print everything in the uppercase, and I have named something like ABC, comma XYZ, comma okay MNO, something like that PQR. I have names like this. So, but I want to print everything in the uppercase like that. So what I have to do? So what is my requirement in this case? I would like to take each and every argument and I would like to print everything in the uppercase. So what I'm doing, see here now, I'm just taking the consumer functional interface now. And what is the object type? Here it is this type string, right? So let me take to print an uppercase equal to, so whatever the value I'm getting, string dot out dot println, right? And just need to make it as to uppercase. Right? So this is what I have written here. So this is how I written my consumer. Now how can I process? So even I can use individually this consumer also. For example, what I can say, and what is the method available inside the consumer? So if you go to the consumer, so what is the abstract method available here? The main method, accept method as part of our functional interface consumer, right? So we are providing implementation to the which method now? Accept method. So performs this operation on the given argument. So that means whatever the operation you defined as part of implementation, so whenever you are calling accept method, the same thing will be performed by the consumer implementation. So you have, for example, like given delete sync. Now in this case, guess what is going to happen? So the delete sync value is just passing here, and that is just passing here and converted as uppercase and finally printing when you are calling the accept method. So let's see. Fine, right? So that is also fine, just like an example. But what about these values? So generally nowadays, when you are just using the couple of methods like for each method from the list, yeah, for example, if you go to the list, like my list is names dot and for each. If you observe here, what is the for each method argument type? Consumer type. So that means they are expecting a consumer type implementation as part of for each method. So whatever you defined as part of the consumer implementation, in this case you defined as printing the uppercase. Tomorrow you can define any functionality based on the input argument, whatever you are having. You can define any functionality without returning a value kind of thing. So for everything, whatever you define logic here, that will be executed in the case of the consumer implementation wherever you are passing. See here now in this case, what is going to happen, guess? So from the list, from the names list, first name will be taken, and base for each means everyone one by one will be taken and applied the same consumer. So that means converted to uppercase and printed, converted to uppercase and printed. This is also converted to uppercase and then it is printed. Like that, every value will be converted and as well as printed. So see here now, this is all you got in the uppercase like this. So what you observe here, it's taking input value, it's just processing but not returning anything. Here it is. In such cases, you can define the consumer implementations. Okay. So this is what one example I can give you. And one more example what I can give you here it is. For example, assume I want to add the uppercase values to a new list again. What I have to do? I have to add the uppercase values to the new list again. So what I'm going to do now, so I'm just taking consumer of, here also string, and I will just make it as add to list. So what is the value you are getting? Always string, right? And what you can do, so just define a new list also. So the new list with uppercase values, like what I will do, list of string new values, something like that, equal to new array list. So what I'm going to do, new values dot add, I can pass here, right? I can pass new arrays here also. So in this case, what is happening? You are just passing input as a string value and you are just adding to the, you are processing that value and you are adding to the array list, but you are not returning anything here. So now what you can do? So let me call this consumer also now. So what I'm going to do now? So same thing, I'm just trying to pass again names dot for each. What I'm passing this time? Add to list. Add to list. So in this case, what will happen? Taking values from the names, converted to uppercase and added to the new values. So let me print now the new values is really contains all uppercase values or not. So let me execute program. So see here, it just what it is printing only lowercase values. That means so what I'm doing, I'm just converted to uppercase. So now see, it's just like added all uppercase values from the old list to the new list. So like that, whenever you have a requirement, you are processing the value and you are just making kind of some operations, but you are not returning any result back to the the consumer column. So then you can go with the consumer one. So, and even when you observe the consumer, we have one more method called as and then methods. So it's just again, it is just like similar to our function and then method only. So it is just going to compose couple of consumers by using and then method. So what is the point here? It is and then means when you are having consumer 1 and consumer 2. So when consumer 1 is happened, and then it is going to execute this respective consumer also. So that is how you are going to define and then method as part of consumer. Like it is similar to function and then methods only. You just refer the function example and you just follow same thing as part of consumer. Same behavior it is. Only thing is you are not returning any values with respect to consumer. That's all. So this is all about the consumer functional interface. So now let's go back to the supplier functional interface. So what is the functionality of supplier interface? Now we will have a look here. So let me open the supplier interface once. So if you see here, supplier interface, we have only one method called as get method as a abstract method, and we don't have any default or static methods inside this interface. But at the same time, this get method is not taking any input value, but it is trying to return a return value. So that means it's not taking any as an input as any argument, but it is returning some type of values always. So what is the meaning of this is we will try to understand. So just like this interface has to act as a supplier of a results, nothing but assume I want to get database connections always by default. I don't want to pass any information, but I want to get a DB connection every time whenever I'm calling the supplier get method. Okay. So that means you are going to provide implementation to the get method. Inside the get method, you are just providing all the logic to make the database connection or getting the database connection, right? So whenever I'm calling the get method, I used to get always a new database connection to perform my database operations. So that kind of examples I can take here. Okay. So that is the meaning of supply heritage. It's just supplying the object, supplying the different values when you are calling the different number, different times you are calling the get method, you are going to get different results. That is what the meaning of supplier functionality here it is. I just created a new class for the supplier class. Okay. And then what I'm going to do here, see, for example, I want to get date and time always. Okay. For example, this is how I have a requirement. Now see what I'm doing. I'm just taking supplier here also, and I'm just taking kind of local date and time. So that means what is the value I'm going to get as a result always is local date and time instance. Okay. Date, time equal to. So what I'm going to do here. So you know that it's not taking any input or method arguments. So the get method especially, right? So that means zero arguments. So what I'm going to do now here as part of implementation, local date time dot now. So that means what is going to happen, guess now, whenever you are trying to call this supplier, every time this implementation will be executed, and this implementation should has to return always this type of object. So tomorrow if you are making something like database connection, if you define DB connection class name here, and whenever you are processing the database details and you are making a database connection, you should return your this implementation should return the database connection object whatever you declared here. Then whoever is calling this your supplier, they are going to get the database connection always without providing any input values, or maybe without sending any data. You are always getting a dynamic database connection. In this case I'm going to get a dynamic time also with respect to my supplier implementation. So see here, for example, date time dot, what is the method? It is get method, right? Get method. So you're going to get which object? Local date and time objects. So this is the get method belongs to the supplier interface. So let me test it now. So see here now, what is the time you got? It's just like 23 and 5404, right? So let me execute same example one more time. So see here 23, 54, 13. So that means the data is changing always. It's like 17. After 1 minute, you will get like 55. So that means it's keep on producing the results. Whenever you're calling now next, maybe for example, assume you're calling again second time also, or that means what is going to happen? It is going to give one more results. Same results or maybe different results it may produce, depends on our logic implementation as part of this method. Okay, so you got the point. Even sometimes, I mean, we can pass the supplier instances to the other methods as an arguments also. For example, if you see here, what I'm doing here it is, for example, public, I'm defining a method, something like static method, whatever it is, and void print current time now. Okay, so just I'm writing a method like this, and observe here how I'm defining a method here with respect to suppliers, and what is the time I'm going to pass here. It is local date and time. Okay, so date, time. So I'm just passing here. So what is the method argument type here? It is supplier type, which is accepting, or sorry, which is returning always a local date time object. So similarly, you can define any type of objects here, and you can pass that supplier object as a method argument also. So see here, now how I am calling this method, print dot, what is the, sorry. So I'm going to call this method, I need to pass what, supplier object. So I already have a supplier object, right? So let me call here now. So then what you are going to do now? So here you will receive always a supplier object. Let's call the method, and then you will get the time, and you can print it also. What we did, let me disable this code once. So whatever the supplier object you created here, that supplier implementation you provided here, you are simply passing that implementation or that reference to the another methods also as a method arguments. So similarly, the other functional interfaces what we discussed, predicate, function as well as consumer, those are also we can pass as a method arguments wherever we want. Okay, so you just try to explore how to pass the functional interface implementations as a method arguments. Okay, so let me execute now. What is going to happen? This, you are just passing this implementation, supplier implementation, you are passing to this method. So then overall it is contains this implementation here. So from that you are calling the get method of abstract method of the supplier class. So that means finally this will be executed, this implementation will be executed when you are calling the get method, because you know that this lambda expression is implementation of the abstract method of functional interface. So let me execute now. So see here, now you got the data. So but with this time I taken an example passing as a method argument also. Okay, so that is all about the predefined functional interfaces, which are very popular in our day-to-day functional programming, or when we are using stream API programming or in anywhere else, right? So most of the times we used to see these four types of predefined functional interfaces in our day-to-day programming. Okay, so that is the purpose. I just taken very carefully and I applied all the scenarios how to understand, especially these four predefined functional interfaces. And when you observe the, okay, when you observe the same package again one more time, not only these four, you can observe there are a lot of other functional interfaces available which are provided by the Java language. But what is the point you have to remember here? It is these are all the remaining all functional interfaces, whatever you can see here, it's directly or indirectly designed or derived from the four interfaces what we discussed right now. Okay, like function, predicate, consumer as well as supplier, right? So these four behaviors are represented in every other functional interface, whatever you can see here, it is okay. For example, if you see here consumer, we know that it is going to take one input, but it is not going to return any value. But if you see here by consumer, in the sense it is going to take two input values, but it is not going to return any value. But when you are understanding the function, it is going to take two arguments and it is going to return a value, right? But here these guys are saying like, yes, these guys are all saying they are going to take two inputs and they are going to pass values. Once you are good with these four types of functional interfaces, understanding and all, we can understand all these other functional interfaces which are presented in this package, because these are all directly or indirectly implemented from the four functional interfaces what we discussed right now. Okay, so that's all related to the predefined functional interfaces. Hello everyone. So right now I'm discussing about the optional class inside our Java language. So why Java is introduced the optional class in Java 8 version, and what is the purpose of optional class, what we are going to achieve by using optional classes in our day-to-day programming, we will try to understand in the today's session. And as well as you know that the importance of optional class nowadays being asked in interviews also, right? So when we will try to understand now, so why people are expecting more knowledge about the optional class and what is the importance of optional class with our in our session, we will try to discuss each and every point. Okay, so as part of today's session, the agenda here it is, I'm going to discuss why the optional class is provided and we should understand then the importance of optional class as well as where we are using the optional class, at what scenarios we are going to use the optional classes, and every method from the optional class. I will try to discuss each and every method from the optional class, and as well as I'll take cover all use cases as well as all couple of examples related to our optional class. So now let's start understanding why optional class is introduced by the Java language. Generally, the optional class will be called as a container class, nothing but when we are creating an object. So that means when we are creating an object for the optional, it should contain a value. It should contain a value, or else it should not contain anything. That means empty. But it should be empty or it should contain a value, but it should never contain a value called as something like null. Generally, we know that when we are assigning or when we are creating any variables in our Java language, or when you are creating an instances for any data types, what will happen? If you are not initialized any value, or if you are not initialized any instance or created instance, then what will happen? The default value for every reference variable of a data types, or for our classes, user defined classes or predefined classes, will become a value as a null. For example, if I return a class called as one class, and generally what I can do, one equal to null, I can assign like this, right? So here one reference variable is not at all assigned with any value. So internally sometimes default will become null, or maybe we will initialize null value also. But at the same time, sometimes if I am passing o1 reference to the some other method, if I am performing any operation on the o1 reference object, so that means assume o1 dot any operation, any method I'm trying to call from that predefined class or maybe user defined class, what is going to happen if I'm trying to perform any operation on the o1 reference variable, I'm going to get what? Null pointer exceptions. So we know that whenever, I'll just show you a small example also how we are going to get null pointer exception. So here in this case, what we are getting null pointer exception because the wo value here, the wo one value contains null here. So that's why you got the null pointer exception. To avoid this, generally what we will do, we will write always a null checks. So that means we will write down if O1 is not equal to null, is not equal to null, then only perform some activity. Then only perform some activity. So that is how we are going to make sure that specify logic implementation here, right? So inside I'll write down the logic now. So here I'll write down the respective logic or something like o1 dot method. So whatever I'm doing here, so that I can avoid the null pointer exception. But these kind of scenarios we are going to encounter on daily basis in our day-to-day programming. And sometimes we cannot expect or we cannot suspect also what value coming or what value is being written from one method to another method, okay, as part of a method parameter values, or maybe the written value coming from any other services, what we are going to get, it might be non-null value, it might be null value, right? So in such cases, it's very difficult to handle the null scenarios, and we used to get lot of null pointer exceptions, and those null pointer exceptions are clearly breaking our application functionality, and it is making lot of issues in every day-to-day programming. I mean, in every day in a real-time application also. So that's why people will worry more about the null pointer exceptions at one point of scenario. We used to take care of in every scenario when we are defining a value or when we are retaining a value or when after return receiving a value also, we will always we will always take care of the null checks to avoid the null pointer exceptions, right? So this will be called as generally null object pattern. So that means you have to take care an object is contains a null value or not. If not contains null value, then only perform the actual operations. If it contains the null value, make sure some other activity or throw some exception like value is not presented or whatever it is. You have to make sure a lot of manual operations. Now by observing all these scenarios, to what Java language is implemented, they given a solution called as optional class. So now the entire solution here it is optional class. Now here you can get what is the meaning of container, here it is. Okay, so optional class. And generally people are calling an optional class as a container. So that means it is going to contain a value always. Whenever we created an object for the optional class, we are generally the meaning of creating object for the optional class, here it is. And if you observe the optional class from our, so optional class is introduced as part of our util package. So let me open once optional class. Okay, let me open once the optional class in Java. Okay, so if you see here, this is what the optional class. It is located from the java.util package. And we are going to define an optional object always with a generic type. So we can define with any type. So that means we can define optional values or optional object with by providing any type of values. It might be string data, it might be any other predefined classes or user defined classes data types. Values we can store as part of the optional class. So why it is calling it as a container object? So generally optional is being called as a container object may or may not contains a non-null value. So why it is being called as a container object? Let me give you a small overview here also. So that means when you created an object for the optional class, okay, and you created an object for that respective optional class, what is going to happen? What here it is expecting is it should contain always some value, or else it may contain value, or else it should be empty, but not null value, but not at all a null value should be presented here. We should not maintain null value here. So what it is, we should not keep null values. So that means the optional class is forcing us, the optional class is really forcing us to maintain either a value, that means a non-null value, or an empty, instead of defining null by default. So that what is going to happen in this scenario is when you are trying to extract the original content from the optional class. So here the optional class now is going to return the original value what available inside the optional class. For example, assume I define a optional class with type called as string and I stored my value like I'm just passing a value, my name something like Dilip Panda. So in this case, the optional is created with data type called as strings, and internally you are storing what value? String value. So this is the actual value. Now whenever you are getting a value, so now optional class is providing lot of predefined methods so that we can extract the actual value what if it is presented or not. By cross checking if it is presented, we can extract the actual value. So we can extract the content. In case if it is not available, then optional class providing something like we may throw some exception, or we may set some default value, so that we are, in this case what is happening, we are simply trying to avoid the null pointer exceptions. That's why we can see the optional class introduction level, they definitely provided especially to avoid lot of null pointer exceptions in our day-to-day programming, so that we no need to write down always a null checks when you are using the optional classes. It's all internally forcing us something is missing or it is empty, you may wantedly throw an exception, or maybe you can set a default value when value is not presented. When value is not presented, you can set a default value here. Okay, so let's see how we are going to define optional classes in our programming point of view, how I'm going to handle the null pointer scenarios by using optional classes. First we will try to produce earlier how we used to get the null pointer exceptions, and as a solution to avoid the null pointer exception, how we are utilizing the optional class in our examples we will see. Okay, so before going into the examples, so I will just give you one more point here. So the optional class is provided multiple predefined static and non-static methods. So every method is having its own importance with respect to our day-to-day programming. So these are all methods we have inside our optional classes. So if you see here, we have couple of methods as a static methods and couple of methods as a non-static methods. So I will try to cover each and every method as part of our session right now. Okay, so we will see every method, don't worry. So now let's start creating a new project and then let's take an examples now. Okay, so see here, I just created an empty project optional demo and I'm creating a class now. So what I'm going to do right now here it is. So what I'm going to do now, my requirement here it is. Okay, so the requirement oriented I'll try to give you. So I have a string value and I have to convert it always to the uppercase. I have to convert the string value to the uppercase. That is what my requirement. So we have a predefined method to uppercase inside our string class, right? So now let me write down a program for this. Okay, so now I have created a class called as uppercase values. So inside that I just created a main method and I'm going to create one more method, public static string get name. So I would like to get a name from this method always, and I will return uppercase value of this method return value. So let me return a name from here always. So I'll return a name like Dilip Singh here. Okay, fine. So now I'll call this method from my main method. Okay. So see here, string name equal to get name. Right. So then what will happen? This value will be returned to the name. And I'm going to print now sys out of name equal name. Okay. So I will do one more thing. So what I'm doing now, name equal to name dot uppercase. I'm just converting every value to the uppercase. So I'm converting to the uppercase the received name value and assigning back to the same variable. And then I'm printing this variable. Okay. So just pass it and execute now, run as Java application. Okay, see here, I just given everything in the, I just given in the small letters and capital letters, but everything is converted to the uppercase. Fine. So whenever you are passing any value from here, so you are going to get a uppercase value as part of this line number 9 operation point of view, right? So even you can give anything. So even if you given empty space also, what is going to happen? So let's execute the program. So see here, you don't have any characters, but it is a valid string. That's why you don't get any exception and nothing is converted as uppercase. That's why it is printed again empty string. So if you're passing any values going further, everything will be converted as a uppercase only. Okay. So see here. Yeah. So it's converted as ABC. But what is the guarantee of we are going to get always a non-null value at this method call. So in this method call, do we have any guarantee of getting 100% non-null value? So you have any guarantee? No, because this method may return any value. For example, somehow this method is returning null value. Now what is going to happen in this scenario? Let's see here. Let me execute the same application one more time. So what happened now? Understand? You are getting a null pointer exception. Cannot invoke uppercase method of string class with respect to name, because name is a null, name contains a null value here. So what happened here? So you created a string value and you given name as, okay, so it's name. But you received, once you are calling the method, you received what value? Null value. And whenever you are trying to perform some operation on the null value, so something like null dot to uppercase, so we know that whenever we are performing any any operation on data, null data, we are going to get null pointer exception. So that is what the meaning of null pointer exception here it is. So how can I, so for this generally what we will do as a solution, so I will write down like this. As a solution, if name is not equal to null, then perform this operation. Name equal to, otherwise just leave it as it is and print the original value as as it is. So see here. Now in this case, what happened? It's a null value, so you are just written a null check here. Why you written this null check? To avoid the null pointer exception. To avoid the null pointer exception, and program should be executed without any errors or exceptions, right? So that's why you written that. So now you handle the null pointer exceptions. Yes, at one point of time, we used to take care of null pointer exceptions by applying the null checks wherever there is a possibility of receiving value as a null instead of actual value. So that is what the meaning of handling the null pointer exceptions or handling our null object pattern. But this might be a problem in every scenario, every class, every method level most of the times. So we have to write down n number of times always a null checks to avoid the null pointer exception, to reduce the null pointer exceptions. So now to overcome these problems only, Java language introduced a class called as optional class. So in this case, what Java is suggesting is, so whenever you're trying to return a result value, for example, here what I'm returning, a value here, right? So I'm returning a string value. So it might be any value going further. So I'm returning what? A string value. So whenever you're returning a value directly, what you have to do is you have to keep the rest, the actual value, we have to keep the actual value inside optional object. So that's why optional is called as always as a what? Container object. So that's why it's containing the value, containing the actual value. So that's why it is always called as container object. Now you got the point, right? So why it is optional classes are calling as a container objects. So in this case, what is happening? We have to create an optional object, and inside that we have to keep the actual value, whatever you are trying to return. So that value you have to pass here it is, or else, yeah. So how we are going to pass? Let's see here. Okay. So here generally what you are returning string value, but you should not return the string value. Now what you are going to do? So I'm going to make sure optional, okay, optional dot. Okay, so you know that. So here, whenever we are defining optional class, what data type value, what object or what values you are keeping inside the optional container or optional object, that data type you have to define as part of the optional generic type. So now my requirement point of view, I'm trying to keep string value. So that's why I given generic type as a string. Tomorrow, if you are returning any kind of other data type, something like array list, set, hash map, whatever it is, or any predefined classes or user defined classes, so you can define that and you can store that respective instances as part of the optional class. So what I'm going to do now here, optional. So here Java language provided couple of predefined methods to store the value or to put the value inside the optional object. So now in this case, what I'm doing, I'm just keeping a value inside the optional element or optional object. Okay. So what is that value? I'm just storing string value as a Dilip Singh here. And finally, I'm returning what value? Optional data type value from this method. Wherever you are calling this method, go here. So here we are receiving value as a string data type, but actually now getName method is returning what value? Optional type data or optional object. So what you have to do here it is, yes, just define return type with the optional of string only. So now finally get name method is returning what element? Optional element. So in this optional element, what is the value you are having? For example, you created value optional object, right? And what is the value you kept inside that? The string value Dilip Singh. The string value Dilip Singh, here it is. Now get name is returning the same instance, so that name is also pointing to the same optional value. It is what? An optional object. This is all completely an optional object, right? So this is completely an optional object, but inside that you have string data type value. So somehow you have to extract this value from the optional object. Extract value from optional object. So for that, what is going to happen here it is, so Spring provided couple of predefined methods. So what it is, so generally what we did in earlier case, we return null check so that then only we are performing the uppercase method. So we are using what? A operators we are using here. Okay, so we are just using the not operator, equal operators and everything. But here optional class is providing lot of predefined methods. Okay, so to verify whether really value is available or not, or the optional container is having empty, or is it contains any value or not, we have a lot of predefined methods from the optional class itself. So in this case, see here what I'm doing, I'm just removing this logic. Now I'm just rewriting the logic. Okay, so I'll just comment out so that we can see the differentiation also. Okay, so see here, if name is present, so if you see here, so that means name is what? Optional element. So I can, let me modify it as a name container. So now name container is present. There is a predefined method called as is present. So what this method will do, it will verify internally the container, the object, the optional object really contains a value or not. So yes, is it contains? Yes, 100% it is contains. Okay, then it will return the true. So if it is present, yes, then you can perform the rest of the operations. It is checking internally a value is presented or not by using this method. So is present is doing what? The name optional object is really contains a real value or not. Yes, if it is presented, then it will return true. If not presented, then it will return the false. That is what the importance of is present method here it is. Okay. So in case the value is presented, now what it is saying, it is internally verifying the value is presented inside the optional object or not. Yes, it is presented. Then somehow you have to extract this value now. So what you have to do now, you have to extract this value from here to outside, from the optional object to outside, and you have to make it as a string. You can assign it as a string data type value. So why? Yes, you defined optional element with the string data type, so that's why this value belongs to the string data. So to extract value from the optional class provided a predefined method called as get method. So what it is, that get method, name container dot get method. So what is the return type of get method here? String data type, because we defined optional. This optional contains internally string value. That's why it is returning string value always. And observe here, if a value is present, returns the value. Otherwise throws no such element exception. So what is the point here? It is, if value is really presented, then it will return the value. If value is not presented, then it will return the no such element exception. But in this current scenario, we have a value. We are already assigned a value, something like Dilip Singh here. So that you are going to get a value, from the container when you are calling the get method. So what is the value internally? It contains string data type value. So finally get method is returning string value. So assume tomorrow if you are returning optional of employee here, okay, so you are storing some employee object here. So then what? Get method will return what data type value? Employee data type. So you are going to define employee something like that here. Okay, but in this case, it's all now string values, so that's why I can taken string here. And now see, it's all, the rest is same. Whatever you want to do, name equal to name dot. Here I need to update to the uppercase. Yeah, so let me execute now. So see here, what is the value? It is printed Dilip Singh in the uppercase. But you return optional of deleting in the lowercase values, but finally it is converted to the uppercase and you achieve the requirement. In it, now you can ask one question or you may get a question like, so what we achieved from the optional class when comparing with the old solution. So in old solution oriented, you can check only null is available or not. If not available, then perform the activity and then you can do rest of the things. But in optional class, maybe, okay, so in this case it is giving same kind of coding, okay, but in couple of scenarios optional class is providing lot of other options. For example, when value is presented, you can do this thing. If value is not presented, you can assign a default value for that respective, or you can configure a default value inside the optional object. When your value is not presented, you can configure a default value or you can configure your own value as part of the optional object. Not only that thing, even when value is presented, you can do some of the activities. If value is not presented, you can configure a default value or you may throw an exception. Okay, whatever the exception you would like to throw, you can throw an exception also. So that means you have a lot of utility methods available inside the optional class. Those utility methods are going to help us to deal with when value is presented what we have to do, when value is not presented what you have to do. So those are all scenarios going to be covered by the optional class methods. So now let's see one by one how we are going to deal with optional class predefined methods. Okay, so one more scenario what I'm going to see here. Now total how many methods we have used from the optional class? Here two values. What is that? First one is off method. So why we are using off method? So the off method is always to store value inside the optional object. To configure the actual data type value inside the optional, we are going to use always a method called as off method. So it is going to always providing or configuring a non-null value. I mean, generally you are going to configure always a value by using the off method. So that means you are simply keeping a value inside the optional container. Okay. So, and second method, what you used, you are just cross checking really the container contains a value or not. So if contains, then you are doing the activities, right? So one more method we use called as is present method. Now, for example, now in this case, assume I don't have, okay, let's do one thing. I'll take something like string name equal to, okay, so I'll write down like this. Okay, I'm just passing name here. Okay, fine. So now, for example, sometimes assume name equal to null. Name equal to null. So string value somehow you got as a null value. So then what you can do, you the optional class is always encouraging us, or the Java language is always encouraging us, instead of writing the null values directly, or instead of returning null values as part of the method response return values, what we can do is we can configure an optional with empty we can configure an optional object with empty value. So that means, so see here what I'm going to do in this scenario. So I'll copy paste same example but I will cover one more use case. So see here now. So what I will do now in this case, when name equal to null, so what I can do, I will pass instead of, okay, returning null value. So what encouraging here it is, you can pass optional of empty. What it is? Optional of empty. So in this case, when if name equal to, if name is not equal to null, what you are doing? You are just storing optional of value equal to optional dot empty. So what is that value? Optional of empty value you are returning here. So when name equal to null, just return the optional empty. If it is not null, then keep that value again by using the off method. So what you are doing? So I'm just keeping the same value by using again off method. Okay, so I'm just passing value to the optional level. I'm keeping that value inside the optional container. And finally, I'm returning the what? Value. So that means optional data finally I'm returning here. Okay. So let's execute now what is going to happen. Else I'm going to write down. So you know that now is present method is going to cross check internally the container is going to contains a value or not. Now in this case name equal to null. So that's why you are returning empty container. What it is? It's just you are returning an empty container this time. So you're just returning an empty container. So it doesn't contain any value. Okay. So I'm just adding in case value is not presented. I'm just writing a sys out value is not available. Value is not available. So let me execute this example. Okay, so see here, value is not available. The reason is what? You are having null, you are returning optional, empty optional. So that's why is present is returns false in this case. So that's why you got else level and this value is printed. For example, if string is contains a value, a string is contains a value, something like Dilip Singh again. Okay, let me execute the same problem. So see here now you got converted value, uppercase converted value as a Dilip Singh only. Right? So this is how the optional class is encouraging us to use always either empty or the value presented optional container objects instead of returning null values. Okay, wherever there is a possibility of getting null values or returning null values, instead of using null returning null values, we can return the optional elements. Okay, so now let's move back to the one more use case or one more method. So how we are going to handle, for example, when optional level value is presented, that's fine, you're able to do something, you're able to do something. Now for example, when value is not presented, then what kind of methods or functionalities provided by the optional class when value is not presented, we will try to see now. So generally, even optional class is provided one more method called as isEmpty method also. So if you see here, I'm using one more method called as isEmpty method. So what is the optional value I received? Container name container here, right? Name container dot isEmpty method. So now tell me, in this case, what is empty in the sense is optional is empty? That is what the question. But this time what? I have a value called as Dilip Singh. So that means inside the optional, I have a value called as Dilip Singh. So it's not an empty. So that means what it will return? Is empty will return. So in this case, is empty is going to return false. False. Is present is returns which value? True. Because value is presented. The meaning of is present in the sense the value is presented. Is empty in the sense is it really empty? No. That's why false. So this is how the is empty is present methods are going to work as a vice versa point of view. So if you see here, I'm just writing is empty. So sys out of is empty is, if it is empty, yes, empty. In case if it is not, else, okay, then sys out of, see what I'm doing, I'm using name container dot get method. So you know that when value is presented, if you want to extract that value from that container, you are going to use what method? Get method. So I'm using this time get method so that it will return string value, and finally I'm converting to the uppercase. What it is? Uppercase. So this is how you can use the isEmpty method also. It is looks like opposite functionality of is present, but you can verify when optional is empty or not. Okay, so let me execute same example one more time. So see here, second time also what happened? It is printed Dilip Singh. Now let me execute, let me pass a null value here it is. What it is? Null value. Now in this case, what value you are returning? Optional dot empty. So when it comes to here, optional dot empty is present. So what it is checking in this case? Value is presented or not. Value is presented or not. Okay, so is it presented true? No, false. That's why it will come to here value is not available. Now in this case is empty is checking what is container optional, that nothing but optional object is empty, right? So that is what it is checking. Is it really empty? Yes, empty. So then you will see this statement. What you are seeing, you are going to see this statement now. So see here now. So value is not available with respect to is present came to else. With respect to is empty came to the if block only and saying like yes, it is a empty container because we are we are returning an empty optional object. So these are all couple of methods we discussed as of now. So what we discussed here it is was first thing is we are understood what is empty method is doing from the optional class. So it is going to return a empty optional object. That means inside an optional container, I mean we can say like inside container there is nothing. But if you want to keep something, a value, a real value, it might be string value, it might be any value, whatever you defined actually here, whenever you defined optional type and you define whatever the generic type here. So we would like to keep that value. So we are going to use always off method. So when you have a real values, we are going to use off method to keep those values inside the optional. If you don't have anything to keep value, then we have to make sure returning empty optional object instead of the null value, so that whenever any method or wherever you are receiving this optional result, so what we can do, we are going to use these methods, either is empty or is present method. Based on that we are going to define our respective logics. So here the main purpose of optional here it is to return, avoiding the returning null values, as well as we are trying to make sure cross check the null values presented or not before making any activity with the help of optional class. Okay. So not only these are all methods given by the Java language, so even Java is also provided. Yeah. So if you observe here now, so we are completed only couple of method of for return. Okay, keeping the value, storing the value, empty for what? Returning the empty optional. And we understood now one more method called as get also. So why get method? So whatever you are just storing as part of the off method, so from that optional object, if you want to extract the value, we are going to use always a get method. So it's going to return that respective data type value as a return value, get method. So that is what we used get method also here, right? So it's returning the value what you kept as part of the optional object. If you go to the other methods, okay, we completed is empty, so that it is checking really optional is empty or not. So is present is checking internally optional contains a value or not. Okay, so these two methods we are done. Now similarly, let's move to the other methods, why they given, why optional class is having couple of other methods, at what time what other methods we are here to use, we will try to understand now. Okay, so now what I'm going to do, I'm going to take these two methods now and I will explain you at what time you are going to use these methods and how we are how these two methods are going to help us when you are working with the optional objects. Okay, so okay, let's define a new class. So now I created a simple Java class. Let me define a optional object also first. Okay, for example, what I will do, I'll just use the existing logic only. So let me copy this value again. Okay, so I just define one again same method where it is returning depends on the value. For example, I'll keep some value here. First I'm keeping the lip sync. Okay, so that means you know that optional of the lip sync. So an optional object you are returning and it contains internally the lip sync value. Now the method what we are discussing here, this is the method called as if present. So here we are discussing about if present method. Okay, we do have other method called as is present. So we understood is present method in the previous functionality, previous example, like is present is internally checking the value is presented or not. If presented, true. If not presented, false. But here the method this time is if present. So in case value is presented, something has to do. That is what the meaning of it is. Okay. So let me do how it is going to work. Okay. So let's take the optional value. Okay. So string, there is a or something like I can take name. container equal to get name. Okay, fine. So here I got the optional element or optional object. Now from this, see the method. If present method is saying you have to define a consumer implementation here. So that means generally the meaning of consumer is what? When we are discussing about the predefined functional interfaces. So consumer is a concept where it is going to take a input value and it will process that input value based on the logic what we define as part of abstract method implemented in the consumer functional interface. And then it will not return any value. Once any kind of logic is applied on the given value, so consumer functionality is saying like it's not going to return any value. So that means if present method is going to return void, because if value is there, something we will write down as part of the if present method, something has to be done. If and at the same time you are not going to get result back if you are using the if present method. Okay, so see here what I'm doing now. In case if value is presented, take that value, okay, and convert it as, okay, and convert, or let me do one thing, sysout dot println, and here what I am going to do, the value dot to uppercase. So that means I'm finally converting to the uppercase. So what is my agenda here? It is I'm just, if value is presented, if presented, then the value will be converted to the uppercase and as well as it is printed. So like that you can define any method here. Sorry, you can define any number of lines of logic here. Okay, it's not like only one line of logic you have to implement. Okay, so any number of lines of logic we can define here. So that means the internal value of optional object is converting as a method parameter here for the consumer functional interface, and you are taking that value, you are performing lot of you are performing the logic by on top by using that value, but at the same time this method is not returning any value, it's just performing the activity when value is presented. Okay, so if value is not presented, then it will not do anything, simply it will come back to the next line. Okay. Similarly, we have another method called as if present, or if present or what we have to do. So that is what the meaning of if present or else. So that means the meaning of it is what? If present, do some activity like this. Do some activity for that available value inside the optional object. In case value is not presented, in this case this method is not doing anything, but here this method is helping us. If value is presented, something has to be done. If value is not presented, something has to be done. So that is what the meaning of if present or else method here it is. So see here now what I am doing, optional. Okay, so before discussing about this method, I'm going to execute the program once for the previous if present method so that we can understand if present or else method easily. Okay, let me execute now my application. So see here, you got the uppercase of Dilip Singh. Why? You kept Dilip Singh inside the optional and you return that. So here, really inside optional element you have a Dilip Singh value. So that's why a value is presented. So Dilip Singh taken and that Dilip Singh is converted to uppercase and printed. So that is what happened as part of this. Now for example, what I will do, I will make sure this one as a null, string name equal to null. So that means whenever null, optional is what? Empty optional. Optional is a empty optional. So that means do you think the value available inside the optional object? No. So that means if present internally there is no value, then what is going to happen? So see here now. So yeah, if you see here what happened, you can't see any exception. We don't see any exception. So that means simply if value is presented, something is happening. If value is not there presented, okay, we are not receiving any exception or we are not receiving any errors also. So that is what the advantages of optional classes. Now let's move back to the if present or else. So that means now you can guess with respect to if value is presented, then this is what going to happen. If value is not presented, then what you will do. That is what we have to define. That is what is explaining this method. Okay, let me write down same functionality one more time. Okay, so but here if present or else what you have to do. If present, do something. If it is not there, do something. That is what the meaning of it is. Okay, let me do. So see how many method parameters we have to pass this method. One is consumer. That means when value is presented, consumer logic is going to be executed. If value is not presented, then it is going to execute the runnable activity. Okay. So that means see here how I'm going to write down. Okay. So for example, I'm just writing directly lambda expression notation for the first parameter. So in case the value is presented, so yes, comma, second, in case the value is not presented, runnable activity, 0, okay, 0 activity. So that means in this case what? When value is existed. So here the second method parameter, second param. So what it is saying? So when value is not presented, execute some default logic or something, perform some default activity, whatever it is, I can say. Okay, default logic. So you have to do execute here. So now in this case, what I am doing, same activity I will try to make sure system.out.println. Okay, so and value dot uppercase. Value dot uppercase. So I'll write down one more statement also. Value presented. So converting to uppercase. Okay, fine. Now, in case value is not presented, that is what talking about the second method parameter. So whatever the logic you have to write down here, you can write down. So see here, sys out value not available. So value not presented. So value not presented. So I'm just returning default value or logic, something, whatever it is, any kind of logic we are going to implement here it is. Okay, so fine. So what we understood here now, if present, when value is presented, okay, if or else, if value is not presented, then this logic is going to be executed. Now let me execute the same application one more time. So with respect to this line, what is going to happen? You are returning the null. So that means name is null and you are returning optional of empty. So that means value is not there. Then it will execute this line this time. So let me execute now. So see here, value not presented. So I'm just returning default value or something like I'm just going through the default data point of view. We return this statement. So what? When value is not presented. Now what I'm doing, I'm just making again passing a value as part of my string name. So in this case again, what is going to happen? So if value is presented, so then returning the optional of name, right? So this time value is presented. So then what is going to happen? This logic is going to be executed. This first method parameter consumer is going to be executed. So if you don't know more about the consumers, please refer the previous video created for consumer functional interface. So let me execute now one more time. What happened? So this time value is presented. So converting to the uppercase and the value is converted to the uppercase. Okay, the value is converted to the uppercase. So you got now what are the two methods about the if present and if present or else. So that means simply I can say when optional contains a value, okay, whatever the activity you are doing for that value or with respect to that value, then you can go for the if present method. But your requirement is demanding when value is presented, something we have to do. When value is not presented, something we have to do. Then we have to go with the method called as if present or else method. If present or else method we have to utilize. So when value is presented, the logic whatever you define here. When value is not presented, the logic what you define here, everything will be executed. Okay. So this is all about these two methods. Okay. Now let's see the other methods what we have here also. Yeah. So if you see here, we have couple of other methods also called as or else get, or else throw, something like supplier point of view. So what I will do now, I will try to make sure explaining about these methods, this set of methods one by one, because these are all methods are interrelated. I mean interrelated in the sense we can understand very easily when we are going through the one by one. Okay, and one method is having somehow a relation with the upcoming method with respect to these methods here. Okay, now let's start understanding about these methods also. So here also I'm just creating one more optional demo class. Okay, so to implement those methods, point of view, optional or else methods. Okay, so what I will do here also, I will just try to use the previous logic here also, only getting empty optional or maybe an optional with the value. Okay, fine. Now let me get this optional element in the main method. So optional of string data type, and here name container equal to what? Name container equal to get name. Okay, fine. Okay, so now see the methods what exactly of or method or else method, all these things and all we will try to understand step by step. Okay, first let me go through the a basic theory what a method is doing and all out of these three methods, out of all these methods. Now if you see here what or method is saying, when you are, if a value is present, returns an optional again. So that means if value is presented, then it is going to return an optional describing that value. Otherwise, returns optional produced by the supplying function. So that means the method or method is taking a supplier implementation as a method parameter. So that means the lambda expression implementation or maybe the functional interface of supplier, we have to provide implementation for the single abstract method, and that logic is going to be okay, returns whatever. I mean that logic is has to return always an optional element. That is what it is saying. If value is presented, the value will be returned as a optional only. If value is not presented, then supplier coming into the picture. Then supplier coming into the picture. So let's see whether it is true or not. Okay, so what I'm going to do now here it is. So that means what R method is saying, the R method, if value is presented, then it will return same object. It will return same optional object. If value is not there, if value is not presented, then supplier functionality will produce another optional with value. So that means simply we have to implement a supplier, and that supplier has to take care of the logic implementation. I mean returns the optional object in this case. Okay. So I have now what? Name container dot or method I am taking here. Now you know that the meaning of supplier functional interface. Okay, so supplier will not take any input parameters. Supplier will always provide supply the objects. Okay, but it will not expect any input value as part of the supplier functional interface. Even in previous session, I explained very well about the supplier functional interface also, along with the consumer predicate and functional interfaces. Okay, so now let's provide the method implementation of supplier functional interface as part of our method, as part of our method. Here it is. Now see here, supplier, you know that method parameters are always 0 method parameters. So what I will do here, okay, so I'm writing lambda expression notation here also. Return optional of the actual value. For example, I would like to return a value. And then I'm writing a method called as get method. So that means in this case, what is going to happen, guess? If value is presented in this container, you are going to get the same value. If value is not presented, then you are going to get this value, right? So that means what I will do here, it is, I will write in a different value, Java optional value, something like that, Java optional or value, something like that. Okay. So now let me execute my method one more time. Okay. So see here what I'm doing. I'm returning optional of empty in this case. So first I will execute with the optional of empty. Here I forgot to take something reading or receiving that value because everything is a string, right? So I just taken the result as a result and I'm just printing now. Okay, so result I have printed now. So let me execute now one more time. So Java optional value. Why Java optional or value? I mean Java optional value or method value. Okay, I'll re-execute one more time. So that means Java optional or method value. Why it is returning? Because optional is empty. It doesn't contain any value. That is what our method is saying. If value is presented, returns the same optional object value. Okay. In case value is not presented, then the optional object, you have to return always an optional object again by keeping some content inside the optional element, optional object level. So that is what supplier functionality is making here it is. So that is what the meaning of it is. So now guess what is going to get here. For example, now again I'm giving value as the lip sync. Okay. So in this case, what is going to happen? It contains the lip sync and the lip sync dot R method. So R will verify value is presented or not. Yes, value is presented this time. So that return same optional object value. So that means it will simply goes to the get method. This logic will not be executed. So that means you get method will return always the value available inside the optional object. So that means the lip sync will be printed now. So let me execute now. See here. Now the lip sync value is printed here. Okay, so that is how the R method is helping us. So simply R method is producing another optional object with some configured value or configured data or configured objects. Another optional object we are going to receive with R method when value is not presented. When value is not presented inside the optional object. If presented, you are going to get the same value you are going to receive it. Okay, so that is what the meaning of R method here it is. So this value is returned in case value is not presented. If value is presented, then respective value is printed or returned from the get method, Okay, so that is how I can define the R method. Now let's move back to the one more method called as, if you see here, or else method, and it is also going to take a method parameter of type. So what or else method is saying? So we discussed only or, right? Now in case or else method, so that means see here, if a value is present, returns that value, otherwise returns other value. So what is the meaning of returns other value? Here it is. Let's try to understand. If value presented, if value presented, okay, return that value. Okay, it is going to return the same value. In case value is not presented, if value not presented inside the optional, then what is going to happen? Here it is, okay, we can configure another value and that will be returned. So that means when value is absent, that means value is not presented, then whatever the value you configured as part of the or else method, that value is going to return always. So that means I can say like as a kind of backup value or default value we are going to get when value is really not presented. Okay, so let's see what is going to happen with the method of or else method now. So name container dot or else method. Okay, so here see here string value it is expecting. Why? The reason is name container is of string data type. You are dealing with the only string data type. For example, assume tomorrow you are dealing with the some a user defined object, something like employee object, optional of employee, and you are keeping employee object inside the optional element or optional object, then optional of employee and something like employee container. Okay, so here or else method is going to show you as a what employee object you have to store here. You have to store always employee object. So see here what I'm doing. This is or else method value. This is or else method value. So what is the return type of this method? String. Why? So because the optional internally what type of value you are storing? String value. So that's why that is what it is making. So let me make sure printing result I will reassign one more time so that I already have a result variable. I'm using it. Now guess what is the output you are going to get in this scenario? In the last, what you are going to get? Are you going to get Dilip Singh or are we going to get a statement like this is or else method value? So definitely it is going to return Dilip Singh value. Okay. So let me make sure now. So see here, it is returning the Dilip Singh value because or else is saying what if presented return same values. If not presented, the value what you configured here that is going to be returned here. That is going to be returned here. Now let's see here what I'm doing. I'm just making null in the sense empty optional you are returning to avoid the null pointer. So now in this case, or else method will verify, okay, optional contains any value or not presented. Then the value point of view, it is going to return into this result variable. So now you are going to get this value in place of absented value, okay, as part of the result level. So let's see now. So now see, this is or else method value. So you got the or else method now. So you have to understand two things here. The difference between or method as well as or else method. So the or method is saying when value is presented, you are going to get the same value again. But when value is not presented, you are returning what? An optional object. You are returning another optional object with some other value. But in this case, they reduced the complexity somehow like that. I can feel or we can feel okay what instead of returning the optional object okay along with a value like or method, so what these guys are doing, they are directly returning the value okay whatever you are trying to extract from the optional object. So they are trying to give always direct a value. Here you are going to get always an optional object. So from that you are calling the getter method, from that you are calling the get method. Okay, but here you are directly getting value. So that means I can consider internally they are calling get method to get the value from the container object of optional. Okay, so that is what going to happen with the or else method. Now similarly let's understand about the other methods. Okay, what somehow related to the same methods. Now see here or else get and supplier method. So supplier method parameter. So what is the meaning of or else get here? It is if value is present returns the value. So that means in the last two methods and the current method is saying always when value is presented it is not going to affect. Okay, those methods are always going to give chance to the available value. So in case the value is not presented, otherwise returns the result produced by the supplying function. So what it is saying, it is somewhat related to our method or not? Yes, looks like, right? So in our method also we have a supplier, but here also we have a supplier. But what is the difference between R versus R else get method with respect to supplier functionality? We will try to understand. Okay. So here you are getting optional. Here otherwise returns a result produced by the supplying function. So what it is and all, let's try to see here. So name container dot which method we are using, or else get method, or else get method we are going to use here. So I will define the logic. So or else get and method with supplier method parameter. So what it was saying, so see here now, it is just saying like value is present, returns the value, otherwise returns the result produced by the supplying function. So that means you have to provide a function here for the supplier functional interface point of view. So you know that again, whenever it is a functional interface, supplier no method parameters. Okay, no method parameters, but you have to return a value here. Okay, so see here, this is or else get value. Okay, so that means in this case what you are doing, you are providing supplier function implementation with the help of lambda expression, and you are returning what this time also, this is contains string value, this contains always a string value. So that's why, so R method what it is doing, it's not directly returning the value. Again you are keeping a value inside the optional and then you are returning the optional object. But here this is what doing what, in case value is not presented, then it's returning some other value, it's returning some other value, but with respect to supplier functionality. So generally now it looks like somewhat related to or else method also, right? Or else method also extended to or else get method. What is the difference between or else and or else get method? So or else is going to give the another value when value is not presented, right? So in this case also same thing. Then what is the difference between or else and get? So here get method is internally using what, a supplier functionality, a supplier method parameter. Generally the supplier behavior is always returning returning, okay, different values at different times. That is what the meaning of, okay, supplier functionality. But somehow we are just hard coded the value, but generally you can define, or you are going to produce randomly a different objects by using the supplier. But here it's just like static, nothing but you're always returning same value or same object or same thing every time. But here as part of the supplier you may produce different objects based on the logic whatever you return here, whatever the logic you are going to based on that you are going to return the result here. So it might be dynamic data, dynamic result, always you are going to get the supplier from the supplier, and when you are using with the or else get method. So when you have to return always same value, go with the or else, or your value has to return based on the some logic execution. So there might be a chance of dynamically returning the when the actual value is not presented in the container, then it's better to go with or else get method. Okay, so let me show you now. So what I'm going to do, null, right? So that means optional empty. So that means in this case, value is not presented. So then supplier is coming into the picture, supplier is going to be executed and you will see this value. Okay, so let me receive it and let's print one more time, same result, sys out of result. Okay, so let me execute now, run as Java application. See here, this is or else get value. So that means value is not presented. Now let's make some value again here. I'll write down again my value, not here. So let's make a value here. So it's all about Dilip Singh. Okay, it's all about Dilip Singh. Okay, now value is presented. So when value is not presented, there is no use of supplier functionality. I mean, this supplier will not coming into the picture. The existing value will be returned in this case also. Now see, the last line will be printed as Dilip Singh also. Dilip Singh only here also. So that means see here, in three methods point of view, Dilip Singh. Okay, second method, Dilip Singh. Third method also, Dilip Singh. When value is presented, it's not doing anything. Okay. Now similarly, let's go back to the another method. Okay, somewhat related to the or else functionality. So what is this or else throw method? So what is the meaning of or else throw? If value is presented, it will return the value. If in case value is not presented, it is going to throw no such element exception, no such element exception. So that means at what times we are going to use this method is somehow forcefully you have to throw an exception, or okay, you have to make sure when value is not presented, you have to make sure some exception should be produced. Then you are going to use this method instead of getting default content or default values when value is not presented. So if you would like to throw some exception, see, or based on the requirement point of view, then you can go with this method. So now see here what we are going to do. The next method is or else or else throw method. So just it is going to throw the exception. Okay, so yeah. So here what I will do, name container dot what or else throw. So see here, it's not taking any method parameter. Simply it is going to throw an exception when value is not presented. If value is there, then you are going to get that value. So for example, if value is there, result equal to same thing. So sys out of, and let me print result value now. Okay, result, let me print. Okay, so now value is presented so that you will see Dilip Singh. You are not going to see any exception. Okay, fine. So you got Dilip Singh now at the fourth line. Now let me write an null. That means, I mean, I defined null here, nothing but it returning what? Optional of empty. So that means value is not presented. So then it is going to throw some exception now. Now it is going to throw an exception. So this is what the exception you are going to get in this case. Okay, so see here, let me execute now. So what you got at lines at this specific method execution point of view, no such element exception, no value presented, no value presented. Okay, so at that scenarios you have to use this method. See, you have to use all these methods depends on the requirement point of view, what your requirement is demanding. Based on that you have to take. Okay, it's not like fixed places, fixed methods we are going to use always. No, depends on the requirement point of view. So whatever requirement is demanding, is it demanding always a new optional object? Go with the R method. Your requirement is demanding directly a value when value is not presented, then go with the R else method. Okay, when your requirement is demanding directly a value, but the value has to be generated based on some functionality always dynamically, then or else get method you can go. So if value is not presented, instead of defining a default content or default values or whatever it is, if you would like to throw an exception, okay, to the caller or whatever it is, then you can go for the or else throw method, or else throw method. Okay, now similarly let's go back to the another method also for the from the same section point of view. What it is? Or else throw method, or else throw method. So in this case also what it is involving? Supplier. So that means here also you are going to get an exception. Okay, here also when value is not there, you are going to throw an exception. But what exception? It's up to your choice. Okay, here always you are getting an exception when value is not there. That exception is always no such element exception. But in this case, you have to throw an exception when value is not presented, and that exception might be anything. It might be no such element exception, it might be a simple runtime exception, that means, or it might be a user defined exception, custom exception, whatever it is, you can throw any exception. That is what the meaning of it is, this method is. Now let's see here, same method execution one more time. So what it is, so or else throw, but method parameter is different with the supplier. Okay, so see here, name container dot or else. So I'm taking this time the second method or else throw method. So what you have to provide, you have to provide an implementation for the supplier functional interface. So supplier will never ever have a method parameter. So that's why you got this. So return new exception. So it is going to, we are going to surround with the try catch clause. So see here now. So in this case, what's happening now this time? If value is presented, it will return the value. In case value is not presented, then it is going to throw a custom exception, whatever you defined here. Okay, this is exception or whatever it is. So this time what exception? It's a simple runtime exception, whatever you want. Okay, even you can write down your own exception, you can return that from here. But in previous case, or else throw is always about fixed exception called as no such element exception. But here anything else. Okay, so no value, something I will write. Now see here null value. Let me execute what it is throwing, what kind of exception it is throwing. Okay, so for time being, I'm simply stopping this line so that otherwise it will be terminated here itself. It will not reach to the new functionality what we written. So I'll just stop for this, run as Java application. See here now what you got, java.lang.exception, and the message is this is exception no value. So that means when you want to define your custom exception, when value is not presented, then you have to go with the or else throw method, or else throw method. Okay, so this is how you have to use the or else methods or method functionalities as part of the optional class, depends on the requirement point of view. Okay, so now we are done with the or else all these methods, right? So when value is presented, what to do, not presented, what is the values you have to get and all. Now if you are moving to the other method, we have one called as filter method. The filter method is taking input method parameter as a predicate. So what is a predicate here? Predicate is a functional interface. It is going to discuss all about the conditional evaluation logic. So that means it is always going to take a input value and provide you always a boolean result. At the end it will provide you boolean result. So I explained about the predicate in previous session, please go through it. And now here also, what is the meaning of filter method with predicate functionality? Here it is. For example, assume you got an optional object and you have to extract value from the optional object based on a condition. That means once the condition is satisfied, then only you have to get the value. Otherwise you don't want, otherwise we don't want that value. So in such case, what you have to do, generally what we can do optional dot get, then you will get the value, and equal to not equal to, something like that you have to write down the manual logic. But in this case, that is what simplified by the filter method with predicate functionality. So if you see here, if a value is present and the value matches the given predicate, so that means the condition is matching, the value is matching based on the predicate implementation, then returns optional value. That means the actual value what is available inside the optional element, inside the optional object, then only it will return. Otherwise it will return empty optional object. Okay, and we will see now how to handle with the filter method. Okay, so let's do one thing. I'm creating a new class again, optional filter method. Let me delete all this. Okay, if you see here, generally I'm using same logic again to get the optional object. Okay, so here I will write down optional of string. Okay, you are going to get a name, so I just writing as name container equal to get name. Fine. Now, so see here I am applying first of all filter method on this container. Filter dot. Okay, if you see here filter. And what is the implementation you have to provide? Predicate implementation. So how to provide predicate implementation? Let's see here now. So generally predicate will take a value as internally as an input. Okay, let's do one thing. So here you have to provide what? Predicate implementation as part of the filter method parameter. Predicate. Predicate is nothing but a condition. Okay, so you will get a value, and on top of that value you have to apply some functionality. For example, in this case I return string, right? So that's why I'm just making equals ignore case. if it is reaching, I mean matching to the Dilip Singh, then only give me the value. Otherwise, don't give me the value. Like that, I return a predicate functionality implementation here. So see here now, dot, you can see again filter method is returning back which what? An optional object. So that means when value is really presented, that means in this case, what is going to happen here it is. So if it is, yeah, so in this case, what is going to happen? If it is optional element and inside that the value is Dilip Singh, if the value is Dilip Singh, okay, and you are making is it equal to Dilip Singh or not with the condition of filter, and if it is okay, then then only then you can get the value. In case if it is not matching, in case if it is not matching, then I don't want to get a value, or I can return a default value or something like that. I can extend my functionality. So that means filter is just verifying the content of your optional object. So here filter method is we implemented value. What is this value? The value what available really inside the optional object. And that value now you are comparing with a your based on your custom value or custom logic implementation point of view. But finally what it will return? A boolean value you have to return as part of the predicate implementation. So now finally condition became true or the logic implement result given as a true, then it is going to give you the same optional object again. In case if the condition is failing, then what you have to do, what is going to happen? So it will not return. So see here, what I will do, optional of string verified container. Verified container. Okay, fine. So when it is matching, then you will get that back. Okay, now in case if it is not matching, what is going to happen? So see here, let me get the value of verified container now. Verified container dot get method. So then what? It will print the Dilip Singh. When this optional is really contains Dilip Singh. Let me print the value now. If you see here what happened, no such element exception. Why? Because you received an optional, but which optional? Empty optional you got. So that means inside optional, you don't have any data. We don't have any data inside the optional. So that's why what it is saying, no such element exception. In this case, there is no data, but you are checking with the Dilip Singh. So that's why it is saying like no such element exception. In this case, what? No such element exception you are getting. But in case the value is presented, in case the value is presented now, again, if I given return Dilip Singh as part of the optional element. So see what I'm going to do now here. I'm giving Dilip Singh. Okay, now in this case, what is going to happen? The Dilip Singh inside optional, what is the value? Dilip Singh is available. But you're as part of the predicate, as part of filter method, you are verifying is it matching to the Dilip Singh or not? Yes, it is matching. So that's why it will give you the same optional object again. So that means same optional object. You're in this case, we return it as a verified container. We are receiving as a verified container. You are receiving it as a verified container pointing to the same option. So that means now see again, you are going to get a value called as Dilip Singh here. Fine, right? So you understood the filter. Condition evaluation is completed. If it is true, then only you will get the same optional, or else it will return a such no such element exception also. For example, if I'm changing my name as Dilip in the optional level. So now inside optional, what is the value you have? Only Dilip value you have. But you are checking with what? Dilip Singh. You are checking with the Dilip Singh. Then what? Condition is not matching. Then what is going to happen? See here. Again, no such element exception. Okay. But for example, I don't want to get an exception. I don't want to get an exception in case if it is not matching. But I want to get a default value or some other value. Then what we can do? So like whatever the previous methods we discussed, or method, or else method, all these things, we can apply those methods, continuation or composition to these functionality. So that means because filter method is returning what finally an optional object. So that means we can use the methods what we discussed in the previous class. For example, see here, our method is going to return optional. So that means in case the condition is not matching, I'm going to use again R, and I'm going to produce one more optional object here. So that means what I'm going to do here, it is in case value condition is not matching, then R, I'm returning a default optional object with a supplier functionality. So see here, optional dot of, so some value I would like to keep Dilip at the end. So what is going to happen here, it is I'm writing Dilip Singh here. So now guess what is going to happen in this scenario, what is going to happen? Okay, sorry. Now guess what is going to happen in this scenario? If condition is matching Dilip Singh with actual value Dilip, okay, then you are going to get the filter instance of optional. In case it is not matching, false, then it will reach us to the R, and then you are going to get one more optional object with Dilip Singh, and that is what referred by the verified container. Now tell me in this case what is going to happen. You are going, okay, Dilip Singh of, I can write down a simple differentiation of our method. So now tell me what is going to happen. Dilip is the actual object available inside the optional, but you are verifying with the Dilip Singh. So then no such element. Then immediately, but what we did, we written one more concatenation method called as R method, and I'm saying like, in case if it is not existed, return this value. Then it will not throw any exception, like no such element exception in this case. But what you are going to get here, it is now you are going to get a value something like this is the value it is going to get now. So you are going to get output of this value now. So you are going to get this value as a output instead of exception. So see here now, Dilip Singh of R method. Now for example, if I given again Dilip Singh, so then your Dilip Singh internally the value contains what? Dilip Singh. Now Dilip Singh is equal to Dilip Singh. So that means it will return the same optional as part of the verified container. And then you are going to get output as a Dilip Singh. Okay, so that means what is the point I would like to say here, it is you can, based on the conditional result, you can define a default messages, a default optional objects. Okay, in case if it is true, same object, we can understand something like that. The value is true, that means condition evaluation getting true, then same optional object. If it is match, I mean condition, yeah, if the condition is false, then you can define the okay, the composite methods of or else all these things based on our requirement point of view. You got the solution. You got, so we understood. So we got the, so we got the func. So this is how we can use the filter method. Okay, in anywhere else, whenever you want to verify a condition, what is the value available inside the optional level? Based on that, if you want to take a decision, you can use the filter methods also. Okay, so now let's move to the other methods what we are pending from the optional class. So if you see here, we have two other methods called as map and flatMap. So what is the map? What is the difference between map and flatMap? We will try to understand. First we will discuss map, and then we'll move back to the flatMap, and we will try to understand the difference between map versus flatMap also. Okay, so these are all methods you will encounter in upcoming stream API concept also. The filter, map, flat map, all these methods are, I can say, like the entire optional class functionalities you are going to encounter in the stream API discussion also. So that's why please make sure understanding very well of every method, so that it will it will become very simple to understand the stream API also. Okay, so let's move to the map method. What map and okay flat map is doing, let's try to understand now.
So now let's start first with the map method. Okay. So as part of map method, if you observe here, it is taking method parameter always a function implementation. So we know function is a functional interface given by the Java language. And as part of the functional interface of function, we know that whenever we are passing a value, it will be transformed to some other value and it will return any other data type value based on the logic implementation, whatever it is. So simply as part of functional interface of function, it takes a value, it will apply some logic on that value, and it may return any kind of other value. Input might be different data type, output might be different data type. Please refer function interface one more time. So in previous session I explained that is also. Okay, so now that means when we are discussing about map, so what map was doing here, and map is returning what? Again, optional object only. So that means internally what is happening as part of map method here it is. If you just go through here, if value is presented, returns an optional describing the result of applying the given mapping function to the value. So what is the meaning of applying the given mapping function to the value here it is? So that's what I told you. As part of functional interface, what is going to happen in general is, generally whenever you are passing a value as part of functional interface, yeah, if you are taking a value, you will apply some functionality on this. We will apply some functionality, and then what we are going to do is we are going to get a result value. So it might be any other data type. So we are going to get a result value. So that means it might be any data type, not only belongs to the source data type, the target, I mean the resulted data type might be anything also. So taking one value, applying some functionality, and then getting a one more value. So this is what the functional interface is going to do generally. What? Function interface. Okay, now that means as part of map method, so what is going to happen here it is, for example, assume I have an optional object and inside that I have a value called as the ellipse. Okay, now if you are calling map method, what is this? Optional object, okay, of string data type. So internally you have a string value, right? So that means I told you already, optional can contain any other data type value. It might be other collection objects or any other user defined class object or any predefined object. So we can take anything. Now what map method is going to do, so once you applied map method on the functional interface, okay, map method on the functional interface, so internally based on the above method parameter of function implementation, based on the above implementation, what it is going to do, it is going to pick up the value, it is going to pick up the value, and on top of that value, if you return any, if you return any logic, okay, so if you return any logic, that will be processed, and finally you will get a again what, one more optional object with a resulted value. What? With the resulted values. So again you are getting what? Optional object. But this time what is the value of optional object? So here the value whatever you have, so once whatever the logic you applied based on the map functionality, for example in this case, assume I applied, okay, this is string value, it is extracting internally string value because string data type, okay, that is also fine. And as well as what functionality I am applying here, it is assume I am applying some uppercase functionality, then internally what is the value you are going to see here, it is the ellipse. So that means you taken source as optional object with a simple string value, and finally after applying map functionality I am going to implement this logic. We are going to provide as a lambda expression this entire logic. That's why, okay, you are going to get apply this entire logic in the lambda expression of function interface implementation. Then finally you got an optional object as a result with the applied functionality as captain. Now if you are extracted value from the optional object, now if you are extracted value from the optional object, what is the value you are going to get here, it is you are going to get finally the ellipse in a capital case. Okay, so you are going to get finally as a ellipse. That is how the map method is expecting, or map method is doing here. Okay, you got. So that means simple on high level, take value of optional object, apply some functionality, whatever the implementation we provided, what based on the requirement point of view, and then, okay, and then get the optional object with the modified value, or the keep that resulted value inside again another another optional object, and finally you are going to get the optional object, right? So this is what map method will do here. Okay, that is fine. So that is what they are saying here now. So if value is present, takes the results, apply the given functionality, and then it is going to, sorry, apply the given functionality, otherwise returns empty optional. So that means in case the value is not presented in the optional level, so you are going to get what? Empty optional object. For example, if you don't have any value, then you are going to get again optional empty object. That is what they are saying. So if you don't have value, then you are going to get result also a empty optional only. Okay, if you don't have a value, but if you have value, it will apply the functionality. Okay, fine. Now before going into the programming of map method, let's discuss about the flat map also. It is somewhat related to the map functionality. What exactly the difference between flat map and map, we will try to understand now. Now for example, if you see here, a value is present, returns the result set of applying functionality. Okay, and optional bearing mapping function to the value. So that means it is saying the functionality of what map method is done, that was same thing being done as part of the flat map method also. Okay, otherwise in case if it is empty or whatever it is, you are going to get the empty optional, right? Then what is the real difference between the map versus flat map? So, and if you observe here, this method is similar to map, yes, taking function parameter, okay, but the mapping function is one whose result is already an optional. So that means, and if you invoke flat map, doesn't wrap it within additional optional. So that means what is the point here? It is, okay, let me give you the use case of it is how flat map is going to work, why they given the name as a flat map. For example, assume in the scenario I have an optional object. Okay, fine. What is this? Optional object. Okay, good. And inside this optional object, assume I have one more optional object. So that means inside optional I can keep any kind of a data, right? So I can keep any kind of data. One more optional object. Okay, so one more optional object. Now in this I have value. Okay, now inside this I have the value called as the ellipse. So it is what? String value. Now in this case, finally I have to extract the delipsing in the uppercase point of view. That is what my requirement. Then what is going to happen here in this case? Tell me. So now what is going to happen if I want to get the value with uppercase value in this case? Can I use map method? So if you are using map method, then what's going to happen? For example, if you are using the map method, you have to do extra logic implementation. So that means if you are using the map, what it will do internally, you will get an optional object, or you just need to first you will extract this optional object. Okay, so you will extract this optional object, and again on top of that, again you have to apply internal mapping, something like that. You are going to get the value of this. Okay, so we are going to get the value of this. You are going to get the value of this. So and then finally you are making the two uppercase, and you are getting the the value, the resulted expected result you are going to get in this case, right? But at the same time, why we have to do all these many of operations? So here as part of the flat map, they are flattening the objects. So what is the flattening the object? Here it is flat. So directly as a nested optional object. So if you observe here, it is all nested objects. So it is all nested optional object. So in this case, what is going to happen? The directly the value will be picked out. Okay, and finally the functionality will be applied. The functionality will be applied, whatever the functionality you want to try, and it is going to get the uppercase. So that means in a simple format, what we can understand here, it is the nested optional objects until reaching to the value, it is just flattening the all optional nested optional objects. So that means until reaching to the actual value, it is just flattening, and finally on top of that value the functionality is applied, and finally you are going to get the result. That is what they are trying to do as part of the flat map. So that is what the meaning of flattening here it is. So they are flattening the nested optional objects. Tomorrow, if you have one more optional object inside this optional also, internally it will flatten. Okay, optional, go to the nested one, go to the nested one, and finally at the end, whatever wherever value is available, so that value will be picked up and the functionality will be applied, and then finally you are going to get an optional object again, whatever the value you are just trying to, whatever the functionality you applied, right? With that, you are going to get an optional object again. So you are going to get an optional object, in this case again as a ellipse. So that means at what time you can use the flatMap node guess. So it's all about, yeah. So we are going to use flatMap always in a scenario like when you are having nested objects. Yeah, that is the main difference between the map versus flatMap especially. Now let's start taking examples about the both methods. How we are going to deal with a simple map method, how we are going to deal with the nested optional objects by using the flatMap method. We will try to understand.
Okay, so let me define a new class for these two methods, optional map versus flat map. Inside this, what I'm going to do here it is, like say first I will take an optional, okay, object of string value, optional string, okay, so followed by name container equal to optional of value. So we can directly, and this time I'm just directly defining the value inside the optional. So what it is, delete set. Okay, fine. So that means inside optional object you are keeping string value of the ellipse. Fine. Now I want to get uppercase of value. Okay, with map functionality. With map functionality. So what we are going to do now here it is. So see here, name container dot. What method we are using this time? Map. And as part of map, what you have to implement this time? You have to implement a functional interface of function. So that means generally what functional interface will do, it will take the value. So which value it is? This one. So what you kept inside the optional object level. So that means this is the value. Okay. So you are extracting that value, and on top of that, you have to implement the functionality. Okay. What I'm going to do here it is, I'm just implementing the functional interface implementation value dot to upper string. So that means, sorry, uppercase. And then what's happening? The result value, you are applying the functionality of converting to the uppercase. So then it will be converted everything in the uppercase. Okay. And that value again keeping as part of the another optional object. So the converted result value, you are just keeping again optional object. So that means now map method is returning what? Another optional object with the string value. So if you want to get the resulted value, then you can use the get method. So that means get method is for extracting value of from the optional object. Then get method will give you finally string value. So now this is the value you are getting. It's all string data type value. Now in this case, what it is? String data type value. It's a string data type value. Right? So fine. So now, yes, I will do one thing. String result. Okay, fine. So I'm just printing the value. Okay, so let me execute now. See here. Okay, the value is finally converted as the ellipsing. Who converted this time? The map method. The okay, as part of that, whatever the implementation we provided as a functional interface implementation, that logic. So that means in future, whatever the data type value you are going to get as part of the optional object, you will take that value. Okay, whether it is a object or primitive, wrapper value or string value, whatever it is, and whatever the functionality you would like to implement, yes, you can implement that functionality, and whatever the result value is going to come as part of this implementation of lambda expression, that value will be again moved to the a new optional object, and then from there you are getting the actual value which is available in the optional object. Okay, so this is what we discussed in the explanation point of view. So now the ellipsing map is going to take the string value. Map is going to take string value because it's a string object. Internally, what we have a string object, and then taking string, converting uppercase. Finally, converted to uppercase and kept again inside the optional object, and finally what the string value with applied logic. Okay, fine. Now it's all very straightforward. Just take the value of from the optional object, option from the optional container, apply some logic, and whatever the result it is, you are going to get based on the logic implementation that you map method is going to keep again inside another optional object. And from that, if you want to get the actual value, you can use the get method, or simply you can keep, you will receive a optional element as a result one more time. Okay, fine. So until this, it will return optional object with applied functionality. Okay. Now let's move back to the flatMap functionality, how it is going to work. For example, in this case, I'll give you one more functional intro, one more optional object here. For example, see here, nested optional objects. Okay. So that means what I'm going to do here, it is optional. Okay, of optional again. So internally, it is going to contain string value, name container 2 equal to. So I'll just try to make, okay, to see here, optional of finally string value of string. That means delete string whatever I'm writing. So this is how I just created one more optional object, like nested optional object. So the optional object contains one more nested optional object, and internally finally the nested nested optional object contains string value. Now finally I have to extract this value as a uppercase value in this format. Okay, as a result I want to get uppercase value of this one. So how we are going to traverse from one object to another optional object with respect to nested functionality by using map method? Let's see, understand first. For example, so if you are using map method, what is going to happen? So see here, name container true dot, I'm using name container. So if I'm using the map method, so I already explained you as part of map method what is going to happen. Yeah, it is going to extract first the nested optional object. So that means what? This entire nested optional object will be extracted first. Okay, so what you got here? Optional object. And from that optional object, what it is going to do? Then it is finally reaching to the last optional object in the nested format. Then it is going to get the value from that. So inside this, what is the value? Dilip Singh. Now finally Dilip Singh will be converted to uppercase. So finally Dilip Singh is converted to the uppercase. And whatever the result got to the uppercase point of view, then it is going to keep again inside one more optional object. Inside one more optional object, right? So what it is going to do? One more optional object. Then finally you are calling the get method. Okay, externally we are calling as a developer get method. Then finally you are seeing the result as Dilip Singh. What it is? The result as in the uppercase format Dilip Singh. Okay, finally you are calling get method and you are seeing the result as Dilip Singh. Okay, so now let's start programming point. So what I'm doing, I'm just taking a map method here so that the previous functionality. So as part of map, first we will get this object. Okay, if you taken the value, so this value will return what? This object. Okay, value dot get. So then what you are getting again? You are getting the optional of string. Nested optional object. Okay, so then from this nested optional object, so you just make sure, I think you can do this activity. So what I'm doing, result nested optional object of container and then map and uppercase. Now convert it again. This out it off. I mean, now I'm just printing the result. So what we did here overall, so we, okay, if you see here now the output, you got output of Dilip Singh. So what happened in this case, what we are doing especially just try to understand. So we have nested. So first map is doing extracted the nested optional. And again on top of that, one more time you are doing the map and you are doing the get end, right? But if you are using the flat map, in this scenario, you no need to write down of this extracting nested optional objects and finally extracting the actual original content. And finally extracting the content of the optional object and finally performing the operation, whatever you are just trying to do here, right? So instead of writing this extracting nested optional objects and finally making the mapping functionality, so what flatMap is doing here it is, so flatMap is going to flatten the optional objects. What is the meaning of flattening the optional object? Here it is. So that means internally what these guys are doing, it is going to directly pick up the value. Directly it is going to pick up the value of the lip sync, and then the actual mapping functionality, whatever we implemented, that is going to implement it on this actual value level directly instead of traversing through the nested optional objects. So that means directly picking the value of nested, it is just traversing and getting the value and just apply the functionality, whatever we are trying to make the functionality, and finally you will get a result. So see here how the flat map is going to work. Now, same container object I am taking with respect to flat map, how we are going to implement the above functionality. So see here, flat map, what functionality you have to do? You are doing same functionality. Upper converting finally the lip sync to the uppercase. Now in this case, so see here, okay, so what you are doing, extract the value. So what value? String value. Okay, then finally you will get a value and then to uppercase. To uppercase. So in this case, what we did, it's just internally with respect to this, you are just flattening the optional objects. This operation is doing flattening all the optional objects, and from there finally you are getting the value. Which value you are getting here? The lip sync. So here it is just flattening all the objects in this area, and finally you got the value, and then you are converted to this, and then you are going to convert it to this. Now what is the result of this? String value, right? So result equal to same sort of result. So see here result. Now let me execute this example one more time. So if you see here, you got again the lip sync on it. So that means very less amount of code we return. We don't need to extract nested optionals and everything. Simply what it is doing, whenever you are having nested optionals, it is going to flatten with this operation. Okay. And then finally going to pick up the value of the actual content, and then it is going to apply the functionality. Okay, so this is all about the flatMap method. Especially flatMap is usable when we are having nested optional objects. Okay, so that's all about the optional class and the methods available inside the optional class with respect to static and default methods. Okay. Yeah. Now in the next session, I'm going to discuss about the stream API. So the stream API is more popular concept nowadays, we know that, and as part of stream API, definitely we should know the previous concepts like functional interfaces as well as predefined functional interfaces as well as optional class, all this information. Okay, yeah, so I will upload all these examples on the GitHub account. Okay, so you can, if you want, you can get code from there also. So right now I'm going to discuss about the most important topic about stream API inside Java language. So we know that as part of Java 8 features, one of the most important feature is stream API, and we discussed already a couple of other features like functional interfaces, Lambda expressions, as well as predefined functional interfaces, Predicate, supplier, and etc. And we discussed about optional class in our previous sessions. Continuation to that, right now I'm discussing about stream API also. Yeah, Stream API is the one of the most important topic with respect to interviews as well as with respect to day-to-day real-time application programming. Okay, so yes, in my projects also right now we are using Stream API extensively wherever we are having some kind of data operations. We are performing operations on the collection of values. So that means in general, at one point of time, what will happen whenever we have collection objects, for example, if you take a list, so if you want to perform any operations on the list object, like if I want to filter some information or if I want to convert from one value to another value from the list of objects, okay, so we have to go with some regular programming, like we are iterating via for loops and we are taking a manual if conditions, if you want to filter, or if you want to write a manual mapping from one value to another value conversion, right? But now those are all functionalities being replaced by the Stream API features. It means we are using Stream API to operate with the collection objects most of the cases. Okay. Okay. Now let's understand more about the technical details about the Stream API. Okay. Yeah. Here we can find the agenda of this session. So what I'm going to cover here. So I will explain what exactly the Stream API and the importance of Stream API, and I will show you the number of ways how can we create the stream instances, as well as we will discuss the most important one called as difference between intermediate and terminal operations in the Stream API, and I will explain about the most important called as stream pipeline, as well as we will discuss couple of use cases also. And the one more important class we have called as collectors, and this class being used extensively along with the Stream API. So what is the meaning of collectors and what are the functionalities available as part of the collectors class also we will discuss as part of this session. And in between this session, I will try to cover a couple of interview oriented examples. Okay, and those are all related to collectors and including the Stream API functionalities. Now the first question here it is, what is stream? So generally here stream is a wrapper on data source. That means what is the meaning of data source? Here it is, for example, if you taken a list of objects, so list of objects is a data source. By using that list of objects, you are creating a stream, okay, that I am calling it as a wrapper on data source. So that means from the list of objects you are creating a stream and you are processing the data via stream, and finally you are making the operations of fetching or getting the results based on your functionalities, okay, with the help of stream objects. So that means in this case what is happening, the data operations are processing on stream object but not on the actual collection object, or but not on the actual source, I can say here. The importance of stream here it is, stream is providing a way to process the collection of objects, okay, in a functional style, allowing developers can perform bulk of operations in sequence of elements. That means we can perform many operations at a time by using Stream API, like filtering the values. Along with filter, we can map the values, we can collect the results. Like that, we can do many operations at a time without disturbing the source object. So that's why stream is a wrapper on the data source. So stream is an interface, okay, provided as part of the java.util.stream package. Yeah, now we have to understand how a stream will be operated. Okay, a stream is not a data structure, yeah, but it will take data structure as an input to perform operations. Okay, that means stream will never disturb the actual data source object. Stream will not disturb the actual data source object. So that means when we are doing operations on the stream, those are all not going to be impact the data source. So now let's start discussion about the technical details of the Stream API. Okay, first we will discuss how can we initialize the stream object. So we have different ways to create the stream instance or the implemented stream instance from the collection of objects, or maybe array of values, or from the individual values. How we are creating the stream instance, we will try to see now. So first let me create a class now. So I created a class stream initialization. See how can we create the stream in different ways. First, for example, first approach is I am creating from a collection object. From collection object, that means I will take a list here, the list object. So I will take some values as part of the list. So like that, I'm just having a list of object. Here it is. Okay, so now from this collection object I'm creating this stream object. So how to create the stream object? Here it is. So first you have to take the list object dot, there is a method called as stream method. So by calling stream method on the collection object like either list or set, we can create this stream instance with respect to this list object. So now if I'm calling this stream, the return type of this method is stream object. Okay, so that means yes. Now finally we are created a stream object. So even here also we can define the generic types. So what is the generic type we have to define? String here, because the actual original list object is allowing string generic. So that's why we given string here also. So this is how we are going to create a stream object from the collection object, So this stream object is created as a wrapper on top of this list object. So now by using this stream instance, we can perform the remaining operations. We will see now in couple of minutes. So this is one way. Even sometimes we can create collection from the arrays of objects also. That means if in case if you have arrays of values, so here let's do what I'm doing here. It is I'm taking string array, something like names equal to, I'm taking couple of string values, and from the arrays we have a method called as arrays dot stream method, and I'm passing the values. Okay, so here names, string names, I'm just passing. So what is the return type of this method now? So it is again a stream of string object. So that means we have to define the generic type always with the stream instance of the original values what contains the data source, the data type of values for original source. We have to configure the generic type here. So this is one more approach, and probably we can create by using couple of static methods from the string also. We can see here, for example, here directly from the method from the stream static method called as stream.off. So here I can pass any type of references. So for time being I'm just dealing everything with this string data type, but we can pass here any data type values. That means we can operate or we can initialize the stream objects with any data type values. Okay, so it's not only string, we can define with any other data types also. So I will take a user defined class and I will discuss the remaining all examples with the user defined class with respect to stream initialization and stream operations. Okay, so how I'm creating, see here, for example, again I'm giving string values here. So that means now one more stream object is created. So the data type is string generic type. So I can create this way also. We can create the stream object from the individual values. From the list object, from the array object, from the individual values, I created the stream object. So now similarly, I can use one more method provided by the stream called as, there is a method generate method. So how it is going to work, we will see now. Generate is the method. So if you see here, this is also a predefined method from the stream interface called as generate. So here you need to provide the supplier interface implementation, the supplier functional interface implementation. In our previous sessions, we discussed about the supplier functional interface. Supplier interface is not going to take any input values, but it is going to return a value always. Okay, so for that, what I'm just doing here as a lambda expression notation, I'm returning some value from here. So generally supplier is all about producing different values at different times of execution. So I'm just hard coded with the one now. It is going to generate a stream object with this value. So here even we can have one more method called as limit method, so that it is going to create the size, the number of values what you given. Okay, so now I created one more way stream object. So what is the supplier return value is string value, right? So that's why here the generic type is I'm taking as string. So stream 4. So the fourth way I have created. Okay. Similarly, we do have other methods from the stream API. That method is all completely depends on the builder design pattern. That means stream provided a builder implementation, builder design pattern implementation. So from that also we can create the stream objects. So it's all about builder method. Okay, so how I'm going to create here. So this is also again from the stream dot builder. So it is going to give you just stream builder object, but not actual the stream object. Okay, so if you see here, it's just returning the builder object. So how I'm going to do here, it is stream dot builder, okay, of the data type what you are trying to store the values, so that you have to pass here it is. So this is not a stream object, this is just like a stream builder. So this is following a design pattern called as builder design pattern. So from this builder, I'm creating now a stream object by passing some real values. Stream dot, okay, so see here, I'm just adding the values like in string value dot add. Again, you can add one more value like that. You can add any number of values, and then finally you are making a call called as build method. Okay, so that means finally this build method is going to create a stream instance with all these values, and it is going to return the stream instance. Now see here, stream of string data type. So we created one more way, stream object. So this is how we can create any number of ways stream object, and even we can create a empty stream also with the method called as empty method. So if you see here, stream dot empty, so what it is going to return, returns an empty sequential stream. Okay, so it's going to return always a empty string. Okay, so this is how we can create the stream object from the source of values, or from the source of collection object or array of objects, or from individual values, or by calling the generate method by passing supplier implementation, and as well as we can define a stream instance with the builder design pattern by calling the builder method, and as well as we can create a empty stream for any other data types. So here I just taken as an example, I taken as a string, but we can define any data type values as part of the stream instance. So stream is going to operate on every data type of values. Okay, so this is all about simply how to create or how to initialize the stream instance from the different types, different ways. Okay, now let's see about the stream operations. Okay, how stream operations are categorized and what type of stream operations we have. So we will see in detail right now. So in stream API, the methods what we are executing along with stream instance, we are calling it as stream operations. Stream API categorized the methods into two operations or two types. The first one is called as intermediate operations, and the second one is terminal operations. So there are two types of methods we have inside the stream API, and one is categorized as intermediate operations, second one is called as terminal operations. So this is very important, like we have to know the difference between intermediate versus terminal operations, and we will see very detailed with respect to examples also. So here again we have one more concept called as stream pipeline. So that means there is a concept again called as stream pipeline. So by involving these two operations or these two types of methods along with the stream instance, we are going to build a stream pipeline. So we will see details about the stream pipeline also. First of all, let's discuss about what is intermediate operations, what is terminal operations inside the stream instance. Okay, so generally when it comes to the intermediate operations, when we call a method belongs to intermediate operations, it will always returns another stream object of the operation results. Okay, so that means when you are calling an intermediate operation method on instance, Once that operation is completed on the stream, so it will return again one more stream object with that affected functionality. Okay, so that means whenever we are calling intermediate operations on the stream, you will always get a return again a stream with the applied functionality. So, and at the same time, we can call many intermediate operations on same stream instance as a chain of methods. So this is called as pipeline on same source, same stream source. Okay, pipeline on the same intermediate operations, pipeline on the same stream source instance. Okay, and one more point here it is intermediate operations are executed only once when we invoke terminal operation. So that means on pipeline intermediate operations on the same stream object. So when those are all going to be executed, once you are initiating or invoking a terminal operation on the same stream pipeline. Okay, now we have to know about terminal operations. So generally we can call only one terminal method on any stream instance. And when we call terminal method, immediately we will get the result of all pipeline operations on the stream object. So that means what is the overall points we have to understand here it is we can call any number of intermediate operations or intermediate methods on same stream object, but at the same time we can call only one terminal method on the same stream, and immediately we are going to get the result of all those operations once we are invoking the terminal method. And whenever you are calling the terminal method, then only intermediate operations are executed which are pipelined on the same stream object. Yeah, if you see here now, for example, we have a collection of object, that means a source of objects, and we call the stream method and then we got the stream object. Once you are calling the stream method, you will get the stream object. And then you are calling chain of intermediate operations. If you see here, chain of intermediate operation. So when you are calling operation 1, it will return again a stream object. Okay, again on that result stream object, you are calling one more intermediate operation. Again, it is going to return with that functionality, whatever you applied with that result, one more stream object will be returned. So like that, you can call any number of intermediate operations on the source of stream object. Okay, and then whenever you are calling a terminal operation, generally the terminal operation we will define at the end of all operations, intermediate operations. So once you are initiated a terminal operation, nothing but a terminal method as part of stream API, so immediately you are going to get a result of all these operations, whatever the intermediate operations we done, and okay, whatever the terminal operation, based on the terminal operation, whatever the intermediate operations, all the consolidated okay operations result you are going to get as a output. So this overall chain will be called as stream pipeline. So that means what is a stream pipeline? Here it is, when you are making the sequence of operations like intermediate operations on the same stream object, and when we are making one more terminal operation on the same stream, so then we are making the entire sequence as a stream pipeline. We are calling it as a stream pipeline. So here stream pipeline is nothing but the combination of intermediate operations methods on the stream object as well as a terminal operation. So this entire process will be called as, this entire chain will be called as stream pipeline here. So now let's see what are the methods are provided by the stream API, and out of all those stream API methods which are categorized as intermediate and which are categorized as terminal methods, we will have a look here and then we will start making a programmatical point of view, every example for every method. Okay, so if you see here, I just noted down all the methods, and that too these methods are very helpful and useful in day-to-day programming. For example, with my entire experience of my real-time applications development, so I collected all these methods what we are using on daily basis in my day-to-day application implementation. Okay, so if you see here, I just categorized what are the methods we have, what are the methods belongs to which section and all. I just categorized here. So we know that we already used empty method, off method, okay, all these two methods as part of the stream object creation, right? So now if you come here, we have a lot of methods, okay, so don't worry about every method. So we know most of the methods functionality, what it is going to done, and we will see anyway practical examples also. So if you see here, I just categorized a couple of intermediate methods like distinct methods. So that means what distinct method is going to do, what filter method is going to do, what skip is going to do. So that means these are all methods belongs to the intermediate. So whenever an intermediate operation is executed on stream object, it will never ever return a result directly. So intermediate operation will never ever provide, okay, an output or result directly. So to invoke all the intermediate operations, you need always a terminal operation, and that too we can call only one terminal operation. We cannot call more than one terminal operation on the chain of stream activities. On the same stream pipeline, you have to make sure only one terminal operations, but you can make sure many intermediate operations. But these are all operations when it will be invoked. So it is going to be invoked in the, when you are invoking the terminal operation. So once you are invoking the terminal operation, then all the operations will be executed one by one in sequential, and at the end the terminal operation will be executed, and finally you will get the result. So this is all about the execution flow of all stream operations with respect to stream pipeline. This is the most important interview question being asked most of the interviews. Okay, like what is the stream pipeline and what are the rules and regulations the stream pipeline is following, and what are the types of operations we have. So we have to explain all these things. When intermediate operations are going to be executed, nothing but intermediate methods are going to be executed, and when terminal operations are going to be executed as part of a stream pipeline, we will get a couple of questions. Okay, so now let's come back to the methods. What we have here, it is, we have a couple of methods, and I told you already we will see an example for each and every method right now. Okay, and so these are all, until this section we have something like all intermediate methods. So we will see what is the meaning of intermediate and all with respect to practical. And we have a couple of methods. See, these are all predefined methods provided by the stream API. That means as part of the java.util.stream package, we have stream interface, and as part of stream interface we have all these methods. And if you see here, there are a couple of terminal methods also. Okay, what are the terminal methods we have? So we will see an examples about terminal methods of all these methods in a programmatical point of view right now. So we have to remember at least couple of intermediate operations as well as terminal operations with respect to interview point of view also. But it's not like you need to remember each and every method belongs to intermediate and terminal. It's not that much easy also. So this is all about the intermediate and terminal operation introduction. Now let's start the programming, how we are going to create a stream instance from the collection object, and as well as how we are going to create a stream pipeline, and what are the rules and regulations we have to follow when you are creating the stream pipeline with respect to intermediate and terminal operations. So now let's look into the stream methods. So that means how we are performing operations on the stream instance, we are going to see now. So let me introduce one by one methods and we will see one by one example how or where we are using the stream methods, in what kind of requirements we are using it, we'll see now. Okay, so let me create a class. I have created a stream operations class here, and what I will do here it is I will take a list of employee objects and then we will try to see all the examples along with this list of employee objects by converting into stream instance. Okay, so what I'm going to do now, to save some time, I'm just pulling an employee class and I'm preparing a list of employee objects as a array list object, and we will try to understand all the stream methods with respect to this list of objects. So now I created an employee class with all these properties, like we are having ID, name, city, age and gender, as well as we taken department, year of joining into the department and the respective salary for every employee. Like that we collected all the properties as part of the employee class. Okay, so now in the another class I just taken a list of employee objects. I taken around 10 employees data here, what is their age, what is their employee IDs and all. So I just covered as part of this list. And now here we will start understanding about the stream methods, or we can call it as stream operations also. Okay, so how to do that? For example, assume I given a requirement like this: get all employee names as a list. So this is what the requirement I given to you. From this list of employee object, you have to collect only employee names as a list again. So then what we will do in our regular programming, or in our previous before to Java 8, probably we will iterate all the employee objects like this, and here you will write down a list of string, because name is a string value. So employee names equal to new array list, right? And then what we will do, employee names dot add and every employee dot get name. Okay, so this is what you will do, and finally you are going to get the employee names. Okay, let me print it. So all employee names, fine. Okay, let me execute now. So see here, you got all the employee names as per the requirement. But now, instead of doing this kind of imperative programming, like we are writing implementation with respect to creating new list, and again we are iterating one by one, and we are doing the imperative programming here, right? So instead of doing this kind of imperative programming, generally we know the purpose of the Lambda expressions functional interfaces to improve the declarative programming in the Java language. So that means now if I am using the stream methods with respect to same requirement, okay, how I can do, let's see, here it is. So the same solution, but we are implementing via stream now. Okay, so first and foremost thing is, we know that how to create the stream instance. We have to collect, or we have to create always stream instance from the collection of objects, right? So collection type. So here I have list is a collection type, so I can create from here. Okay, so by calling a method called as stream method, as we discussed earlier. So once you are returning, what you are going to get, you are going to get a stream object. For example, I can write down like this: stream. So what type of values you contain inside the stream? Employee type. So you are going to contain employee type values here. Okay, so let me import the package also for the stream, and then employee stream you got here. Okay, you got all what? Employee stream. So on this stream, now we discussed, like we have two types of operation called as intermediate operations as well as terminal operations. So first, generally to perform any functionality, most of the times we will use intermediate operation, and to pick up the results once or to collect that result from that intermediate operations, we will use terminal method. And this overall process we are going to call it as a stream pipeline, right? So for example, in this case, stream provided a method called as map method. So here I'm just taking stream object, okay, and then I'm calling a method called as map method. So what is the argument for the map method? The functional interface. So you know we know about the functional interface. It will take input as a one value and it will return one more value as a nature of the functional interface, as we discussed in the previous sessions. So that's why we have to know function, predicate, supplier and consumer before understanding the stream API. So we already covered that session in the previous. So here that means as per functional implementation, I'm going to take every employee object. Okay, so here this is representing every employee object from the stream of objects. Okay, I'm collecting one by one employee object, and from that what you are trying to get, employee dot get the name. So that means from every employee object you are collecting employee dot name. So what is this operation type? Map is a intermediate operation. So we know that any intermediate operation will not give us the result, the final result. So to execute, to get the functionality executed of intermediate method, we need always a terminal methods, right? So if you see here, map, okay, if you understand the map, it is what? Intermediate operation. So intermediate operation will never ever gives the results, okay, on stream pipeline. So to conclude the stream pipeline, we need always a terminal method. So out of all these terminal methods, we have to collect a terminal method with respect to the requirement point of view. Yeah, for example, if you see here, I'm calling a method called as toList method. So this is a terminal method. So if you see here, this is a terminal operation. So what it is going to do, a list containing the stream elements, and it is being added from the Java 16 onwards. So that means this method, this terminal method, we don't have earlier before the Java 16, or from Java 8 to until Java 16 we don't have this method. So at that time we used to use a concept called as collect as, and collecting as a list, like that we are having a concept, and we used to use that functionality before the Java 16. If it is Java 16 or more greater than the Java 16, then we can use directly toList method, which is a terminal operation. So I will discuss in case if it is less than Java 16, okay, how we are going to collect the values from the intermediate operation called as map, okay, by using collector class. We will see in the upcoming operations. Okay, so now let me call the toList method here. So I'm just calling the toList method now. So see the return type of, if you have observed here, so this overall I'm calling it as now stream pipeline. What it is? Stream pipeline, as we discussed in earlier class. Okay, so here in this case, this is what? Source. This is what? Intermediate operation. This is what? Terminal operation. So this is source. This is intermediate operation. So intermediate, it's not like final one. And it is all about terminal. It's all about terminal operation. And by overall this, we will call it as what? A stream pipeline. We are calling it as a stream pipeline. So we built a stream pipeline, and we are finally, so, and we discussed one more point also, like whenever we are calling terminal method, we are concluding terminal method, and we know that we have to call always only one terminal method, but we can call any number of intermediate methods. We will see those things in upcoming examples. Okay, so now once we are calling the terminal method, then immediately intermediate operations will started executing first. So then it will be executed. So from here, from every employee object, you are collecting the names. So then internally it will collect 1, 2, 3 like that, all employee names, and finally as per the terminal operation, it is going to make everything as a list of values based on the return value from the map. So what is the data type of return value from the map functionality? String data type. So here you are going to get list of values with data type string as a result. Okay, so let's see now here. So what is the return type of this method? If you see here, list of string, list of string here. Why string? Because this return value is data type is string. Here it is. Okay, so let me collect this value now. List of string. Okay, all employee names. See how clear it is, or how simply we return the functionality of getting all employee names when comparing with the declarative programming. Like we are going with the regular for loops and writing like regular, okay, functionalities. We are overriding that those things with the stream API. No. Okay, let me just print all the employee names one more time. So whether we are receiving properly all the employee names or not. So run as Java application. If you see here, even we got same result with respect to stream operation also. Okay, so this is how the stream API is helping us nowadays writing very significant code, okay, as well as writing very comprehensive code instead of going with the regular approach like iterating the for loops and making any conditional statements inside the for loops. When you want to extract data or when you want to collect any op when you want to collect a data based on any conditions, instead of going with this approach, we are going with this stream API approach. Okay, so we will see a lot of other examples also how stream API is helping us with other requirements also. Okay, so this is all. Okay, what we understood now in the overall process here it is, we understood now about the map method. So map is a method, okay, derived as part of the stream API, and this map method is going to take as an argument function interface implementation. That means function is a functional interface. It will take one type of input value, and after processing that input value, or you are doing any mapping or manipulation on with that value, and you have to return always one more value. So that is what the functional interface returns. And again, if you observe here, we already discussed in earlier case also. So an intermediate function or an intermediate operation will always returns again one more stream object, but not actual result. So the same thing is being applied here also, if you observe now. So when we are calling the map method, the return type is completely stream object, but when you are calling the toList method belongs to the terminal operation, you are getting the overall result, terminated result, right? So let's see the other methods also, like what we have going to use on daily basis in our day-to-day application programming. Okay, so you understood now how what is the purpose of really the stream API when comparing with the old approach of coding and with respect to stream API coding. Okay, so let's see here. Now I will take one more method called as filter method as part of the stream API. Okay, so here now what I am doing here it is, I already have a employee stream object, right? I already have a employee stream object. Okay, I am using that employee stream object and I am calling filter method. What it is? Filter method. And as part of the filter method, what is the argument, guys, here? Predicate. So predicate functionality we know, right? We discussed already. Predicate will take a value internally and it will always gives us a boolean return type value, boolean type value as a return type, because predicate is all about conditions. So we are going to apply some conditional statement as part of the predicate implementation, and based on that we are going to get always either true or false results in predicate. So here, for example, my requirement here it is, let's see here, I have to get all the employees whose age is greater than 25. So what I'm going to get, all employee names when whose age is greater than 25 I have to get here. So see here what I'm doing, I taken the same initially created stream object and I'm reusing that stream object and I'm calling the filter method. Now I'm providing implementation of the predicate functional interface. So what stream contains, what values always it contains? It contains internally employee objects. So see, understand how to write down the methods or how to implement the methods as part of the stream API. You have to be understand very clearly. So it's a very simple. Stream object contains what type of content? Employee content. That means employee type objects. So whenever you are taking, so again you are going to get what? An employee object. So predicate will take single input parameter, okay, and it is all about employee object. And from that employee object, what you are trying to do? You are trying to compare age with respect to what? 25. So here this will become the predicate implementation, a conditional statement. It has to represent always true or false value as part of the predicate implementation. Okay, as a lambda expression implementation we taken for the predicate argument of filter method. So yes, and once whose age is greater than 25, what you have to do? You have to collect their names. You have to collect their names. So with this operation, what you are going to do? It's an intermediate operation. If you see here again, filter method is returning again a stream object. That means it's an intermediate operation. It's not a final operation. It's not a terminal operation. And from this, okay, now in this case, what is going to happen here? It is, okay, it is going to filter all the employee objects whose age is greater than 25. So that means as a result, what you will get again? Stream of employee objects only. But you will, the values contains internally stream is all about the employee objects whose age is greater than 25. So from that stream, again what you are going to do? I am going to map, okay, the filtered employee names. I am going to mapping here, okay, employee dot get name. So what I did here, I taken two intermediate methods. The first intermediate method is doing what, guys? It is just filtering whose age is greater than 25 out of 10 employees whose age is greater than 25. And then from those filtered values, I'm picking or I'm getting those employee names. And finally, I'm converting it to the to list with respect to terminal operation. So then finally, you're going to get the list of employee names whose age is greater than 25. So here what it is, it's again an intermediate operation. An intermediate operation. Okay, and similarly, so this is also what? Second one also an intermediate operation, right? So yes, and the third one is terminal operation. The third one is terminal operation. So that means terminating the stream pipeline so that we are getting finally the result here. Okay, so let me collect the values as a return whatever you are getting. So you are getting list of string whose age greater than is 25, right? So employee names, okay, I'm just taking here it as, okay, so I'm just differentiating employee names too. Okay, so let me print it now. Sys out of employee. So I'm just printing now the result of employee names too, and I'm just printing here it is. Okay, so let me execute the program now. So see here, there is a surprise. Okay, what is that surprise? Here it is. Just understand the exception. Okay, and then I'll explain you what is this exception also. Okay, so here if you observe the meaning of this exception, until this it is processed successfully and you can see the names of the employees. Okay, this is printed, this is printed. So that means until this you don't have any problem until line number 28, but you got problem at line number 33. And what is the problem or what is the exception it is saying? Just understand, illegal state exception, stream has already been operated, okay, upon or closed. So what is the point here it is, and you are getting at what line? Line number 33, you are getting illegal state exception, and it is saying like stream has already been operated upon or closed. So simply what it was saying here it is, so we should not use a stream object more than once. So that means I created from the list of object, what we did, we created a stream object, right? We created a stream object like employee stream object. And we used the same stream object for the mapping method to collect the list of names. That means we already built a pipeline for this map operation here, right? Here. The stream object we are already used once to perform some operation, not only map, any operation. So that means we already used a stream object once and we built one pipeline and we executed a couple of operations on the stream object, and we are trying to reuse it on the second time, then you got an exception. So that means now what stream API is saying here, it is a stream object can be used only once. Okay, you can process only once and you cannot process more than once. So only once you have to process, only once you have to process, but you cannot process more than one. More than one, we should not process. So that means the same stream reference, you cannot use second time onwards. You cannot use second time onwards. It is not allowed. It's not allowing. So that's why the exception, you are getting like illegal state exception, and it is saying like stream is already closed. So yes, so that means what is the overall concept here, it is guys, from the once we created stream object, we can perform only one time stream pipeline operations on the stream instance. We should not use same stream object second time. Then what you have to do, if it is not allowing to use the stream object second time to perform any other operations, what you have to do is you have to create one more time, one more stream instance from the actual source object. So you have to create second time, freshly you have to create a stream object. So this will be asked in interviews also. Can I reuse the stream object multiple times to perform different operations? No, we have to use stream object only once to perform operations, and if you want to perform second time any other operations with respect to same stream instance, you will get illegal argument exception. So to avoid that, what you have to do is whenever you are making any new stream operations, every time you have to create a new stream object. Okay, so that means what is the solution here, it is now if you're going here, what is the solution? Let's don't use the same stream object and let's create one more time stream object from the original source. What is the original source? List of employee objects. From this, what I am doing here, it is, so it's a employees dot stream. Okay, and I'm creating stream object. Now what is happened here? You created one more time stream object and you are performing respective operations, and we are performing respective intermediate operations and as well as terminal operations. Now let me execute. So what we did here guys, we created one more time stream object to perform other operations. It's not like we are not using the existing stream instance. Okay, let me execute now. If you see here, you got the names of almost 7 people. Okay, yes, for total 7 names you got. That means their age is greater than 25. Those people names you got. Now assume, okay, I think now you understood very well about the stream operations, how to reuse the stream instance, whether we can reuse it or not, or what are the rules we have to follow when you are performing the stream operations. So here you have to remember a couple of things here, it is. What it is, you cannot reuse stream instance second time. Okay, you cannot reuse stream instance second time. Point number 1. Point number 2, a terminal operation will gives always the result, okay, the result, but intermediate operations will never ever provide you the results. Intermediate operations are going to perform only mapping or any functionality implementation, or we can do any functionality implementation as part of the intermediate methods, but to collect the results out of all the intermediate operations, you have to call always a terminal method. So that means a stream pipeline always required and terminal method, even though there is no intermediate method. Okay, so once terminal method is there, then automatically first this one will be executed. That means here from this, what happened guys, when first intermediate operation is happened, 7 objects is received internally, 7 objects are filtered when first intermediate operation is executed. So then out of those 7 objects, a stream object is created. Okay, as a result, what? With one more stream object is created with this 7 object, and with this map method, what you did, out of these 7 objects, you are picking one by one employee names, and total you got 7 employee names, 7 employees names whose age is greater than 25. So this is what about the stream operations. This is how we are going to build a stream pipeline, and this is what we have to follow with respect to rules and regulations for the reuse of stream instance. So now what I'm going to do, I'm going to introduce one by one other methods what we are using on daily basis in every real-time application on top of stream object. Now I have a requirement. I would like to print all city names of employees. Okay, so I would like to print all the cities belongs to all the employees. Okay, so what I'm going to do, see here it is. So we know that we cannot reuse the stream instance when we are doing newly operations, right? So I have employees object, list object, and from that I'm creating the stream object. So what we are created here, stream object. So by using stream object, what you have to do, first I'm going to map. What I'm going to map, from every employee object I am getting employee dot get city. So that means here I am using an intermediate operation. Okay, for what? For mapping city values from every employee object. Okay, so what you are going to get here, you are going to get a stream object with the values of city names, and from that what we are on, okay, unique values. For that we have a method called as distinct method given by the stream API. So what is the method we are discussing now? Distinct method to retrieve distinct values from the stream of object. Okay, so from this, what is my requirement? I have to print, right? So we have a method called as for each method. Okay, we can use that for each method as part of stream API. That means if you see here, distinct also an intermediate operation. How can I say this is an intermediate operation? So if you see, the return type is what? Again a stream instance. So every intermediate operation will always returns a stream instance, but terminal operation will only perform the real execution. So here what I'm using a method called as for each method. So here we have a consumer implementation, consumer functional interface implementation. So we know that consumer, what it will do, it will take a input value, but it will not return anything. So that means what I'm going to do here, it is I'm going to take a concept of printing all the values, system dot out, and I'm printing every value. So I'm just using method references concept here, so that every value. So in this case, what is happening? A stream object, an intermediate operation. With this you got city values, and then from out of city, or you are collecting only unique city names, and then you are passing one by one city name to the system.out.println with the method of for each. So see here, what is the return type of for each? Void. So that's why, and this is calling it as a terminal operation. So what is this? This is a terminal operation. So we have to call only one terminal operation, but we can call n number of intermediate operations on the stream object. Here first this operation is done, and this next this will be done. So all the aggregated results are going to be concluded, and finally you are printing the values. So see here, so we covered here two methods, guys. One more method called as for each method. So it's a terminal method. So what is the nature of this? So it will process each and every value, okay, based on the consumer implementation. So it will take a input value and it will process the value based on our logic, but it will not return any value when we are using consumer implementation. But for each method is taking argument of consumer implementation. So please refer consumer functional interface, then we can easily understand what's happening as part of this for each method also. Okay, fine. So let me execute now. If you see here, Pune and Hyderabad, two values we received. So let's observe the employees belongs to what are the cities other than Hyderabad and Pune. So if you see here, every employee may belongs to either Pune or Hyderabad, and we don't have any other city names. But in case if you have any other city names, we might have see the result here. So what's happening here? The distinct method is taking distinct values, and for each is processing every value from this result of string. Fine. Now let's move to the another requirement or another method to understand the stream functionalities. Okay. So see here, now my requirement here is get count of employees whose salary is greater than 20,000. So what is the requirement? I would like to get all employees count whose salary is greater than 20,000. Okay. So what I have to do? First, let's create the stream object dot stream. Yes, you created a stream object. Then from that, let's observe what are the methods we have related to the count or what we have to understand first. Let's hear. So what is our requirement, guys? Here it is very clearly the number of employees count we have to get whose salary is greater than 20,000. So how to do that? First thing is this stream object contains which objects? Internally employee objects. So from that, what we can do now? First, let's get the whose salary is greater than 20,000. Like, so what I can do? I can use the filter method like what we discussed in earlier case. So I can apply predicate here. That means a condition. So what it is? From every employee object point of view, whose employee salary is greater than 20,000, whose salary is greater than 20,000 you want. So what filter method will do here? It is filtering all the employees whose salary is greater than 20,000. So what is the result? Again, you are going to get here it is. It's a intermediate operation. You are going to get stream of employee objects whose salary is greater than 20,000. But we want count, right? So what is the method we have? Let's see here. We have a direct method called as count on the stream object. So what it is this? This is also a terminal operation. So this will return directly count value. So that means how many values available inside the stream, that count you are going to get. Okay. So this is how you can use the count method when you want to count the number of values available inside the stream instance. So here it is a terminal operation. This is a intermediate operation, and this overall I can call it as stream pipeline. So let's see whether it is collecting the count or not, whose salary is greater than 20,000. So what I'm doing here, so I'm just taking count of employees with data type long. So let's print it now, count of employees, run it. So you got total 6 employees available whose salary is greater than 20,000. Okay. So yes, now what is the method we are done now? Count method. So it's a terminal method. So we are going to get count of objects or values available inside the stream object. So this is all about the count method, right? Now let's move to the few other requirement, and we will try to see any other important stream API methods available or not. Okay, for example, now my requirement here it is get first 3 employee objects. So that means out of 10 employee objects, I want to get first 3 employee objects as a list. That is what my requirement. So what I can do here, see here it is. First, you have employee object, and what you are going to do? Stream, right? Stream object you created. Yes. Once you created the stream object, what you can do here it is, we have a method called as limit method. So what limit method is going to do? It is going to limit based on the value what you are passing for the argument. So it is going to limit with the set of values initially available in the stream object level in an order. So let me do one thing. So I given here 3. Okay. And then what I'm doing, I'm just making 2 list. So guess now what is going to return 2 list? A list of object. Okay. A list of which objects? Employee type objects. So you are getting first 3 employees. You are getting first 3 employees. Fine. So let me see whether it is true or not. Sys out of first 3 employees information. So here, what is the method we discussed, guys? Limit. So it is just limiting the number of objects available inside the stream object, and it is giving us those limited set of values to the next operation. So out of total 10 employees, it is limiting first 3 employees, and those 3 employees, on top of those 3 employee objects, you are doing the other operations. So here you can do any other intermediate operations, and you can do any terminal operations with these 3 employee objects. So it's up to, based on our requirement, we can do any other functionality, because it's an intermediate operation. It is returning again a stream instance only, so that we can call if we want any other intermediate operations also. So let me execute now whether it is working or not. So see here what you got: the list employee 6, employee 7, that means ID 7, and you got employee 3, 6, 7, 3 employee information you got. So go and verify the list of objects. See what you have: first employee 6, employee 7, and employee 3. So you got these 3 employee objects because of the limit method. It is limiting the values from the stream object, and it is making a subset. I can say, like, with this number, it will make a subset of objects from the overall stream objects, and it will return again one more new stream object with that subset of values. So we discussed about the limit method now. Fine. Now let's move to the one more operation or one more method with respect to the requirement point of view. For example, now I want to skip first 3 employees and I want to collect other employees data. So what I have to do? So in previous operation, you are collecting first 3, but in the current operation, I want to skip first 3 employee objects. That means the remaining employee objects I have to get instead of 6, 7, 3. So what I have to do now? So same kind of operation. First thing is, so okay, you have employees object, and from that you are creating stream object. Okay, this is common. Fine. Then in earlier case, you used a method called as limit method. Now here, Stream API provided a method called as skip method. So what it is doing, the number what you are passing as part of the argument. So I given 3 here, right? So it is going to exclude 3 employee objects from the list of objects inside string and processes other objects and creates new stream object. So that means first 3 will be skipped, and the remaining, with remaining employee objects, one more stream object will be created with this skip method. So that means, see here, now to list I'm just collecting. So see what is going to happen. 10 employee objects available in the stream, and it is skipping first 3 and collecting the remaining values. Just opposite to the limit method. So whether it is true or not, let's see here now. So here I'm just taking a variable name except first 3 employees. Okay, that is what, right? So let me print it now. So run as Java application. So see here now, you got an employee list, okay, with all the employees except 6, 7, 3, and then it starts from the 8, and you can see all the other 7 employees information other than 6, 7, 3. So if you see here, now the count started from the employee ID 8, 9, 10, and you got all these values. Just opposite to the limit method, skip. So you're just skipping. So is it clear now? So what we discussed now, skip method. So see, now you have to understand the importance of Stream API, how significantly we are writing the code with respect to any operations without writing the regular format of iterating the list of objects, and then we are processing conditional statements. So this is just making a declarative programming. Okay, so now let's take one more method from the Stream API called as any match method. So that means when we are going to use this method, what is the purpose of this method, we will try to understand. For example, assume I have to verify any employee under age 18 years or not. Okay, so that is what my requirement. So what I can do here, with respect to stream operations, employees dot stream. Yes, I'm creating a stream object, and from that stream object, so you can call the terminal method called as any match method. So what it is taking internally an argument predicate. Predicate is nothing but a conditional implementation, and it will return always a boolean value as part of the predicate implementation. So it's a terminal operation. So that means you cannot call one more method on top of any match operation because it is returning finally a boolean value. So here what we have to verify from the stream. So stream will contain employee objects. So that means from each and every employee point of view we are checking employee dot get age less than 18 years. If anyone else is there, then this method will return true. In case no employee available less than 18, then it will return false. Okay, so see here, I'm just taking result boolean is under age. Okay, so let me print it now. This sort of is under age. Okay, so see here, let me execute the program. So what you got false. That means every employee is greater than 18 years of age. So if you observe here, there is no employee with 18. For example, let me make it as 28 years, just as a test case point of view. So I given 28. Now let me execute. You got true. So that means, yes, there are employees whose age is less than 28. Yes, we are already having, if you see here, we have a couple of employees who is having less than the things. So that means the any match method finally producing a boolean result by applying the predicate implementation with respect to stream values. That is all about the any match method, and it is very simple and straightforward method. So now let's take one more method called as all match method. So what is the meaning of all match method? We will try to understand now. So it just like similar to any match, it is somewhat opposite to the any match method also. So for example, let's take a requirement. Okay, how can we satisfy with this all match method? We will try to understand. For example, I want to check every employee joined after 2010 or not. So that means every employee here, I want to check every employee joined after 2010 or not. So that means out of 10 employees, if anyone else is joined before 2010, so then I will get false. In case if every employee is joined after 2010, then I will get true. Okay, that is what the meaning of all match. If any one of the element is going beyond the conditional of all match method, then it will return the false. Every element should satisfy, then only you will get the true. Okay, so let's see how to implement it. Yes, let me create employees from the list. I'm creating the stream object, and from the stream, what is the method, guys? All match method. So here any match means if one value is matching, then simply it is terminating the result and it is providing true value. Here everything should match, then only true. If any one of the value is not matching based on the conditional statement or predicate implementation, so then it will return the false. Okay, let me take, so here stream will contain employee objects internally, and from employee object what we are taking, get joining, year of joining, right? So year of joining should be greater than 2010, right? So this is the statement we are talking here, it is. And what is the result? Again here it is boolean result. Okay, so let me take a return value here, boolean result. Simply I am taking, so what is the result? We will try to verify here, sys out of. Okay, so I'm just passing the result. So please focus on the last line of the output, what we are going to get now. So what you get? False we got. So that means there might be an employee who joined before, okay, 2010 also. So if you see here, anyone else available? 2016? No, 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 no. 2009, because of this employee we got the false. Okay, we got the false. For example, let's do, what I will do here, it is I will make 2011. Okay, so that I'm evaluating one more time same method, and I'm trying to see the result now. So if you see here, again you got the false. So what is the reason? Just verify here, you have 2010. So that means here we taken only after 2010. So but in this case only after 2010. So let me make this one also 2011 now. Okay, so let me execute it, run as Java application. What you got? True. So that means now all the employees joining here is making true based on this implementation. For every employee object, the predicate implementation or the predicate execution became true. So that's why overall results you got it as true. Okay. So now let's move to the next method. What we have to take care, here it is. So now let's take one more method. What we will use on daily basis, here it is. Similar to all match, we have one more method called as none match. It is completely opposite to the all match method. So that means as part of the none match method, the predicate what we are going to implement here it is. So it should not become true for every employee object. So that means everything should become false. Then you will get true result in this case. So it's simply opposite to the all match. When all are matching this implementation, then only you are getting result as true. If any one of them is mismatching, then you are getting false. But in this case, any one is matching, then what you will get? Then you will get false. If anything, no one is matching, then only you will get the true here with respect to none match method. So let's take a requirement here also. Let me give you a requirement. So what we can implement here it is. For example, I would like to check every employee salary is under 10,000 or not. So what I'm going to do here it is C stream dot none match. So what this method is saying, returns whether no elements of the stream matching the provided predicate. So if nothing is matching, then you will get true. If any one of them is matching, at least one element is matching, then you will get false result. Here it is. Let me take none match, and what is the object it contains? Internally employee objects, and employee dot, we are applying predicate on the which column, which property. It's all about the salary property. And what is that? We have to verify every employee under 10,000 or not. So let's see the result. Here it is now. I'm just taking result variable and let me print the result now. So see here, what will happen? Every employee salary less than 10,000. If you taken here, we have every employee salary is greater than 10,000. So see here, what is our expected result now? So what you got, guys? True. So that means yes, every employee salary is greater than 10,000. So that means false for the first employee, second employee false, third employee false, like that. For every 10 employees, it became false. False, 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 false. So false, 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 false. So everything is false. So overall result is true. For example, let me make one value as 9,500. So just to make sure the functionality is breaking or not, it is returning false or not. See now, out of 10 employees, 9 are not matching, but one employee salary is matching with this condition. So that's why if anyone is matching, any value is matching, then you are going to get the result false, right? So it is working as expected. This is how we have to remember. There are three methods. One is any match, all match, none match. So different scenarios, we can use these methods with respect to stream operations. So now let's move to the one more method as part of the stream API. So we have a method called as find any method. So what is the purpose of this find any method? I will try to explain. For example, when you are taking a stream object on top of list of values or a collection of values, I want to take one value from the stream that might be any value. Simply I want to get a value from the stream of elements. So then I have to use find any method. When stream is having one or more than one values, and out of all those values, simply I have to get one value from out of all values. Out of all values from the stream, then I can use the find any method. So in this case, find any will return different cases, different value on top of the stream object we can expect. Okay, different times, different values, because any value, it's not like there is nothing, you are going to get always a specific value from the stream of values. Okay, so see here, what I'm going to do here, it is employees. Yes, I have employees list, and from that I'm creating stream, and I'm calling a method called as find any method. It is also a terminal method. So generally find any method is returning what? Optional of employee object. So why this stream belongs to what? Employee object stream. We are okay, this is employee object stream. So that's why here you are going to get employee stream. For example, if you are getting extracting employee names, and if you are writing find any, then that stream will become string values of the stream, and then find any will return optional type object with string. But in this case it contains employee object, so that's why find any is returning what? Optional of employee type, optional of employee types. So we know that about the optional class. In previous I already made a session about the optional class, how important it is. So to get a value from the optional object, we are having a predefined method called as get method. So what it returns? It returns employee object now. So that is what about the find any method. Okay, so let's see here. I'm printing the employee object, what is written by the find any method. So let me execute now. So it's a very simple. See, if you see here, you got employee 6 information. Here it is. How many objects you got? Only one employee object. So find any will return any of the value from out of all values available inside the string. Okay, fine. So now let's move to the another method called as find first method. Now it is just simple and similar to find any. So what it will return? It will always return first element of the stream, first element of the stream. So that means what is going to happen here it is. So when you are having list of objects, and from that you are creating a stream, right? You are creating a stream, and from that stream, for example, assume this is the one, this is the second employee, third employee, fourth employee. Here you have second, 4, something like 3, 5, 1, something like that. So it will return always which one? First element. So that means it will return always which one, which method? Find first. So here the method is all about the find first method. So it's all about find first method, and it will return always second one. So it's all about first one from the string. But when it comes to find any, what is going to happen? Find any method is going to do what? It may pick up any value. So there is no guarantee which value it will be pick up. We may get this value, or we may get this value, or we may get this value, or we may get this value. But find first is always returns the first value from the string when you are doing, okay, the operations. Here it is. When you are doing the operations, it will always return the first value. So that is the difference between find any and find first methods, and it is being asked in interviews also. So let's see. Now, is it returning the first element of the stream or not? So generally, whatever the order we have as part of the list collection object, based on that, it will take first element in the stream also. So 6, employee 6, right? So let me print it now, whether it is true or not. So here, I'm not writing entire logic, I'm just copy pasting, and I'm using a method called as find first method. What is that method? Find first method. Okay. So I'm just reusing the employee object now. So let me return it now. See here, you got what? Employee 6 as a first one. So that means first element you got, here it is. So that means find any may return first value also, or any other value also, but find first will always return first element of the stream. Okay. So simple, okay, and straightforward. Now similarly, let's move to the other methods. What are popular inside the stream API? We will try to understand now. For example, there is one more method called as sorted method. So it's the most important, or one of the important method out of stream API. It's being asked in most of the interviews with respect to sorting the values or sorting the data of collection values. So sorted methods, the method itself representing, it's all about sorting the data. So what is the purpose of this method is somehow we are going to sort the data. So how we are going to sort the data? Here it is. See here. For example, my requirement here it is, I have to get employee IDs in sorted order. Okay, so if you see here, you have an employee IDs 673 in a, okay, without any order, right? So now I want to make sure 1, 2, 3, 4, something like that in a sorting order, I have to get the employee IDs. So how it is, how can we do that? Let's see here. Okay, for example, what first thing is, yes, again employees object, employees dot create the stream object. It will create stream object with the employee instances. First, what is our requirement? Sorting employee IDs. So here we know that this is all about stream of employee objects. So here map method, that means from the employee objects, what we are trying to do, we are mapping, we are getting employee IDs. From employee object to employee IDs, we are mapping. So that means now this map method will return one more stream object. Guess what it is? Stream of employee ID values. That means the data type is what? Generally employee ID data type. If you see here, integer, right? So it's all about internally the stream will contain integer values. So this is all intermediate method. Now let's call one more terminal method. Okay, what we are discussing? Sorted. Now this, there are two methods available. One is sorted and one is sorted with comparator parameter. So we will see second method. Okay, first let's discuss about this default parameter sorted method. So here what sorted method is returning, just observe here, the return type of sorted method is again stream of integer values. So why integer? Because map is returning already integer stream. So from that internally it is sorting the employee values. So that means before the sorting method, the order is something like this 6 comma, okay, based on this order 6 7 6 comma 7 comma 8 comma 3, something like that. Now after the sorted, what is going to happen? Internally the stream values will become 1 comma 2 comma 3 comma 4 comma 5, like that, until the values will be sorted. Now from this what you can do? Now you can collect the values like as to list, or you can collect the values as a array of values also. So I'm collecting the values as a list. Yes, then what is the list value? You will get list of integer values, right? Sorted employee IDs. So see here, everything is good or not. So here you have to use a different variable name because emp is the variable we already used as a local variable. So that is the purpose we got the compile time error. Here it is. Once a local variable is defined like this, we should not use those variable names again as part of the Lambda expression implementation point of view. Let me print now the sorted employee IDs. Everything you got in the order or not, we will see here now. See, now you got everything in the 1 2 3 4 order. For example, if you don't have sorted method, okay, and let's print the same execution one more time. See, now you got an order in the 6 comma 7 comma 3 comma 8 9, like that, right? So you understood the difference of sorted. Okay, yes, it's just applying the natural sorting with respect to the stream values when we are having. Now let's move to the another method, again sorted only, but with respect to comparator. What it is? With respect to comparator argument. So we have one more sorted method with comparator argument, right? So what is the behavior of this comparator when you have to use this comparator argument as part of the sorted? We will try to understand. So this is also one of the most important topic or interview question with respect to comparator. So see here, what is the requirement we can take and how can we implement this sorted operation with comparator argument. Okay, for example, let's take a requirement like this. So the requirement here it is, define sorting based on employee IDs, sort employee objects. So that means internally, now generally when you are printing the, okay, when you are printing the employee objects from the stream without sorting, you will get in the same order. Thus, okay, the elements in the same order. But what I have to do now in this case, I have to sort the employee objects with respect to employee ID. That means now in the stream level, I mean, once the stream is formed from this list, so what I have to do now, I have to get employee object, this employee object first, and then this one will be second, and this This one will be third. Like that, this time I'm going to get the entire employee objects. But in the previous requirement, we taken what? Only employee IDs. So that means from the employee stream, we extracted employee IDs and on that we applied the sorted. But here, now I should not extract employee IDs. By using employee IDs, I have to sort employee objects itself. I have to sort employee objects itself. So how to do that? Let's see, here it is. First thing is, what is the source? Employees list. Okay, from that you are creating stream object. Okay, yes. Now let's come back to the method, sorted method. Why I am not calling any other map all these things? Because I don't want to map. I want to sort only employee objects based internally with respect to employee ID. So this is the list of objects, right? 1, 2, 3 something, I mean whatever the order it is. From this you are creating again a stream. So assume you are having objects in an order like this: employee 6, employee 7, employee 1, employee 2, employee 10, like that. Assume you are having in a unsorted order. Now what I have to do, these are all what guys? Employee objects. I have to sort the entire employee objects based on the employee ID, and I have to collect finally the result in the sorted order, right? So here also in the list also you have unsorted order. Now when I am collecting the list right now, what I have to do, I have to make sure in the first position first employee object, second position second employee object, third position third employee object, like that. I have to collect a list of employee objects. So this is what the requirement I have to do. So in this case, what we are doing, we are using sorted, okay, and with respect to the comparator argument. So what is the comparator argument? I'll try to give you a small overview now. So let's go to here code. So I'm just calling sorted of comparator. So what is the comparator? Here it is. So I'll give you the overview of comparator. What is the meaning of comparator if you see here? So what is the comparator guys here? If you observe here, what is the comparator? Generally, it's a part of, okay, our java.util package. It is from our previous Java versions also. Generally, comparator we will use for comparing the values. Okay, for comparing the values to come to, okay. So that means most of the times we will use comparator in the sorted operations before Java 8 version also. We have a one abstract method called as compare, and we will try to implement some logic for this abstract method. Now what that means, comparator is also a functional interface. So that means as part of the sorted method, now what you have to provide implementation for this comparator functional interface, and the method is called as compare method. It is going to return internally integer value. Based on that, a sorting operation will be carried out. So please refer the comparator details. Okay, so if you want more knowledge about the comparator. Okay, let me call this sorted with respect to comparator, and internally it contains only one abstract method, and it is taking two values, two method arguments, right? So I'm taking employee 1 comma employee 2. Okay, out of employee 1 comma employee 2, so I'm implementing lambda expression implementation here again. So if you see here, e1 dot, okay, I will do one thing here. Now let's see here how I am implementing. Return e1 dot get, based on what we decided, employee IDs, right? Sorting based on the employee ID. That's why we taken it is. If you taken a based on employee salary or employee's age, then you have to use those values. Here it is. Minus e2 dot get employee ID. So we are just based on this comparison, we are making the values. Now what sorted method will return? Again, a stream of employee objects. That means internally now this stream will be sorted with respect to 1, 2, 3 like that, and again you are going to get one more stream on instance from this operation. So that, and from that what you can do, if you want, you can collect it as a to list also. So you can collect it as a to list. So see here, now what is the values you are going to get? List of employee types. So let me hold the return value. Let me define sorted employee objects. Sorted employee objects. So sys out of sorted employee objects I'm printing. See here now what you got, employee ID 1 and followed by employee 2, and followed by employee 3. So you got in the sorting order based on the comparator implementation. So please refer more about the comparator, the most important with respect to interviews. This is the most favorite topic as part of interviews for so many panels. So please go through it with respect to sorting objects also. So now let's move to the one more method as part of the stream API we will see now. For example, I have to get minimum salary employee details. Out of all the employees, whoever is having minimum salary, those employee details I have to get. So I have to get minimum salary employee the details. So the functionality is what? Minimum of salary of, and that employee details we have to get it. Okay, let's create the employees. From the list we are creating the stream object, and from that stream object let's see what is the method we have, guys. Minimum method, min method with comparator argument. So comparator is again similar to the previous method only. Okay, so based on what? Salary this time, right? So let's implement how we are going to do the min method with respect to salary. Here it is. Okay, so let me do like this. So what you have internally, so comparator is having internally compare method, right? We already saw it. Functional interface, it contains compare method with two argument values, right? So employee 1 comma employee 2, two arguments as per the abstract method. Okay, and I am providing implementation now, like even dot get, what we are worrying, guys, salary, right, minus e2 dot get salary. So based on this, I have provided comparator functional interface implementation with okay, by using Lambda expression. And from this, what you have to do? So what is the minimum method is returning? Optional of employee object, optional of employee objects. So that means from the optional element, from the optional object, if you want to get the actual employee object, so from that optional container object, if you want to get the original employee object, we have to call the get method. Now what get method is doing? Employee information it is returning. So see here, employee minimum salary employee data, right? Let's do here, typecast it to integer, for example, to avoid this problem. So what is the problem? Simply salary is the double value, right? Double minus double, it is returning double value. So but it is return type of compare method is integer method. So that's why it is giving the compile time error, and we typecast it to the integer value, so that no problem. Now let's print it. Who is having less salary? System.out.println. So what you got? You got the minimum salary employee. Who is that person? Employee 6. Who is having 9,500 only. Yes. True or not? See? Well, if you see here, yes, this guy is having only 9,500 salary, and the remaining all people are having more than 9,500 salary. Right? So this is all about the min method with respect to comparator argument. So that's why we have to understand what is comparator compare method very clearly. So please refer one more time. So now let's move to the another method. Similar to minimum method, min method, we have a method called as max also. So if you want to find out max values from the stream elements, so we can use max method. So it is completely similar to min, but opposite to the min functionality, like we are going to get the maximum value out of all the stream elements. Okay, max salary employees, I'm just applying max method. Here it is. So the functionality is same, guys. Internally it will compare employee 1 salary and employee 2 salary, and here now this time it will give priority to the maximum salary employee, and based on that you are going to get finally who is having max salary out of all the employees. You will get that employee details. We are just getting maximum salary employee details. So let me print it. So see here, we got the maximum employee salary or not. So see here, we are getting maximum salary employee or not. We will see. Employee 8 is having salary called as 34,500. So let's see, anyone else is having more than that to represent the functionality is working as expected. So if you see here, there is no other person's salary is greater than 34,500. So in interviews also they will ask you like how to find an employee details who is having maximum salary. okay, or minimum salary. Like that, they will ask the questions. Then you have to write down this kind of implementation. So let's move to the next method. There is one more method available called as average method. Method name itself telling the functionality of this method. So what it is, getting the average of the values. So that means once we are applying average on stream object, then it will provide you the average value out of all the stream elements. Okay, so you know that generally we will calculate average on numeric values, right? So what is the requirement here? It is, for example, to fulfill this method, I will take a requirement like this. I would like to find average salary of employees. So that means out of all the employees, I would like to find out. So what is the average of all the employee salaries? We will find out. So see here, let's take the source, nothing but the original list object, and then you are creating a stream object. Okay, fine. And then from that, what you want to find out? Average of salary of all the employees, right? So let's map first to the salaries from the employee objects. So for that, what I'm using? I'm using a map method. And if you observe here, there are a couple of other map methods also. If you see here, map to long, map to int, map to double, map multi to long, something like that, right? So functionality is almost the same, but only thing is parameters are going to change, depends on the requirements, or sometimes when we are extending the implementations or solutions, we have to use couple of utility methods provided by the stream API. So in this case, for example, I'm taking here. So what it is going to take internally, two double function. So that means similar to function, we do have functional interfaces called as two double function. It is going to deal only with the double values. So I'm just taking this. That means this is one more method I can call map to double, but it is functionality similar to map method only. So what it is going to do, it is going to take employee object. So you know that functionality of function functional interface, right? So it will take input value and it will give a return value always. So from this, what I'm going to get? I'm going to get salary, because salary is a double value. That's why I taken map to double here. So now it will produce all these salary values again as what? A stream of the objects. So that means now one more stream is created. Once this method will be executed, a stream will be created with the values of salary, right? So yes, see, double stream salary. So what is this double stream? Yes. So similar to stream, we have couple of other stream interfaces called as into stream, double stream, like that. We will see one small example related to other stream interfaces what we have along with the stream. Simply, now this is representing, okay, the stream will always contains only double values. So that is what about the double stream here it is. So now from this, we are going to get average of the salary. See here, I'm calling out average method and it is returning optional double. So we do have categorized optional classes related to double and other data types along with the generic optional class. Okay. So here what I'm doing, I'm just calling get as double. So that means it is going to return always as a double value, this method. That is what the meaning here it is. Okay, so here let me take it as employee. So see here, average double average salary. So let me see the result. If you see here, you got the overall average salary of all the employees. So what we learned now, newly the map to double method. We are extracting all double values and finally you are getting double stream, right? Similarly, we do have other methods called as map to int and one more is map to long. So that means we are going to map values to the respective integer and long stream values. So if you see here, we have double stream, int stream, long stream, right? So that is what, when you are using map to double, you will get double stream result. If when you are using map to int, then you will get return value as integer stream. When you are using map to long, then you are going to get long stream. So specific to these three data types, specific stream objects we have. When you have other data type values, then definitely we have to use this map method and you will get any kind of return value and you are going to take stream with respect to the data type values. So now it's all clear, right? So whenever you want to map from, okay, one type of data to and other type of data, or you want to extract the values, and if it is belongs to the integer, then you can take map to int. And if it belongs to the long data type, that means the return value becoming whether it is a long data type, then you can go with the map to long in this place. So here salary is double data type, so that's why I used map to double. In case if it is map integer value, then I can take integer like that. Okay, so if you want to find out average age of employees, then what you can do, simply map to integer employee hyphen, so employee representing the overall employee object, from that you are extracting employee age, and finally you can call the average method. Okay, so I'm just reusing the logic, and what I want here, get age, right? So age, so what we are trying to find, average age of employees, right? So age, and what you are going to get, age you are going to get always, average you are going to get always in the double value, that's why you got here. So you are getting always optional double, so that means average method will always return double, optional double data type. So from that you will always get a double value, because we know that average will always provide the decimal values. So let's see here now, double average age. So if you are taking here, sorry, I forgot to take here, right? Average map to int. So right, it is what? Integer value. As part of this mapping, we are getting integer value from the employee object. So what it will return, see here, int stream. So that means similar to stream only, but only thing is this stream will allow, or the stream contains only integer values, not any other data type values. Similar to double stream, double it will allow only stream with double values or contains double values. Here it will contain only integer values. Now from that, if you are calling the again average method, so it is going to return optional double, and you are going to get result as a double value. So I can take now double, okay, average age. Okay, let me print it now. See here now, let I got result what? You got 29.9 here. Okay, so this is how we can use map to double, map to int, and map to long along with the regular map methods. Map to int, map to long, map to double will work only with the data type of long, integer, and double respectively. So I'm not taking example for map to long because it is similar to these methods only. Now let's move to the another method which are being popular again as part of the Stream API. So now as part of Stream API, we have a method called as peak method, and this is a special method as part of Stream API, and we have an interview questions around peak method also. So what is the importance of peak method? What is the functionality of peak method inside the Stream API? We will try to understand now. So if you see, first of all, the definition of the peak method, okay, employees dot stream. I will just show you what is the definition given by the Stream API for the peak method. So what exactly it is? See here, peak method is taking method argument of consumer type, and what it is going to do, returns a stream consisting of the elements of the stream, additionally performing the provided action each on each element, okay, are consumed from the resulting stream, so that means, for example, assume this is what a stream object which contains employee objects, right? So it is a stream object, internally it contains employee elements, and from this employee type stream, whenever I am doing any other operations on the employees type stream object, I will get resulted stream objects, right? For example, if I'm done map operation on this stream and I'm collecting all employee IDs, then what will happen? Map will produce from employee object to employee ID values. Again, a new stream will be created with employee IDs, right? But now, as part of process, from one stream operation to another stream operation, okay, what is being processing, and at the same time every value has to be, okay, involved as part of some. So that means here the peak method is simply saying like it is going to perform an activity Okay, it is going to performing an action on each element, what is received by this stream and what you are processing to the next operation, okay, from the stream. So it will perform an action on each and every value, and then the respective operation will be done, and the respective operation functionality will be executed. So this will be repeated for each and every element available in the source stream instance here. So that means what is going to happen here, it is, if you see here, for example, I have a requirement like this: find out who are joined after 2015. I have to find those employee objects. So in this case, that means first is what we will have, guys, we will have a list of objects, right? So these are all objects inside the list, and from this we are creating a stream. So here we are creating a stream, and internally again it will contain all employee objects. So from this stream, now I am applying an intermediate operation called as filter. Okay, like greater than 2015. The joining is year is greater than 2015. I have to get, right. Call a terminal operation called as toList. Finally, I'll get the list of employee objects who joined after 2015, right. But now in this overall process, so here how many objects we have? 10 employee objects. So here how many we will get? Probably less than 10 or 10, right? So it might be 0 also, 10 to 0. So it is all, there is a chance you are going to get 0 to 10. In worst case it is 0, or maybe maximum 10 values you will get as part of here it is, in case if everyone joined after 2015, right? So now I want to trace here, I want to perform some action. On each element. I have to perform some action, okay, and then I have to process that element to the next filter operation. So that means when this element is processing by this, okay, before filter method, so I have to take that element and I have to do some action on that element, okay, as part of consumer implementation available inside the peak method. And then again I will process same element to the filter method. So that means here what is happening, you are doing an action on the element, but we are not managing or manipulating this object, and we are passing that object as it is to the next filter method. So like that every element will, okay, do same action, second element do the action and process it to the filter. Now third element came, perform the action and pass it to the filter method. Similarly, fourth element, perform the action and pass it to the filter method. So like that, in between any stream operations, when you want to perform an action, and that action will not impact the actual stream object or the stream elements, when you are processing with other consecutive operations, stream operations. So let's see here. So generally that's why peak method will be used in the most of the cases as part of tracing. You can do the trace or you can perform an action. So any other actions on the element, every stream element. But this process will be repeated for every element, like, okay, take the element, perform action, process it to the filter. Take the element, perform action, and then process that element to the filter. Like that, for every element, same process will be repeated. So in between any operations, if you want to perform an action without impacting the source and resulted streams, then you can use the peak method. So let's see a requirement here and how can we implement it. So now my requirement here it is, out of all employees, I have to find whose date of joining is greater than 2015. Okay, those employee details I want. Okay, and at the same time I have to track, okay, how many employees are processed. I need this track also, how many employees being processed. So see here what I will do. First, list object, you created stream, and then from that I'm creating a peak method. Okay, as part of peak, what is the implementation we have to provide? Consumer functional interface implementation. So consumer will take a input, but it will not return any value, right? So what I'm doing, I'm just printing all the values system dot out dot println. Okay, so that means whatever the elements available inside the stream, okay, it has to be printed before processing to the filter method. So that is what my idea here it is. Okay, filter and predicate is all about what? So this is contains what? Employee objects, right? So that's why employee hyphen employee dot what we were looking for, get data year of joining, and those should be greater than 2015, right? And then I have to collect those list of employees. So in this case, what peak method will do, we will try to understand. So let me do one thing, list of employees, employee details, something like that. Okay, so let me print it now, sys out of employee details. Okay, so here I'll write down a line separator to differentiate peak methods. So see here, let me execute the applications and observe what's happening. So if you see here, from here the method execution started, right? So what's happened now? Stream with 10 employee objects, and yes, first employee 6, employee 7, employee 7, employee 3, like that it is processed. Okay, all the, so that means it is very clearly saying from the stream, first employee object given to the filter, second employee from the stream, second employee object given to this filter, like that you given the values. Now for example, see here, I'm taking peak method from here to here, then what will happen? Guess. Now in this case, you will have how many employee objects? 10 employee objects. Okay, the stream contains 10 employee objects. But in this case, now once you are doing this operation, how many employees you will get? So probably either 0 or 10, 0 to 10, right? 0 to 10 objects. And maybe whatever the result you got after this filter with respect to employee method, employee objects of stream, okay, and I want to see finally what are the values being finalized and what are the values being terminated, what are the result I'm making as a list, converting as a list, I have to see. So that means in such case, what is the value processing from the stream object, okay, and processing to the toList method, those values will be printed now. So see here, it is printed 6 and 9. Why? Because from the out of the 10 employees, we have 2 employees, okay, joined greater than 2050. So then, okay, who is that? 6 comma 8. So now it is saying like from the filter, it is having 2 employees. Those are all, okay. Who are those employees? 6 comma 8. So 6 record is passing 6th employee object processor to the toList. That is what done by the peak method. So that means every value of the stream result before passing to the another operation, okay, we intermediately we are performing an action, or maybe we are doing some kind of tracing implementation and what are the values being processed from one operation to another operation. So it will be repeated for every element. That's why you can see this time too. In earlier case you saw when we applied peak method here 10 times every employee object is printed with different employee objects. So this is how we will use the peak method. Okay, peak method will take internally argument as a consumer. Consumer will not return any return value. So that's why we will not write any filter conditions or mapping conditions with respect to peak, because finally it will not return any value. That's why you should not use. So what peak method will return? So peak will return the element, one by one element from the attached source stream object and processing to the next stream, next operation. So that is all about the peak method. Now let's move to the another method called as, so this is all about the methods as part of the stream API. So we are covered almost every method including intermediate and terminal operation. We do have a couple of other methods also somewhat related with one class called as collectors class, and I will discuss that right now. Okay, so before moving to the collectors class and collect method or something, there is a method called as reduce also. Before moving to that, I would like to give you one more point. Here it is. Generally, as of now, we created stream instance from the list n number of times. In the same operations class itself, probably we have created stream instance everywhere, right? Employees.stream, employees.stream, employee.stream. So that means in this case, whenever we created method called as stream method, right? So whenever we are calling a method called as stream method, what is going to happen here? It is internally it is creating a sequential stream object. So that means sequential means, you know, right? One by one value. One by one values will be processed by the processor or internally. That means when I have a list of objects here, and from this list of objects I created this stream. So whenever you created a stream, what will happen here? It is the values will be available inside this stream, like object 1, object 2, object 3, object 4, object 5, object 6, like that. And whenever you are performing any operation on this stream, now any operation is performing on the stream, what will happen? The operations will process the elements one by one. So that means first the operation will applied on this one, and then second this one. Okay, a single thread kind of, okay, a single process is working like that. So first process this element, and then second, and then third, and then fourth, and then 5, like that the operations will be carried out, okay, in a sequential manner. That is what the sequential stream. But at the same time, stream API provided one more way to create this stream object, that is called as parallel stream. What it is, guys? It is all about parallel stream. So that means whenever from the list of objects we can create stream object in two ways. By, okay, one is sequential stream and the second one is parallel stream. So by default, whenever we are calling dot stream method, so what is that method? We are calling dot stream method, right? So I mean, sorry, it is all about stream method. Now similarly, we have one more method called as parallel stream method. What is that method? Parallel stream method we have. So if you are calling parallel stream method, internally the stream object will be created in parallel stream. So in previous case, it is returning sequential stream. So that means by default, you will always get sequential stream when you are calling stream method. Now, but when you are calling parallel stream, you are going to get parallel stream object. So now, what is the difference between sequential versus parallel now? Okay, now for example, if you created sequential stream or parallel stream, then what is going to happen here? It is, so as part of sequential stream, this is going to happen. The elements inside the stream will be processed one by one. This is stream, right? So whenever you are doing any operations, one by one value will be processed in sequential manner. It will follow an order. Okay, but when you are calling parallel stream, I mean that means when you have created stream with parallel stream method and you created parallel stream object, what is going to happen internally here? It is as part of the stream internally whatever created. Okay, assume this is a stream you created, right? So here the objects you will have. Now internally they are going to segregate your stream into multiple, okay, sections, and one by one, okay, process internally we computer processors will have some cores. Okay, so simply I can say, like, assume like this way. Okay, a thread is operating on this stream and one more thread is operating on this and one more thread is operating on this. So that means now if I am calling any operation like filter method, okay, or map method, what is going to happen? Thread 1 will perform filter on these values on its own. Okay, on its own the filter will be executed. That means the operation. Similarly, thread 2 parallelly, that means thread 1 is started its process. Now parallelly thread 2 is also processing its status. So that means the same operation is being done by the thread 2 on this set of elements available inside the stream. So this is what? Stream, right? So that means parallelly the thread 2 is processing its operation. Similarly, thread 3 will start its execution on the operation of this section. So that means what is the final thing here? It is when you created parallel stream object, internally the multi-core processors will start executing, or the stream will be divided into multiple sections, and each and every section is processed by each and every multi-core process, or we can consider it as a thread also. Then parallelly threads will start executing same operation on stream elements. So then which one is better option, whether it is a stream or parallel stream? So here stream may take some time when it comes to the performance point of view. Stream will take some extra time when comparing with the parallel stream, because stream is all about processing one by one value sequentially, like this. But parallel stream is all about processing values based on the operation parallelly by dividing into multiple sections and by using multiple processes, right? Then parallel stream will take very less time to perform the operations when comparing with the sequential stream. Okay, if you see here, employees, so from employees, I'm creating which this time parallel stream. So when you are creating an object with parallel stream, what is going to happen internally? It will create parallel stream object. But what is the difference between which one we have to choose here? It is parallel stream sometimes may not guarantee the order of processing the elements, but sequential stream will guarantee the order of elements processing internally available inside the stream object. So that's why most of the cases people will try to use sequential stream to do any operations instead of parallel stream. But in case if you want, you are not worrying about the order of the elements being processed or whatever it is, then even we can utilize parallel stream, so that parallel stream will take very less amount of time to do all the operations on stream pipeline, whatever you concatenated consequently. When comparing with the sequential stream, it will take less time. So let's take a small example with respect to parallel stream. So whatever the methods or operations we discussed till now, like with respect to the above all methods, terminal or intermediate methods, are similar applicable for this parallel stream also. Only thing is internally multiple processes will work on the same stream object by dividing into multiple sections. Parallelly elements will be processed by dividing into small groups. So that's why it is being called as parallel stream. So what I will do here, I am not taking anything. So I will implement the above, just this functionality with parallel stream. If you see here, what I will do, so here let me write down sys out of parallel stream. Now I will write down this logic as it is, but only thing is I'll call parallel stream method. So here instead of stream, what we are calling this time, parallel stream. Okay, so if you see here, there is nothing changed. I am processing parallel stream. So here now we will observe the difference between the order of elements processed from the stream in this operation, sequential as well as parallel point of view. We will try to understand right now. So here I used parallel stream. Now if you see here, peak method point of view, you got an order 6, 7, 3, 8, 9, 10 like that, right? So if you go to the actual source of list object, what is the order? 6, 7, 3, 8, 9, 10 to something like, right? So that means sequential stream will follow same structure internally. I mean, when you created stream instance from the list, internally, okay, stream is also maintaining the same order as part of the list. But when it comes to the parallel stream, see, there is no guarantee of the order. Okay, that is what I told you, right? So it is processor 2, it is processor 10. So there is no guarantee which order you are going to get. And then 3 and then 5. So okay, 2, 10, 3, 5, right? So let me execute one more time. So see here, 2, 10, 5 this time you got. There is nothing like 3. So there is no guarantee of order. But in this case, every time you got same order. Okay, so this is all about the parallel stream. So you can create a stream object into two ways. One is sequential and second one is parallel stream. So if you are calling stream method, it will create internally sequential stream. One by one value will be processed by the operations. If you are calling parallel stream method, then internally it will create parallel stream, and whenever you are performing any intermediate operations or terminal operations, internally multi processes will start processing your stream elements parallelly by dividing into small group of elements. So this is all about the parallel stream method to create the stream instance. Okay, total two ways we can create. One is either sequential stream or parallel stream we can create. So now let's move to the the most important method called as collect method from the stream API. Before knowing specialization, like we have a class called as collectors class. Okay, this class will be specifically used as part of this collect method inside the stream operations. So, and this class is also introduced from the JDK 8 onwards to support, I can say, like stream API operations. So that means we should know first of all little bit about the collectors class, and then only we can understand the collect method. This collectors class is giving a lot of utility functionalities with respect to data operations on stream instance. Collect will comes under the terminal operation, and what we are going to do with the collect method, and internal it is involving collectors class, and what collectors class is providing, we will try to have some examples right now. Okay, so now let's take discussion about the collectors class. So generally collectors class is a simple utility class provided utility functionalities or utility use cases what we will use daily basis in our application programming to collect a values from the stream instance, or to accumulate values from the stream instance to any collection type values or aggregated functionalities, or maybe grouping functionality or summarizing functionality point of view. The collectors class is provided by the Java language. So that means as part of the collectors class, we have a lot of collector methods, and each and every method is going to represent one kind of functionality. So what we can do with the stream elements. So that means whenever we have a stream and whenever we want to accumulate the stream elements with respect to a collection object, then we can use a method called as toList method from the collectors class. Like that, we do have some other functionalities like averaging functionalities, summarizing functionalities based on the all stream elements, or we want to group the stream elements based on a property. So all these use cases or utility cases are provided as part of the collectors class as a static methods inside the collectors class. So if you want to see here, the definition of collectors class is all about what they are saying. So it's just like a implementation of various useful operations such as accumulating elements into collections, summarizing, and according to the different various use cases and criteria. So a couple of examples they are saying as part of the collectors in class itself. So this is a collectors class, final class, and it is also introduced from Java 8 onwards only as part of stream API introduction. If see here what they are explaining about the collectors class, they are also saying like when you are having, so couple of use cases they take in here, it is accumulate names into a list. So that means assume you are having a list of tuple objects, and from that you created stream on instance and you got only names from that tuple object, and then you are making a new list with that names what you are mapping from object to name, and every name value is finally mapping to the list. I mean you are collecting everything as a list of values, like what we did in earlier functionality. Instead of using collect, now we have a shortcut method directly called as toList collect method. So this is also one more approach. So if you want to accumulate names into tree set, yes, map to the names and collect values as collectors.toCollection, and as a tree set object you want to collect all these values. Here as a list you are collecting all these values. So what you are doing here, you are calling a method called as collect terminal method, and inside that you are using collectors implementation as an argument, and you are calling all the static methods of the collectors. Depends on the criteria, depends on the functionality. If you see one more use case they are taking, like convert all the strings and concatenate them with separated by comma. So that means from all the string values, for example you have objects, you created stream and you are mapping all the string values, and then you are collecting all the string values concatenated by the comma. That means finally you are going to get a full length string which is concatenated with all the string values with comma symbol. So like that you do have other use cases here also. So we will see a couple of use cases in our employee objects right now with respect to collectors class and collect method. So simple, collectors is a simple utility class or provided utility methods to fulfill lot of common use cases. If you go here, collectors class is having a lot of predefined utility methods. What it is? Averaging to double. So that means all the values will be averaging to the double. Similarly, averaging to the integer value, averaging to the long value. The count. What is the count of the stream elements? Like that. Grouping by. So we will see functionality right now about the grouping. Joining. So what you are going to join. So joining with some char sequence. Right now we have an example, right? So separated by comma symbol like that. So whatever the symbol you want to separate, and you can join all the string elements, something like that. So max by, minimum by, so summing into, summarizing. So these are all methods. If you see here, toList, toMap, toSet. When you want to accumulate values as a list, toList. If it is set, toSet. If it is map you want to accumulate, then you have to form a map from the stream elements, then you can use toMap method also. So let's see here what you are going to do now with couple of methods inside the collect method by using collectors class. So let me implement couple of requirements. For example, collect all employees names whose age is greater than 25. So I have to collect this one. So simply we know that, right? First you will have collections object, that means employees dot create the stream object, and from that filter the employees who is having age greater than 25. Employee dot get age whose age is greater than 25, those employee details you want, and from that map, and what you are collecting, their names. You are collecting name, right? And here what is the requirement? Collect all employee names whose age is greater than 25. Collect all employee names as a list, as a list. Okay, this is the requirement, right? Now I can use collect method here. Okay, and from the collect method we are going to use always, most of the times, the class called as collectors. And if you see from the collectors class, a predefined method toList, right? So toList we are using. Now what it is going to give you? It is going to give list of string values, because you are mapping finally to the string values and everything is collected as a list. Employee names, right? So let me print it, sys out of names. See here. So you got all the employee names or not? Yes, we got respective employees whose age is greater than 25. But this is the approach from Java 8 onwards. But in Java 16, even they simplified this operation. They given direct method called as toList also. So like we discussed in the previous example, we can directly take toList also. Okay. So it's all about our comfort or what Java version you are using. If you are using Java 16 or greater than, then you can directly use the toList. If it is below Java 16, if you are working for Java 8 and 11, then you have to go with this approach only. Directly calling toList will not work out, because I am going with the Java 17 as part of this tutorial. Fine. So this is how you are going to use the collect terminal method. So it is a collect is what? A terminal operation only. Please remember that. And collectors is a utility class providing utility methods, all static methods. Okay. In such a way, we can simply wrap the result based on our requirement. Okay. Let me take one more requirement and then we will try to use collect method and collectors class also. So my requirement here it is get unique department names. Okay, what I have to do. So from the employees object I have to get the unique department name. So see here employees dot stream, first create the stream object, and from that what you have to do, map the department. First of all, identify what are the departments available, employee and department, right? So from the departments, what you can do, you can make the distinct. This is one way, right? So it will pick up all the distinct values, and then you can call something like toList, all these things, or else, for example. So that is what, guys, it's all depends on the scenario analysis, our skill set, what kind of solutions we are using. So sometimes same problem will have multiple solutions. So instead of distinct and collecting as a toList, for example, if I take in collectors dot to set, what I've just connected as a set. So what is the set nature? Set will not allow duplicate values, right? So that means Now what it is going to return, if you see here, collect method is returning, the terminal method is returning set of string values. So this is also you can write down instead of distinct and tooling. So if you see here, departments, sorry, it's all about set. Okay, let me print it now. So see the departments, what are the departments available from the employee objects. We got all these details. So we have sales, finance, and as well as infrastructure, HR, and security we have, right? So we have all these departments. So this is how the collectors class is helping us to accumulate the results from the streams, and we are wrapping the stream operation or stream pipeline with the result. Okay. So I will take a couple of other methods also, which are more popular as part of the collectors class. So for example, I'll take one method with respect to map also. So for example, I'll collect employee IDs and their salaries. So that means my requirement is here it is what guys, I have to collect employee ID as a key and their respective salaries. As a hash map I have to collect employee IDs and their salaries as a map. So what I have to do? First thing is, yes, go to the employees list object and from that create the stream. Okay, then it will create employee stream, and then from that what you can do, you have to take the collect method and now see here collectors dot to map. So what is that? To map method. So map will contain always two values, right? Key comma value pair combination. So for that so here you have to pass two values, and one is collectors dot and one is what is that you would like to collect employee dot, here I am using simply method references, or you can directly write down employee dot get also. So lambda expression notation also. Here what is that? ID, right? Get employee ID. So instead of lambda expression notation, I'm simply writing method references. So please refer method references also one more time to understand all these functionalities, and it is very important. I already made a session about method references also. So here, and what is the next? Employee colon method reference, and what is the values you are collecting? Salary. Get salary, right? So that's all. Now see what is the return type of collect. It's all about map integer comma double. So why dynamic it is map integer comma double? Because employee ID is an integer data type, salary is a double data type. That's why it created map with these data types. Okay, employee ID and salaries. Okay, import the map. Okay, so let me print it now. So we got all the respective IDs and salaries are not. We are trying to understand now. So see here, employee 1 25,000, 2 13,500, 3 18,000, like that. Every employee ID and their respective salaries we got as a key value pairs, and we collected it as a map. So this is how the collect method is making our life very simple from the stream of elements. Okay, so let me take one more method also. So the most important here it is grouping by method. What it is? Grouping by. So what is the meaning of grouping by? So somehow group by functionalities. It's all about group by functionality, like how we will have in our SQL language also, right? So we have a group by functionality, right? Same kind of here also. I want to calculate the average age of all male employees. I want to collect all female employees average salary. So here I am grouping based on the gender, right? These are all the examples. So in such cases, you can use the grouping by method also. Okay, grouping by method from where? From the collectors class. The methods what we are discussing is completely from the collectors class, and that we are being used inside the collect method. Okay, now let's see a requirement to utilize this grouping by method also. So my requirement is get average salary of each department wise. I want average salary. So then what I have to do? First, the actual list object, and from that create the stream object. It will create employee stream objects. From that, what you have to do? Collect. So here somehow we have to use the grouping by method, right? So how to use it? We will see now. So if you see here, collectors dot grouping by. Okay, you have a lot of overloaded methods from the grouping by method. So you have something like function and as well as collector, supplier, implementation. So I'm just trying to take example for one of the grouping by method to achieve this. requirement. So what you want guys here, okay, let me do one thing, let me close here. So here you have to implement the grouping by functionality. What you have to group? You have to group the department, and based on that you have to make the calculate the average salary. So what you have to do group? So what you are going to grouping here, employee, based on the department wise you are grouping, and what you want again from that grouping, you want, see here again I am using the collectors method to make it as averaging. If you see here, averaging double, averaging integer, averaging long. Now what you are trying to averaging from the employee object, you are averaging what? Get salary. So now that means what is the point here? It is grouping by method is saying like group the values based on the department, and which values? Salary values, and find out the averaging. Find out the average of all these values based on the department. Now see what is the return type of collect method? Map of string comma double. So why this is return type? Because string is all about department name. Double is all about average salary of each and every department. So here average salary department wise, right? That is what you got these details. So see how Stream API is making, now just realize the importance of Stream API, how it is making simplified solutions when comparing with the regular old solutions. Like for example, if you want to achieve same requirement before Java 8, what we have to do? This list we have to iterate with for loop, and then we will write down if conditions. Okay, while iterating each and every employee object, we will try to get all departments and their respective salaries. Once we are identifying all those things, we will do some average calculation, right? So we will identify the count of salaries and we will make, okay, average count, average salary, and we will again create one more hash map object, and irrespective to the department name, we will set that average value. So this is all the logic implementation manually we have to implement, and it will take longer time and it will take longer lines also, right? But now here it is just like utilize the existing features, or just like fill in the blanks way they provided the solutions with respect to Stream API. So that's why Stream API got more popular from the Java 8 features. And to understand the Stream API, we should know all other Java 8 features. So to achieve Stream API understanding, definitely we should know other Java 8 features as a prerequisite. Default methods, static methods inside the interfaces, as well as constructor references, method references, functional interfaces, Lambda expressions. Together, all these are helping to understand our Stream API. Now let me print the values, average salaries, run as Java application. If you see here, you got all the employees, all the salaries related to the department wise. Average salaries of every department. Sales, you got the average salary. Finance department, yes. Development department, yes. Infrastructure, HR, security point of view. So these are all questions being asked in interviews, guys. They will simply ask you, can you get department wise average salary? Okay. Or department wise total salary. So like that, they will ask. If it is total, then if you see here summarizing into double, so whatever, you just use it. This is all about the importance of grouping by method. Now I will take one more method called as count inside the collectors class. So when we have to use count as part of the collectors, or just one use case we will try to understand now. For example, get count of employees gender wise. So I would like to see how many female employees available, how many male employees available, count I want. So it's a very simple now also. Employees dot stream, yes, we created the stream object, and from that I want to collect gender wise, right? So you have to collect, and here, okay, let me make it as colon here as a terminal method, but inside the collect method argument I am using collectors dot grouping by. Why you are using grouping by? Why are you using grouping by now? Because we have to group gender wise, and then we have to find out the count. Same, right? So that's why what it is, first you have to group based on the employee gender, right? You have to make sure gender wise grouping, and then what you have to group, what you have to find, count based on the gender. So now let's see here, collectors dot counting, collectors dot counting method. That's all. It's done now. Based on the gender wise, you will get the counting also. So what it will return again? Map, because grouping by means it is grouping based on this and providing this value. So that means key value pairs. So grouping by internally returns map functionality. So that's why you will see now again a map object with string comma long. Long means the count value. So here count of employees gender wise. So if you are trying to understand the Stream API very logically, it's very simple, guys. Please take care of couple of practices, then you can easily understand Stream API and we can easily operate with the Stream operation. So let me execute now. So if you see here, female 5 employees are there, male 5 employees are there. I got the count. So this is also one of the most popular interview question involving collection topic, Stream API topic, as well as collect method and collectors class also. So these are all classes they will ask, and it is one of the most popular interview question. So now I'll take one more also. I have methods like summing, okay, summing based on double, summing int, summing long, like that, as well as summarizing double int long, like that. I have a couple of methods. So we will try to understand what is the meaning of summing, summarizing with respect to one, okay, data type method, and you can practice same thing with other data types also. Okay, so what is the real difference between summing and summarizing is we will try to understand. So first let's take what is going to happen here. I'm directly writing this time inside the system.out.println employees, okay, dot stream, okay, dot collect, okay, from that internally collectors dot summing. So first I'm taking summing. Okay, if you see here summing double, summing int, summing long, and what I would like to sum here it is, for example, I would like to sum all the salaries. What it is, employee, for every employee salary I would like to sum it. So I'm just taking summing double here because I'm going to sum the overall employee salary. So here my requirement is summing all employees salaries. Summing all employees salaries is the requirement, right? So based on that, I'm taking summing double. Why I taken double? I'm summing, I'm just adding all the double values because salary is a double data type we defined inside the employee class. So that's why I have to take, here it is, employee colon. So what is that? Salary. So when whatever that argument you are taking here, that data, that based on that you have to take this. Okay, so salary. Now let me print it. What is going to happen? Are you going to get the entire sum of the salaries or not? See here, you got all the employees sum of the salaries like 2,16,007. Okay, it is just summing all the values. For example, you have a group of values, integer values or long values or double values, and you want to find out sum of all the values. Then simply you can use summing double. But what is the summarizing? Here it is. Let's understand. If you are using summarizing method, in the summing method point of view, what is going to happen? See here, summarizing double. Okay, in place of summing, I used summarizing double. Now understand the difference between summing and summarizing, how it is going to differentiate. Okay, it's all about summing, it's all about summarizing, right? Let me execute now the actual difference between summing and summarizing. What if it is summing? What you got, guys? A single double value by making sum of all these salaries. But when it comes to summarizing, generally what is the meaning of summarizing? Summary is all about the highlights or the overall statistics point of view, right? So now it is giving internally what is being happened, okay, like how many employee salaries are being calculated. That means some adding, how many employee salaries are being added one to one internally. All the summary details it is provided. If you see here double summary, so that means it is saying total 10 employees are there, okay, and it got some values. So if out of 10 employees, okay, their salaries is all about 20, sum is 21,000, this one 2,16,000 and 1,700, right? That is what you got in earlier case also. But here summary statics means it is giving summary, so that means summing value as well as whose salary is minimum salary and whose salary is maximum salary, and what is the maximum value, and what is the average value. So that means when you have to go with the summarizing method, when you want to get all the information at a time, like min value, max value, average value, and sum value, then you can use the summarizing method. If you want only sum value, okay, out of all the values, then you can go with the summing method. You got the point? It is just providing summary, that is nothing but it is giving four values internally as an object, double summary statistics. It is giving count of the values, how many okay elements available inside the stream, and mean how many values processed, and what is the total values, what is the minimum value, what is the maximum value, and what is the average of all the values also you got based on this summarizing double. See how it is very simplifying our programming style, or how we are making the logic implementation. So now let's see one more method as part of the collectors class. That is all about max by method I am taking. Okay, so one of the method we are being used in our project. So what is the meaning of max by method from the collectors? So the name itself telling it's all about maximum value, right? So see here, I am finding max age of employees. So that means from out of all employees, I'm trying to find the max age employee. So see here what I'm doing, employees dot stream, create the object, stream object, and from that collect. Now what is the method we are using? Collectors dot max by, right? So internally what it is using? Comparator. So we have to provide the comparator implementation like what we discussed in previous min or max methods. Okay, when we are applying on the min or max methods as a terminal methods in previous case, right? So it is now in this space you can directly use min also, or you can use directly max also. So this is again, if you see here the max method, so this is the max method, right? So here also you are providing the comparator. These are all being added latest. Okay, we can use those methods also, or we can go with the collectors, collect method and collectors also. So it's up to our choice. Okay, I'm just taking an example with collectors only, right? Max by. So what you have to provide? Comparator. You know that, right? What is the comparator implementation? Two method arguments. It will take employee object 1 comma employee object 2, employee 1 comma employee 2, and from that what you have to do? You have to make sure their ages, right? E1 dot get age, right? Minus E2 dot get age. So internally it will process all employees age and it will sort internally. Finally you will get the maximum age employee details. This is way you can write down. Now what is that? You are going to get result optional of employee. So if you want you can write down dot get method here itself, so that you will get directly employee object. Okay, so please go through the comparator, it's most important. Now employee max age employee. So let me print it now to verify. So what you got, employee 6 is having more. Okay, employee 6 is having max age out of all the employees. So you got one employee details, right? So or you can directly use, instead of collect method, min max methods also, like what we discussed in previous cases as a terminal methods. So those are all given as a shortcut methods in the recent Java versions, but at one point of time we used to use collect and followed by the collectors min by max by, like that. So now let's move to the one more method as part of the collectors called as joining. So the name itself telling we are going to join some values. So for example, let's see, I want to get all department names with the delimiter means separator, delimiter 3 columns I have taken, with the delimiter 3 columns. So what I have to do, see here. So that is what, if you are good with one, if you are practically good or you are able to understand the previous operations, it's all about almost common what we are doing in anywhere else. Okay, stream dot collect, and as part of the collect, what we are trying to do, collectors dot joining. So right, joining. So what you are trying to join here, the department names, right? So what you have to collect, joining department names you have to collect. So but that means Before that, what you have to do? You have to get the department names. So that's why I'm writing mapping. So first I'm mapping from the employee to, that means I can directly take, okay, like this method references also in this case. What it is? Get departments, right? And from that you are collecting each and every department name and you have to join. You have to joining with char sequence of delimiter. If you have a prefix suffix also, okay, you can add some prefix word and suffix word, then also it will base for every value it will add a prefix, it will add a suffix, and internal it will add a delimiter also. If you are using joining, what will happen? So simply the department names will be joined without any delimiter, without any space, something like that. Okay, 1 2 3 something like that you will get. So if you have a delimiter, so then you have to provide the delimiter. Here it is. So what is the my delimiter? Here it is. It's all about 3 colons I have given, right? So let's see here. Now I'm going to get all the department names with this delimiter or not. Okay, so what you are going to get? Again, a string value. You are getting a string value. String all departments. Let me print it now. See here, you got security department, finance department, and everything is separated by the delimiter called as 3 colons, right? So now this is what about the collectors class, and we do have couple of other methods, but these are all popular methods and those other methods also similar to these all methods only. So please refer the other methods, almost copy paste or same similar to these methods implementation only. So this is all about the collectors class and we are using as part of the collect method. So collect is a terminal operation. We will use collect method to accumulate stream values into respective required result type like collection, summarizing the values, okay, grouping the values based on the properties. So all utility use cases being covered by the collectors class. So that developers can straightforwardly we can use these features. We don't need to write down again a manual logic to achieve all these functionalities. This is all about the Stream API operations. Before winding up the Stream API session, so here what you have to remember here it is, first thing is what you have to practice here it is what is a stream object, how to create stream object, and then you should know what is intermediate operations and what is terminal operations, how we are joining intermediate operations and followed by terminal operation. Okay, in which order the operations are getting executed as part of the stream pipeline. So these are all things you have to remember. Along with that, you have to remember the collect method. In collect method is having a special utility class called as collectors class, and collectors is providing lot of utility methods to wind up the results from the stream instances. So see here, we made almost lot of operations with respect to list of employees. We implemented a lot of requirements, but when it comes to the source code, okay, precisely very less amount of code we written, like around 200 to 300 lines, right? But we implemented almost around 30 use cases. But if you want to achieve same use cases with respect to old approach of Java programming, like until Java 7, hopefully it will take another 400-500 lines of code also. Okay, so that means it is just like declarative programming, and it is encouraging us to make the declarative programming. Internally it is encouraging or involving what kind of concepts, guys? 100% functional interfaces and Lambda expressions and method references, as well as default methods, static methods inside the interfaces, and it is forcing us to utilize or use the optional class also. So that's all about the Stream API. Let's connect with the next session. I'm going to make a next session interview questions as part of the Java 8 futures. I will make an interview questions series, which are first thing is giving priority to the Java 8 futures, because this is the most important futures and being asked in interviews, and as well as we are using in daily basis in our day-to-day programming also. So thanks to everyone. So please let me know what are the sessions you are expecting, and I will try to make those sessions. So please share and subscribe so that I can reach out to more people and I can start making more sessions. Thanks to everyone.